to apply data science with Python by Simplilearn. Let's start with a quick question. Have you ever wondered how companies predict what products you will like or how search engines gives you exactly what you're looking for? That's all data science at work. And guess what? Python is the tool that makes it all happen. In this course, we are going to explore how Python helps us handle data, make sense of it, and even turn it into something useful. We'll focus on 3 key tools: NumPy, Pandas, and Matplotlib. Don't worry if these sounds new to you, we'll break them down step by step. Here's what we will cover in today's video. First, we'll dive into NumPy, where you'll learn how to create and manipulate arrays. You'll also cover how to do all sorts of calculations like finding averages, medians, and more, basically making your data do whatever you want it to do. Next, you'll also get hands-on with Pandas. You'll discover how to clean up messy data, handle missing values, and transform data so it's ready for analysis. You'll also talk about turning text into numbers, which is super important when you're working with data. Then we'll talk about Matplotlib. This is where the fun happens. You'll learn how to turn all the data into cool visualizations like charts and graphs. You'll see how visualizing data can help make better decisions. Along the way, you'll also talk about the real-world data science process, how to figure out what problem you're solving, how to explore and understand your data, and how to use the right tools to get results. By the end of this course, you'll be comfortable using Python to handle data, clean it, analyze it, and even show it off with visuals. Whether you're just starting or looking to sharpen your skills, we have got you all covered. So let's get started to unlock the power of data with Python. Before we commence, if you're interested in mastering the future of technology, the Professional Certificate course in Generative AI and Machine Learning is the perfect opportunity for you. Offered in collaboration with E&ICT Academy, IIT Kanpur, this 11-month live and interactive program provides hands-on expertise in cutting-edge areas like generative AI, machine learning, and tools such as ChatGPT, DALL-E, and also Hugging Face. You'll gain practical experience through 15+ projects, integrated labs, and live masterclasses delivered by esteemed IIT Kanpur faculty. Alongside earning a prestigious certificate from IIT Kanpur, you'll receive official Microsoft badges for Azure AI courses and career support through Simplilearn's Job Assist program. Hurry up and enroll now. Find the course in the description box below and in the pinned comments. Here's a simple quiz question for you. What does Pandas help you do in data science? Is it to visualize data, clean and organize data, create machine learning models, or is it to build websites? Let us know your answers in the comment section below.
Next, we'll talk about the concepts about the data science part. What is data science? What is the process and so on. Again, that's the first page, right, that I have as a part of thing. So a fundamental definition that we go through with it is the use of scientific methods, processes, and algorithms to derive meaningful insights from the data. That is the idea behind it. I will not go through with that, right? I will not talk about this. What I'll try to talk about is to think of a real world scenario. I am giving you guys a scenario. Can you everybody, I hope so everybody can see my screen. On my screen, can you see there is a bulb? Yes or no? Great. Thank you, Gilbert. Thank you, Preeti. Now that's data for me. I'm giving you this data. This is the data. It's a visual data, right? It's a visual data. Now, think yourself as a person who is a data scientist, right? Who is a data scientist at some bulb manufacturing company, right? Some bulb manufacturing organization, right? You're a data scientist at a bulb manufacturing organization. You're walking out of your house and you saw this bulb. You're walking out of your house, going to work. Imagine you're going to work and this bulb was there into the next house or maybe somewhere on the road. You found out this particular, or somewhere on the pathway, you found out this particular bulb there. Great. Hypothetical situation, but thinking process. This is the most important part for a data scientist, for an AI engineer. Is the most important part is the thinking process. How do we think about it? Now, think about what you can recommend as data scientist, considering this particular bulb as an input, right? This is the input to you. Think about that. Okay, you may not know what is data scientist roles, but whatever your understanding of data scientist based upon that, right? Or AI engineer course, right? Whatever your course enrolled into. What is your approach towards a business proposition about this particular information that you have that you can recommend to your, let's say, the to the management over there? Maybe you can tell them, okay, I saw that bulb on the street and I have so many so and so recommendations for you. Anything that you would like to talk about, or let's talk about what you can tell me about this bulb. Let's say, how will you draw insightful information about the data? Can you tell me about this bulb? Just information, no decision making, just about the bulb. Tell me what else information you can give me. I'm okay with that. You say that if the bulb is yellow, that is also an information. It's a screw based bulb, not a click and lock method. Its brightness level, okay. Bulb dimensions, great. What else? See, I'm looking forward towards something. Power consumptions, great. Materials used, wattage, great. Lights when connected power, okay, that should be, a basic property, Preeti, yeah, but it's still good. Anything else? See, I want you guys to observe things. Take your time, observe, because whenever you are saying, let me just try to tell you, I have too many options came up. Like Abhinetri says, brightness level. Is it observable from the given image? The bulb dimension, Gilbert, is it observable? Is it available on the given data? The power consumption, Narendra says that, wattage, or the material used, lights when connected power, how many watts, is that available with the given data? Can you actually find it out from the given information? Ajay Shri, what is that? Sairam is coming up to caution validation required before green. On top, some black dot is there. Yeah, what does that implement? E27 bulb holder, agreed, Devashish. It is an object. It is an object, okay? Any object, right? Good. So I tend to, closely follow the observation from Sairam. The kind of inference that you might require to take it up is something which is unusual, right? Something which is unusual, because as a data scientist or as an AI engineer, everybody knows, right? I know, you can see the options coming from 10 different peoples in the chat window as well. Someone is talking about, wattage, powers, luminosity, and so on and so forth, right? But something different, something that makes you unique, something that is no one else is able to observe, and that has some meaning. So Sairam talked about there is a black dot on the top. What do you recommend? What is the reason behind it, or what would be the implication? It's a filament bulb. Great. It's a filament used in the bulb. It's a tungsten bulb. Great. So one observation, which is directly not available, but it is hidden. None of the bulb manufacturer label, that's not available, right, Gilbert? But what I can observe, let me just put it across. What I want to convey to you guys is, right, with this particular image. See here, I can see that there is a black dot on the top, right? It's a black dot on the top. That black dot tells me that whatever the outer covering is, right, of this bulb, that outer covering is getting blackened out. That means the intensity of the power inside the bulb is such high that it is turning out the features outside, or the outer body is black. And if that is happening, that means it has to be usually a tungsten bulb. That's number one. It's a tungsten bulb. Second thing, this does not happen over a day. This does not happen over a day. It happens over a long period of time. That also tells me it's a very old bulb, isn't it? Do we agree? Thank you. And if it is a very old bulb, as business perspective, I can think of incandescent bulbs, for example. Yeah, similarly, it's a very old bulb. Now, I can think of an alternative bulb. I can think of, as a business proposition, I can think of an alternative bulb that does not give the black structure, gives me better, life, or maybe something like that. It's not using tungsten technology, maybe using some other technology like light emitting diodes. Could have been any other solutions, right? Which will offer a better or cheaper options. Make sense? Now, why did I discuss about this bulbs for so long? The only reason I wanted to talk about is not the bulb, but the approach. Make sense? See, I can go on with this theoretical presentation for a long period, not a problem. But the point is, this is not what we're here to learn. You can go through with this presentation 10 number of times. You will have access to this presentation. So I will not concentrate more on to the presentation part, but what we need to do in real world, I'll try to concentrate more on that. Is that okay with everyone? Right? Presentation is something that you guys can read through 10 number of times, right? And most of the slides are self-explanatory on this. So what did you learn from here? That whenever you're getting a data, whenever you're going to work around with the data, you do not look for things which are obvious, right? You need to look for things which are not obvious, isn't it? Now, in order to find out those things, you require certain kind of methodology. Here it was easy for us, right? Because we can see that pictorially. There is a picture available, and I can see that part. I can see that shine. There is a slight little curvature onto that too. I can use that too for some informative purpose. Like it's in a background where there is too much light. That's why I have that shiny part or shiny curve on the top. That means there's a background light reflecting on that particular bulb. Right? So understand this part, that it is not about that what is given already in the data. It's not important because everybody can see that. What is important is what is hidden in the data. Is that okay? Thank you. Hopefully. Thank you, Gilbert. Okay, so moving on. Now I have some basic things to talk about. Very quickly walk you through with that. So the process of data science, it's a kind of process where I would require a lot of information, right? I need to know about the domain. I need to know about the scientific methods and technologies. Three important things, right? Now, domain is something that you may or may not be aware about at any point of time. For example, let's say if I talk about when I started my career as a data scientist, I was coming from a financial background. I was working in State Bank of India prior to that. So I came up from a BFSI background, banking and financial institutions. So my core expertise was on finance. But if you talk about over the period of time, what kind of projects that I've dealt with, I've dealt with the financial, non-financial, pharmaceutical, I've aviation, different kinds of projects that I've dealt with. So subject expertise is not something that you will have in all sections ever. this is something that you will acquire project wise, right? You would have to do the hard work to read about the project, read about the domain, understand the domain, acquire knowledge about the domain. That is what you need to do, right? When it comes to the scientific methodologies, right, that you need to do. So scientific methodologies are the mathematical tools and the scientific tools that we have, right? So I'll talk about that during this course. What are the scientific methodologies that you need to require to be a data scientist or an AI engineer? We'll talk about those mathematical and scientific concepts that are used in the real world. We'll talk about that during this course. As a part of technology, we require a machine and a programming language. Two things, right? A machine and a programming language to implement these things. Good. So I have a programming language like Python. I can use that. There are other languages as well which allow you to do that. Then operating systems, data processing tools. Again, we'll talk about the Python language slightly, data processing tools, the libraries, the application design. We'll talk about all those things during this particular course. So that's your upcoming portion. Are we good? Keep on asking questions. Some of the applications of data science processes is being given up here. One of the data science process application is the biometric sensing of the data, right? You wear up a wristwatch or the what you call it as a smartwatch. It counts up your steps, it counts up your heartbeats, and talks about the real-time information about that. I can use that information and take out some decision-making process and make some contribution decisions. Let's say suppose my wrist or my this particular smartwatch detects that my blood pressure is going beyond 200, right? My blood pressure is going beyond 200. There is no movement in my body. It can be detected. Now, would be possibility that I'm suffering from a cardiac arrest, or I'm suffering from hyper blood pressure. So I might require immediate emergency services help. My Android device or my whatever Apple device or whatsoever it may be, right? My smart device can make up an emergency call to the emergency services and send my location. If it can send my location, emergency services can arrive at me and take necessary care, right? Without any human intervention, we can still deal with these things, right? So useful interactions that can happen. Another example of data science is the search recommendations. So recommendation systems, not in this course, but in the next course, machine learning, we'll talk about that. How does the recommendation system feature works? We'll talk about that. But recommendations that you might have observed on Google platform, you write down typing something and it starts, showing up, okay, this is what people have searched for, or this is what is the possible next word. So next word recommendation, right? Suppose I want to write down, maybe you might have seen in how many have seen that, okay, while you're writing a mail, right, it tells you, if you write on hello, it automatically shows you sir or madam and so on. It asks you to press tab to select that option. Automatic recommendations of certain words, completing a line, completing a paragraph. Seen that before? Expecting yes. Yeah, thank you. So that is coming not from just any kind of software, it's just a data science process, the recommendation systems. Similarly, your loan applications, right? Credit card applications or loan applications, they say that you'll get an approval in 2 minutes. Who's going to look after that application in 2 minutes? No one. It's a backend machine. Looks at your credit report, looks at your history, looks at your application status and everything, and makes up an informed decision based upon that data, right? You'll study about how does the decision making process happens in ML course, machine learning course, right? You'll study about that. But as of now, you can understand that this is an application of data science. There can be a lot of applications, right? Any field that you think of, there is an application. Any particular field you want to put up an example? Any specific field you think that I should put up the example with? I can put that example, no problems. But ask it. Any specific field. For example, let's say you apply on a job portal for a job. You think that my job, that my qualifications are exactly what is being required for a particular job. You still do not get a call. Thank you very much, Abhinitri. See, this was theoretical portion, so I was not expecting too many questions with this part so far, but I just want to follow the process. So this is the entire process that we have, right, in the field of data science, right? Now, in this, there is few things, right? First thing is problem definition. Problem definition is a kind of a problem statement that is given to us, right? A client will come to your organization or to you to tell you that, okay, this is the particular problem that I'm facing. Suppose only one particular soap is not getting a high sales, or the sales values are very low for that. Why is that happening? No, you need to answer as a data scientist or an AI engineer, what is the problem, what is the possible cause of the problem, and how we can rectify that problem, right? So once we know the problem, based upon that problem, we ask the client to provide the data, right? The data acquisition happens. Now, what is the skill set that is required for data collection? Anybody? I'll only talk about the skill set. As a part of data collection, usually what happens is a client will tell you, okay, these are my database servers. I have kept my entire transactions data or whatever the things that we have. I've kept in particular database. These are the login credentials that you will have. Take out these login credentials and fetch the data from there. Sensible? So we should be aware about how to fetch data from different database servers. Now, as a data science, if you talk about end-to-end process, people will seek those kind of things. If you talk about small or marginal organizations, very small organizations, they think of person who can do end-to-end job. But in bigger organization or mid-level organizations, they have a separate team who does the ETL portion. We call it as extract data and transform and load it back. And then we have a different set of data scientists. But in general, the skill set that is commonly expected is structured query language, SQL. Not a part of this course. We will not talk about SQL at all. That's a separate course altogether. You may have that as an optional topic, but you should know about structured query language, if not in detail, but slightly about it. Are we good? So that is where we collect the data. Either we'll do that through databases or we'll roll out Google Forms. You see that there was a Google form rolled out to you at the beginning of the session, isn't it? What was the purpose behind it? Yeah, there is one purpose that I get to know about you guys, but there is another purpose that there's a data collection process that is happening in the background of Simplilearn. They get to know, those or whatever the data scientist team that is working in the background for Simplilearn. They will get to know, okay, what kind of learners are joining in, what they know about, which industries, and so on and so forth. A lot of conclusions can be made out of this. A lot of business decisions can be taken out of that. Are we good? So data collection is not just with the SQL. It can be directly from the end users. It can be directly through online resources. You can extract it from web pages. You can just walk through with the web pages, and you can use that. Maybe there is another library that you can use for data collection is BS4, beautiful soup. That is a web scraping library, but that's not our objective. We're not going to talk about these two portions, the problem definition and data collection. Why? Because we are going to go with the standard problem statement. There is a standard problem statement that will be given to you, and there is a standard data, right, which is in the format of CSV. It is in the comma separated value format. So what I'm expecting is you will have a data set, you will have a problem statement, and then we'll start working. Are we good? You will get the problem statement. Maybe I'll address it live in the session. The data set, if it is available into your standard practice data sets, it is available into your LMS. Otherwise, if I will use some additional data sets, I will share it with you guys. Okay, if I would require any one of those. So our learning for this particular course will be limited to this part only, the part 2 and part 3. We'll get to know how do we clean the data, how do we explore the data, and how do we perform the feature engineering part. So this is the basic thing that we'll do here, right? In between, there is a lot of things. How do we clean and explore the data? Exploration is the major part, right? Because we need to make a lot of decisions about the data while doing the exploration. Some part of model building is also, part of this particular thing, right? We'll discuss into that part, but we'll not actually build the model. Maybe if time permits, I'll try to see some one or two models to be built up, right? But this part is not part of your curriculum. Model evaluation and model deployment, we will not discuss that at all. This is a part of your machine learning section, right? Next course, machine learning. These three topics, 5, 6, 7. So essentially, the entire 9 sessions are dedicated to this particular portion only. Now, how important is that? Is you can understand this. Suppose if there is a project, let's say there is a project of data science that talks about a particular problem, and the time span given is 6 months to complete that project, for example. Out of those 6 months, you can imagine at least 4 months will only be spent on this part. At least 4 months. It can go up to 5 as well. This is very, very critical factor, because how good we clean the data and how good we manipulate the data, that makes the next stage, which is the model building, more robust, more efficient. So that is one of the very critical factor in the field of data science or machine learning or artificial intelligence. How is the data being prepared? So data preparation is a really important topic, and that is what we're going to learn through this course. Are we good? Okay. Python for data science, preferred programming language across the industries, have some advantages and disadvantages. We'll not talk about that. What are the important packages? NumPy is one of the important packages. We'll discuss that in detail. Pandas is the second topic. SciPy, we'll discuss that shortly for some period. Then stats model will come into the picture as well. We'll talk about scikit-learn, not too much in detail, but slightly about scikit-learn as well, wherein I'll talk about what is scikit-learn, and some features of scikit-learn will come into the feature engineering course. Matplotlib will discuss in detail. Seaborn will discuss in detail. Plotlib will come with the questions. Okay, with the Plotlib. This is a types of plots with the examples which is given into the presentation. Wherein what is a line plot? Connect two dots and join them with a straight line, that becomes a line plot. A marker plot, highlight those dots and that becomes a marker plot. So you can see your dot, 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 dot. See, that becomes a marker. Then there's a scatter plot, which is typically used for the purpose of analyzing relationship between two data points, right? We'll discuss all these plots in detail. This is just for your reference to know about these words. That's it. Then you have this area plot, that is also called as a stack plot. Area plot and stack plot are same thing, and it talks about cumulative changes between certain data, right? We like see why I'm trying to rush through with this is because I need to talk about this, how these are created and what kind of meaning they take up at a later stage as well. So I do not want to put up time here just to talk, if I give you the details right now and then later on again same problem arises. So I need to talk about how they are created and how we will use them. We'll do that. All these graphs that I'm talking about. Bar plots again talks about frequencies of the things, how many things are appearing how many times. Grid plots, drawing of that grids. Histogram, another plot, very important plot that talks about the frequency distribution. Pie chart again talks about the frequency distribution. That's it. What is data exploration? Will we be diving into the specifics in a subsequent session? Yes, definitely. In the data exploration part, we will talk about a lot of things. Preeti. There will be a lot of things as a part of data exploration. Essentially, when I'll try to start working with the Pandas library, right? When I start working with the data Pandas library, I'll tell you how to reach out to particular data, why to reach out to a particular data, what inferences you are going to make out from a particular data, and how will you deal with them. Every kind of possible scenarios, the different sort of data sets, I will try to include that. Whatever the possible situations that you may come up across in a real world scenario, up to a certain limit, right? Because I have limited number of data sets that I can talk about. But yes, I will talk about data exploration. Essentially, that will be the most longest thing that we will have highest, longest thing after the mathematics portion. The maximum time will go on to mathematics, but next thing that will be data exploration. Otherwise, I just need to talk about syntaxes, right? Suppose what is numpy, what is numpy syntaxes, what is an array. So basic concepts, right? So that will be a syntactical thing where I'll talk about syntax and tell you, okay, this is how the things are designed in Python. We need to follow the very strict Pythonic way. That is one thing. I'll tell you this is what is supposed to be done. That is fixed. But when and why is something I'll let you know. Good. All right. So what I will do here is I am currently using Anaconda, tool, which you can do it by this way. You can go on to anaconda.org download.success. I have shown that link, and you can download your requisite installation. If you're using a Mac machine, just in case if you're using a Mac machine, you can go onto the Mac link and find out the downloader here, either for Silicon. Intel chip is not available there. Why, I'm not sure. But Apple Silicon graphical, Apple Silicon command line is Intel chip is also should be available, right? So if there is any concern with that, let me know. Otherwise, you can get it from this. This is a local installation. That means that allows you to create files locally on your machine, use your local hardware, and work on the local manner. But typically, you can also use, a, a cloud-based hardware, and that is what you can use with the Colab. So you can search for colab.research.google.com. Once you go onto that page, that should appear up with something like this if you're already signed into your Google account. If not, it will not appear up that way. But you can click on the new notebook option and you will come across with this kind of scenario. My Office laptop is VS Code install extension of Jupyter. I am okay with that, Sitish. I'm okay with if you do not have to install that extension and you're putting up a path for Python. Uh, Kotin, yes, Simplilearn does offer a lab. You can use that, but what will happen is in a later on courses, like when you will use start machine learning or deep learning, some later courses, Simplilearn lab is going to be not available. And I do not recommend people doing the Simplilearn lab. See, I am working for Simplilearn, but I do not recommend it. Why? Because there is a reason behind it. The reason is because some of the libraries in that particular field are not current. They are slightly older one. They're not updated. And hence what happens is certain functionalities will not work in a proper way, or they will work, but they will not offer you this solution that you should expect out of it. Right. So I do not generally recommend people using Simplilearn. That's the final, ultimate thing that I tell people. Okay, if you cannot do anything, go with the labs. Very simple thing. I write down that piece of code into my cell block over there, and I can execute that by clicking on that play button. It gets executed. I am not going to use Colab in general. I will be using the locally installed Jupyter Lab environment. So I'll show the same piece of code on the local Jupyter Lab. Here it goes. So I opened up Jupyter Lab and I have clicked on this sheet and I can write down that print, same piece of code. And I'm putting up my name. This is going to be faster for me. Right? It works. Hopefully 1, 2, 3. It does not. Why till now? Taking too long. Something is wrong with my machine. Maybe I'm acquiring too much of it. Done. Great. So anybody and everybody, give that a try. Can you just pick out that print statement and see if you're able to execute that? either in Colab, either in your environment, whichever you are preferring. I'm okay with that. But just make sure that you are able to get the codes executed. Great, Abhinetri. So we'll start talking about the first library, and that will be your first file, which I'm going to rename over there, numpy. And I'll put up that is for your Jan, or rather, this is your EDSP batch for January, EDSP B1, that's batch 1 for Jan 26 or January, that's fine. Rename. Great. So let's start talking about numpy. So what is numpy? So NumPy is essentially a framework or library, one of the very basic or base library that is available in Python, or that's a part of Python, which is used for numerical computation, primarily used for numerical computation. So NumPy is a library of Python which is used, something from Sairam. Yes, sir, I'm telling you, which is NumPy is a library of Python which is used primarily for numerical computation. The word numpy is coming from numerical Python. So numerical, that's fine. Numerical Python. So I've just highlighted those characters in uppercase. Right. So essentially, the idea behind the numpy was that I wanted to make sure that I can use the mathematical concepts of Python in an efficient manner. Right. It brings in, what does it brings? It brings the concept of, it brings in a new data structure, a data structure that is array. Now, do we know what is the data structure? Anybody? Not data types. It is a data structure. Now, data type and a data structure are slightly different in nature, Narendra. Collective data of different types, not even of array is not of different types. A data sets are not even a data set either. So when I talk about a data structure, a data structure actually defines the arrangement of data, defines the arrangement of data in the memory. Let's try to understand that through a conceptual or graphical manner. Very simple thing, but I'll try to put that into a graphical manner. Suppose it's your birthday. Possible? Anybody's having birthday in the month of January? Oh, January is finished. February in the house? Suppose it's your birthday. Now there is a locality, right? There is a locality where 5 of your friends are living. Good. There are 5 friends of yours. Suppose this is the entry gate of that locality. This is your friend 1's house. This is your friend 2's house. Right? This is your friend 3 house. This is your friend 4 house. And this is your friend 5 house. Now, the problem is that you know where is friend 1. So you can reach out to friend 1, give him the invite. Friend 1 knows where friend 2 lives. Friend 2 knows where friend 3 lives. Friend 3 knows where friend 4 lives. And friend 4 knows where friend 5 lives. Good. Now, if you think about this process, it is going to take up some time for you to go around with all the friends' houses and distribute the invites. Yes or no? As compared to, when I ask you the comparison, if it is the situation like this, that you have a friend 1, you know where is friend 1, but the friend 2, 3, 4, and 5, they are living adjacent. You know that friend 1 lives at a particular place, you will go up to the friend 1, and then next house is of friend 2, then 3, then 4, then 5. Now definitely you will take up less time in this scenario, isn't it? Thank you. So that is what array offers. So array is a arrangement of data into the computer's memory in a contiguous manner. Contiguous means in a single chunk. So whenever data is arranged, right? So what is an array? That is what numpy offers. An array, which is referred as nd array. The word that is used in Python is nd array, right? We use the word nd array in Python. So referred as nd array is a contiguous memory allocation of the data of same type. Now, idea is that every information will be of similar nature and it will be arranged in a contiguous manner. Contiguous means that one after the other. It will not be scattered around in the memory, but it will be together in single chunk. Sensible? Not sensible? Yes, no, maybe. So you need to ask questions. No, every time when I start with NumPy and I say that it is used for numerical computation, people say that Python has its own module for numerical computations like math. Then why do we require NumPy? So that's the next basic question. That is, why NumPy? Why NumPy? So what is the NumPy? Because of the use of the arrays, and its functionalities. Right? Its functionalities. NumPy offers much faster execution. That means it is intended to be very, very fast. Good. That is the only reason I require NumPy. Then the core Python. Let's try to look at something. Now, first of all, before I begin with this, how many of you know what is an import statement? Import keyword. Anybody have ever used import keyword before? Yes, no, maybe. Yes, Naresh. Yes, Gilbert. Great. Yes. Yeah, for importing. Yes, to use the library. Thank you very much. So almost everybody knows it. Hoping so. Now, considering that, I'm going to import few things now in front of you, right? I'm going to import a library that is called as import. I'm going to import, just correct that, it's raw, we get code. Let's import time. One of the library, which is the default library to the Python, which is time library. I'm going to use that library. Why I want to use that library is because I want to showcase something. Great. What I want to show is this. If I just talk about time is a library that I'm using, dot time, and I'll try to print it up. Let's print what is the time function is going to give me. Now it gives me a epoch time. What does it tells me? It prints the epoch time at execution, right? What is an epoch time? Somebody help me. Present time, no. Unix time, yes. But what essentially that means? Unix time, Narendra. So epoch time, if I talk about, is the time that is elapsed in seconds since January the 1st, Jan 01, 1970. Right? So that is called as an epoch time. Right? Epoch is another word that is used alternatively as Unix time or Linux time. Essentially, that was the period when Unix was introduced and the clocks were reset to be standardized for a standard reference. So it was kind of something of that we follow in the computer science fraternity to keep a hold of time as a fixed things across everyone in the entire globe, because time is something which is varies across the globe. Every geographical location. I am currently right now. It's almost like 11 in the morning or early afternoon. You can say that 11 a.m. is the timeline for me. Some of you would be at different time zones, isn't it? For some of you, it might be early evening. For some of you, it might be the early afternoon, maybe late afternoon. Some of them, right? Isn't it? Depending on the time zones that we follow. So in order to standardize that, we use a particular timeline on the machines, and that is we call as the epoch time or Unix time or Linux time. Great. Now, what is the advantage over there? Now, since I have executed this particular statement, right, there is some time elapsed, isn't it? Let me just try to copy the same statement again, paste it back again. Good. And execute. Can you notice that there is a difference in the two outcomes? Right. 17698364891. 17698366649. Or essentially, if I can say that, between that two executions, right? There was 159.5690 seconds elapsed. This is the difference between the execution time, right? Two statements I have used, and I have tried to showcase the difference between the time of execution. Are we good? Now I'm going to utilize this. For what purpose? The purpose is to tell you why numpy. Good? Great. Yes, no, maybe. Now, I'm going to use out a data structure over there just to showcase this part, which you will learn about in due course in upcoming time, maybe today itself or tomorrow. That is going to come up, right? But I'll start talking about this part, right? And that is a random thing. So I'm going to create an array. The idea is to let's create an array of random data. Create an array of random data, right? So how will I do that? Since I am using that, you can use that in syntax for yourself. As of now, do not put into your brain for this. Just think of that as a syntax, okay? And I am expecting everyone is going to do that for me, right? I'm going to create an import library, import numpy as numpy. Numpy, I'm going to put that as a name np. What it essentially means that I am importing the numpy library with an alias name np. Thank you very much, Narendra. And now I'm going to create up a data. So let's say data is equal to np dot random dot rand, and I'm going to use let's say 1 2 3 4 5 6 7 8 zeros. So what I want to do it is to ask my numpy to generate random values of what nature? Of rand nature. Now rand means random floating point numbers between the range 0 to 1. We'll discuss that rand function later on. I'll do that. But as of now, consider I have a floating point numbers, which are decimal point notation numbers that will be between the range of 0 to 1. Good. I'll have that many numbers. Good. It generates that data. Good. The data is now generated. Now, if I ask you that I want to calculate the average of this, a very simple thing, right? There are that many number of data points. That's 10, 100,000, 10,000, 100,000, 1,000,000. So that is approximately 1 billion. Good. 1 billion numbers. If I want to calculate the average of those 1 billion numbers, how will I do that? I need the summation of all those. Agreed? What is an average? Take the sum of all numbers, right? Divide by the count of numbers. Is that okay? That's average. So let's take a sum. Sum is equal to, or let's say, I'll define that average is equal to whatever the data that I have. So I'll take up the summation of that. Sum of AVG, that is going to give me the sum of, not AVG, but DATA. I'm taking that sum divided by the count of, but the count is not available, the length of DATA. Good. Ln of DATA is going to give you the same data. If you just, let me just show you that number, right? Same number. So I'll calculate the average over there with this function. Good. Now, I'll try to do what? I'll try to note down the time. So I'll take up a start time that is equal to time.time. So that is going to capture the time that is elapsed since epoch before the execution of this statement. Good. And then I'll copy the same thing and I'll put it down below and I'll put that as a word stop and I'll write down time.time again. So stop is going to capture the time immediately after the execution. Agreed? Thank you. Let's try to display what is the time taken. So can I put a print time taken is equal to, and I'm putting that as the stop time minus the start time. Correct? Everybody okay with this till now? Thank you. I'll execute that for you. It's going to take some time. Let's see how much time it takes up. It is going to be machine dependent. My machine will take some time, your machine might take some different time, but it takes me 12.69 seconds. The difference that I got is 12.6994, so approximately 13 seconds. You can say that. Good. Now, I'll copy the same piece of code, right? No changes at all, apart from how I am going to calculate the average. I'm changing the process of calculating the average. Instead of using the, the traditional approach, I'm going to use a numpy library approach. I will ask np.mean. Now, that's a numpy function to calculate average of a data, and I can put up that I want an average of this data, which is by the name data. Good. And look at the time. Time taken 0.42. Do you notice the difference? Right now, some of you guys, I'm not expecting all of you, but some of you are going to tell me how much time on your machine it took up without numpy and with numpy. Some of you will tell me. That will confirm that everybody is doing along with me or not. This is just for that purpose, nothing else. Because what I'm expecting is that you guys will do along with me. I have not yet started with numpy. I'm still trying to, talk about the advantages of numpy and so on. No one? And no from Asif. I'll wait. I have time. No problems. I'll wait. But I want you guys to practice. And I insist, guys, give that a try. If you're feeling not comfortable with the code, I will, show up whatever maximum possible. Maybe you might require this line as well. Paste up the results, Akshay, the time before it took up and time after. So Rosie, it took up 0.01301 and 0.00. So potentially Rosie is having either a very good machine or she's using Google Colab. She or he is using Google Colab. I'm not pretty much sure. I cannot capture with the first name. Is it a he or a she? Sorry for that. Now that can be pronounced as a Rosie and it can also be pronounced as Rosé. So slight confusion. Not a problem. I am not gender biased. Anything. I'm okay with that. But good. Potentially, what I can inference from that is either you have a very good machine or you're using Google Colab servers. If I'm not wrong, can you confirm? Again, data start off with length 10. Preeti has tried to use servers slightly. Utilize these things, but yeah, you can still notice the difference in the time, isn't it? Right? You have used a small chunk of data, that is why the time taken has not too much of difference, but there is a difference, right? So essentially what happens is because of the numpy functionality, right, I can use or I can perform tasks in a faster manner as compared to the traditional approach. And that is why people prefer using numpy and not using the functions, not using the default or core functions or core Python part. Core Python is good. We need to use certain things from core Python. It's great. But yet, you would require libraries to do work with this. Now, does anybody require help installing NumPy onto the machine, especially to the people who are using VS Code and not able to extract NumPy? Anybody not able to execute any of the piece of codes that I have discussed so far? So suggest some system for data science, Akshay. Typically, that's difficult to gather for me. What kind of system that you're looking for? Thank you very much, Narendra. On that part, we've installed NumPy. Minimum requirement. See, there is even if you have a very basic machine, right? You have a basic machine that allows you to browse internet over any period of time. Not a problem. What you want, I want you guys to have a good browser, right? And you can still use Google Colab. I'm not saying that you need to have a locally installed software, not necessarily. You can use the cloud softwares. The point is, we need to be a little bit more, conscious with them because they lose out on the data. I need to keep a local copy of those data. So a simple average machine, where any simple average machine, let's say you can have 4 gigabytes of RAM with any simple processor. I'm okay with that. But make sure you have a good internet speed, right? If I talk about my machine right now, I'm working on currently on 200 megabytes, 200 Mbps connection right now. And that's the maximum available in my area. If I would have some more options, I would have gone with that. So good internet speed works well, provided you have an average machine, which is good enough to play, videos, watch out anything. I'm okay with that. So nothing specific from my end, a minimum requirement, but yes, something that you can have that allows you to do a proper without lag functionality. I'm okay with that. 2 gigabytes of RAM is also fine with me. I'm okay with that, provided your browser works well. Good, great. Now comes the first aspect, that is the array. Now, before I move on to the arrays, can someone tell me the list? Anybody heard about the word list before? List in Python? No, great. Okay, heard about linked list in other languages? Now, data structure. An ordered mutable collection that stores multiple values in one variable. Thank you, Satish. So essentially, understand the idea. Python offers a data structure. Data structure is an arrangement, right? It offers a data structure which is called as a list. Now, list can contain any type of value, right? I can have an integer value. I can have a floating point value. I can have I can have a string. I can have any Boolean type of data. The point is, when the list works, what does it do? It tries to store your data into the memory. Now, it does not store that into a contiguous manner. Right? It will try to store integer value somewhere, a floating value somewhere else, another value somewhere else. Now, whatever the combination, it can be, continuous. It may be continuously together. It may not be together. It varies machine to machine, right? Wherever the memory is available, a list will store all data points accordingly. Now, however, the arrays allows me to store the same information in a contiguous manner. That means that essentially, if I have 4 or 5 or 10 number of values, array will allow me to store the data in a contiguous manner. It's like this. I have 1, 2.4, let's say letter A and true. But there is a catch. The catch is with list every individual element, right, of that data structure will keep its data type. That means if something is integer, that will remain integer. If something is floating, that will remain floating. If something is string, it will remain string. And something is a Boolean value, it will remain Boolean. However, with the arrays, the data type changes. That means it is going to be throughout the array, every element is of same data type. Every element of the array is of same data type. Are we good? Thank you. So, what is an array? So, an array, I've given you the definition earlier too. An array is a contiguous arranged data in memory, right? A contiguously arranged data. That's a simple array. NumPy has array by the name on that on NumPy addresses. Let me just put that up. Addresses arrays as the name, and the name is ND array, which refers to n-dimensional array, What is the idea behind it? So the arrays could be in multiple number of dimensions. When I say dimensions, what does it mean? It means that suppose I have a single line of data. It can be horizontal, it can be vertical, does not make a difference. I call that as 1D, one dimensional. If I have a table like this, I have rows and I have columns, right? Like this. I'll say that as two dimensional. If I have a three-dimensional data, like I have rows and columns like this, behind that I have another layer, like just like you can say that a Rubik's cube, right? You can think of a Rubik's cube or any three-dimensional object, right? So if the data is arranged in that format, I'll say that as a three-dimensional data. Or hypothetically, you can think of 4-dimension, 5-dimension, 5th-dimension. These are not pictorially representable, but imaginary, right? But yeah, we can represent them in terms of machine. Great. So Python offers two ways. There are two ways by which the arrays can be created in Python, right? What is the number one way? Using the array function. There's a function called as an array, and then there is using the built-in array generative function. There are a lot of many of those, so I will not talk about them in general. I'll try to talk about them one by one. Good. So let's try to create arrays. Let's create arrays. Create ND array rather using array function. Great. Now The first one that we have in the picture is, let's create a zero-dimensional array. Now, what does zero dimension means? Input stream. What do you mean by zero dimension? When you say the word zero dimension, anything strikes back? Yes, does not exist. No, it does exist, Preeti. A zero dimension does exist. Empty array, no, Rosai, Ravishandran. Empty array, I will, yeah, you can say that as zero dimensional, but that indeed does not mean the same thing. Understand what is, do we know what is the difference between a scalar data and a vector data? I will though talk about scalar and vector in detail later on. That's a separate thing. But what is a scalar data and what is a vector data? A scalar is without direction. Great. Thank you very much. Direction means a dimension. Understand it. Suppose if I think about a coordinate system. Suppose this is a XY coordinate system. Right? And if I put up a point anywhere in this XY coordinate system, right? Let me put up a point. I need to take a bolder pen. Suppose this is the point. Now, this point, if you do not talk with reference, a single point I've talked about, if you do not talk about this point with reference to any point, right? If I talk about where is this point from this location, right? That is a vector, right? It is a vector. Where I'm talking about the location of a particular data to a reference, right? There is some length and some magnitude. Both things are available. Some magnitude and some kind of direction available to the data. What is talking about positive, negative, northeast, northwest, whatsoever it may be, right? I'm not talking about that. But some direction, then I'll say that is a vector quantity. If it is not vector, right, it is some data, right? Or something that you can think of which is directionless. Think about your height. For example, your height. Suppose I personally talk about myself, I stand 182 centimeters, right? I stand 172 centimeters. Now, if you talk about my height, if you measure it from my head to my toe, if you measure it from head to toe, you put up the scale from head to toe, I'll get 182. If you put it up from toe to head, I'll still get 182. Does it make a difference? That's scalar, right? Direction does not make a difference. How do you measure it? It does not make a difference. Now let's talk about gravity, for example. The gravity on the earth, suppose this is your earth, and the gravitational pull that we have is 9.8 meter per second square, right? I'm talking about very standard basic figures, right? So if something is attracted towards the earth, it is coming at an acceleration speed of 9.8 meter per second square. Agreed? Now, if something is going away from it, then I do not have the acceleration. We call that as the word deceleration, right? But that is nothing but minus 9.8 meter per second square. The direction changed, right? The magnitude remains the same, but the direction changed. Here it was adding up to the things. Here it is retracting from those things. Make sense? So direction changed. Or you can say the force, acceleration, velocity, these kind of entities which are direction wise, these are called as the vector quantities. Are we good? Thank you. So zero dimensions data or zero dimensional data or zero dimensional array are those that do not have any direction, right? And are created using scalar value. Okay. So how will I put it up? Very simple thing. So I'll name that as ARR0D get is equal to, I'll use numpy library dot the array function, as I said that here, using the array function. Good. np dot array, and I'll just put up a single scalar value. Let's say put up 5. I put up a single number 5. So I'm asking it to create up a numpy array, which is a zero dimension. And so what I'm asking it, numpy, please create an array and use this data. This data is in no dimension. I'm just putting up a scalar value. Good. It creates up an array. You might not agree to this. So let's first of all print that value, ARR0D. I'm going to print that data. I'm going to print the data type of this data, print the type of this data. If anybody is not comfortable with any of the function that I'm putting up or using, let me know. If you do not ask it, I will not talk about it, because this is some basic functionalities just coming from the very basics of Python, like type function and print function that I've used. Quickly, done. You can see 2 results on the screen. Confirm if they're visible and you have questions on them. ARROD, where did I use it? It's not OD, it's a 0D that I've used, and that typically is a variable name that I've taken up. You can take up anything. You can take up your name instead of that. If you do not like that particular part, you can put up your name, Asif. If you want Asif, I will put up Asif over there. If you don't like it, I can put up ASIF. It works well, no problems. It's just a variable name. That is our choice. It has to be a valid name as per the Python documentation. That's it. Great. But I've just kept that as ARR0D so that it becomes, understandable that I'm creating up a zero dimensional array. That's the idea. That is the only one idea, right? So at a later stage, when you are going to look at the codes, you would get to know that it's a zero dimensional array. Everybody able to get that as a numpy 0D array? Eyes, nose, maybe ND array. But is it zero dimensional? How will I put it up? I need to know the number of dimensions, isn't it? So how will I know that? Same array, I can use another function. This is a numpy function, so please remember. What is ARR0D? It's a numpy array. It offers me a lot of functionalities. One of the functionalities is to know about the number of dimensions it has, right? So I want to know ARR0D, the number of dimensions, NDIM. That gives me what? The number of dimensions for a particular array. So this is your array, and I want to know the number of dimensions of it. I want to print that up, so I'll just put up a print function before it. Print the number of dimensions. Good. Can you see 0? See, guys, I want you guys to code along with me. If you want me to take a pause, I'll pause it up. If you want me to wait, I'll wait for it. That I am trying to write down the piece of code. I am fast and not able to go along with me. I will wait, but confirm that you are getting also the same results or similar results. If you're getting any kind of error, if there is any issue, any problems, or anything, let me know. I'm here to help you out. No, Asif, I will not do it. I want to look at my screen, type it down, and then do it. There is a deliberate reason behind it, and I'm being very blunt on this because I wanted to make learn and not understand how to do a copy paste. Right? You want me to take a pause? Why we cannot use Rosie Ravichandran np.endem AR of 0D? See, the idea is slightly, different into that. Do you understand the concept of classes and objects, Ravichandran? Now, that was a specific question coming from Ravichandran. Right? Basic understanding. So the idea is that this property, right, endem, is a class attribute, right? Like when we create up a class, we have an attribute called as endem. Good. And then if you talk the way you are talking about, you're talking about there is this function, right? You're talking about the way I'm talking about that I am trying to write down a function called as endem followed by an argument of the array, right? So that is a method, right? If I have a method by the name endem, I can call that method passing an argument data, right? So there is a difference between a class attribute and a class method. So here endem in Python with numpy library is given as a class attribute rather than a method. There are certain things which are methods. I will use them as methods, but there are certain things which are as a class attribute. I need to use them as an attribute. Make sense? Now here you should know what is a class attribute. That's the basic idea. Thank you. Again, team, I'm okay with 2 plus 2 is equal to 4, but ask it. If you do not ask it, I will not get to know. But right, can I move on to the next attribute or next property? Yes, no, maybe quickly. Yeah, thank you. So next property that I want to talk about is the shape. So same thing, I've just copied and pasted back, and I'm writing down the word shape. Now, what does it tell me? Now, listen to that definition very clearly because this is going to be a very, very important attribute that you will have to use multiple number of times at multiple number of places for multiple number of reasons, right? So shape is one of the very important attribute, right? Very important attribute. So you need to understand that very clearly. What does it talk about? It tells you the number of elements in each dimension as a tuple, right? Now, can you tell me what can be the expected output from the information given by me? 0. Preeti says 0. I tend to disagree. Anybody else? The Preeti, your approach is not wrong, but the way you are interpreted the answer is not exactly the way it should have been. Narendra says nothing with a round bracket, 0 itself, Abhinetri. No, it's not going to be 0 again. Yeah, you mean an empty tuple? I agree with that. 0 is not an empty tuple, right? not square brackets, Kunal. Yeah, round brackets. What I want is that it is going to talk about the number of elements in each dimension. Now, how many dimensions do I have? Nothing. So there is no dimensions available, so I cannot count any number of elements in any number of dimensions. Right? So what I'll get is a tuple that is having nothing. A tuple without nothing means an empty tuple. An empty tuple will look like this. Are we good? Sensible? Thank you. Let's talk about the next property. Size. And I'm going to give you the definition for size too. It gives the number of elements, gives the number of elements in the array. Now, what should I expect over there? Arrays are denoted by square brackets. See, arrays are denoted using square brackets. Agreed. But the point is, I'm not denoting the array. I'm denoting the shape of that array. If I have to print that array, ARR 0D, the number of square brackets, I'll come to the square brackets concept in a short while. Someone has, let me just scroll back up. It was Kunal. So Kunal, I'll come to the concept of square brackets in terms of Python in a short while, and I'll talk about 1D array. I'm still stuck at 0D. Right. So just hold on. I'll talk about when the square brackets comes into the relevance. What is the purpose of square brackets in terms of arrays? What is the significance does the square brackets hold up? Everything will come up, but I need to put up the right path. So coming back to the size. Now, when I talk about size talks about the total number of elements possible in that array. Now, here I have only one element, so I'll get the answer as 1. Almost everybody was wrong, or everybody was right. Next property I want to talk about is a very basic property. It's called as the D type. Now, what does D type tells you? It talks about the data type of every element in the array. Now, some of you would be getting int 64, some of you would be getting integer 32-bit, 32, right? Let's have a check. I've got int 32 over there. Anybody got int 64? I am expecting that from the Google Colab users. Right? int 64. Now, what is the difference between that? You're using a local Mac. What is the data type that you got? D type. Shishodhya, Narendra, 64. I'm okay with that. Great. Now, what does that mean? Any idea? What does that int 32 means? It means that the machine has stored the data as an integer of 32-bit. Interview question team. Let me ask it. What is the default size? What is the memory allocation size? Memory size of integer or let's say integer 32-bit in Python. Now you see that I have given up a word. I've said that what is the memory size of integer 32-bit in Python? Now you might say 32-bit, but that's not right. It goes like this, that by default, when it is 32-bit, right? Python takes it at not as 32-bit, but it takes up that as 28 plus 4. That means it is allotting 32, 28 bits to allot the data, and 4 bits are incremental. That means if a number can be accommodated in 28 bits, it will accommodate in that. If it cannot, it will use next 4 bits for this. If it cannot be accommodated into that, it will increase that by 4 bit. Is my screen not visible? Akshay is not able to see it. Rest of the team, you can see. Sairam, thank you. So Python is, kind of a language that, does not allow, or it allows me to avoid data usage or data leakage. Does not happen with that. For example, let's say if I talk about A, let's say I'll put up a number A is equal to 999. 4 times 9 works well. Print A. I can see 999. If I increase that to any number of 9s, I still get that same number. If not okay with that, I'll copy that and paste it up multiple number of times. I'll still get the same number. That many long values are not supported in other programming languages, but Python does it. What it says is that I am willing to extend your data structure. Willing to extend it. I'm going to give it a default value. There is a library that I can use, that is a sys library. I'll just show it with that. Let's put up import sys, how much memory it takes up. For example, if I put up here sys dot size of, okay, great, very simple function, sys dot size of. All right, I want to get it up. So get size of, yeah, and let's print it up front. Now I want you guys to concentrate on here, the number of data points that I'm going to use. Look at this. You will have a great knowledge on this. I'm putting up 9,999. Good. What does it tell me? What is the size here? 28 bits. It is in size in bits. Let me increase one more 9. Still 28. So that many number of data can be accommodated in 28 bits. If I put up another 9, 28. If I put up another 9, still 28. Another 9, still, now it becomes 32. Make sense? Right? So whenever this data cannot be accommodated in 28 bits, it increases that by an incremental value of 4. Make sense? Why by 4? Because my machine is 32-bit. In 32-bit, it is going to increase by 4 bits. In a 64-bit, it is going to increase by 8 bits. And it's going to not start with 28, it's going to start with 56. Make sense? Now, if I just put that number, let's say double it up. I'm just putting the same number, doubling it up. You can say it goes up to 36-bit. Akshay Sharma rejoin, because many all the other learners are able to use and see my screen, so it has to be an issue at your end. Please rejoin. Akshay, then it has to be something at your end. You need to check at your end, please, because it is nothing from my end. Every other learner apart from you is able to see my screen. So something that you might have disabled around, or maybe something that is causing that problem. You might have put up, hide screen or hide whatever. Sys function is size. See, sys is a library, Asif, that's a default library to Python that is used to know about the system interactions. That means how is the machine interacting, the hardware component part, right? So it's a library. It has multiple number of functions. One of the function that I have is get size of, that talks about the amount of memory or hardware memory that is taken up by particular data. So get size of gets me the memory in terms of bits, which I can see over there. Not in bits, but in bytes. Are we good? Thank you very much. Now, very common question. Now, had that been a 64-bit integer, same thing would have varied. Those who are using 64-bit machine, you would have seen that I have 36 over there, you might have 72. Same example, same data, you would have 64 or 72, right? No, it is not starting with 28. It starts with 56. Because for 64-bit, it is 56 plus 8. 8 is the incremental term. For 32-bit, it is going to be 28 plus 4. INT 64, I am getting triple line is 36. Not possible. Integer 64-bit does not start with 36 bits. Not possible, Kunal. Data used is 28. For me, it starts with 28. See, that is a separate thing, individual machine wise. Kunal, hold on. See, it is individual machine wise things. You might think it is 32-bit or 64-bit. I'll talk about individual machines if you require, but that's not the point. The idea is that I want to convey is that what your machine is going to be, how it is going to take up the data. Either it is going to be a 32-bit data or a 64-bit data, right? That is the main concern. Does not matter. It does not make an impact at the end of the day, as of now for you. As of now, it will make an impact when you are dealing with, bigger corporate clients where every single bit of data is an important, right? Things you want to, save out on even a single bit of memory. Optimization of the project is a concern. You might require that information at that stage. So I just given that as an additional information to you guys. Good. The size of integer. There is a concern with the size of floating point. There is a concern with the size of the strings. I am not going to talk about that at all because that is going to take me a long time. But what I'm trying to bring in is the perspective where you can, extrapolate your knowledge, how you can utilize your time after today's session, coming up to tomorrow's session, and have multiple more number of questions for me, right? Giving you something new to explore. Hopefully. Are we good? Next thing I'm going to talk about is another property into the same array, the zero dimensional array, and that is the item size. Give that a look, team. Item size. What is that item size? Talks about the amount of data or space allotted in bytes. So it has given 4 bytes of space. Those who are using 64-bit machine would have had the value is 8. Good. Confirm. Everybody okay with this? So on my machine, size of is 32 and item size is 8. Abhinetri, I need to have a look into the machine because there will be a lot of things to consider. But what I have told you about is standardization. Either for 64-bit, it should be 8. But if there is a disconnect, then there should have been a clash between your machine operating system size and the Python installation size, right? Maybe your machine is 64-bit and you have installed a 32-bit Python, or the vice versa, right? If there is a disconnect between the version, at times what happens is people install, okay, they think that my machine is 64-bit and they install a 64-bit Python, but at the end of the day their machine is 32-bit only. So there is a clash happens. So some certain things will work on 32-bit, certain things will work on 64-bit. That is going to happen. It is going to happen, right? Nonetheless, let's try to talk about a vector quantity now, because I'm starting with 1D array. Let's talk about a data point. Till now, I've seen a value 5. I've just given a number 5. I did not tell it what it is, in which direction it is, where it is from. Now, in my coordinate system, right, this is your x-axis, this is your y-axis, right? If I have to refer a point, let's say this one, this is 3 on x-axis, let's say 4 on y-axis, okay? So that is means that I'm moving by 3 data points on X and I'm moving by 4 data points on Y. Then I'm reaching to this point. Make sense? From where? From my origin, which is 0, 0. Good? Agreeable? Yes or no? Thank you. Now that means from my origin, that is into some direction and have certain length. Acceptable? Now, if I have to represent this point, can I say that that is X, it has a value on X-axis, it has a value on Y-axis. That means I have two terms at least. X-axis holds a value 3, Y-axis holds a value 4. Correct? Or can I say that this is individually a scalar value, this is also an individually scalar value, but I combined them together to make up a vector value, isn't it? So when I combine multiple scalar terms, it becomes a vector. That's what I'm going to do over there. For 1D, I'm going to create up a combination of multiple vectors. So let's take up a vector quantity. I'm going to take up a list 1, 2, 3, 4, 5. A simple data, right? A very simple data 1, 2, 3, 4, 5. A simple list that is 1, 2, 3, 4, 5 values, and I'm naming that as ARR1D. And I'm not going to change up anything else apart from the variable name. And I will request everyone. Yes, Akshay, tell me. LSM would be available, but if it is a video issue, you can let me know. I can see some responses coming through. Akshay, you will be getting a call in a short while from a call or connection from coming from Anurag. Great. So what I can see here is some responses. Let me just quickly have a look. Okay, here it goes. Sairam got Sairam has 1, 2, 3, 4, 5 class numpy ND array, comma 1, 5, comma 5 integer 32 and 4. Then 5, 4, 3, 2, 1, 4, whatever the number is, that does not make a difference to me. 8 bits, 8 bytes. Okay, 1, 2, 3, 4, 5 class numpy ND array, 5, comma 64. I'm okay with Kunal's. Sairam is okay. I'm okay with that. Again, 14 is okay. I'm okay with that too. So most of you are getting the correct answers as expected. But the idea is to understand or comprehend the results. Number 1, print 1D array. Now look at this. When it was a zero-dimensional array, it was a 0D array, right? How many number of brackets do you see in the output? Square brackets? No brackets. Good. Now, when it becomes 1D, can you tell me how many brackets at the beginning and or at the end? I'm using the word or, not and. Brackets either at the beginning or at the end. Number of brackets. You have 1, right? So for zero-dimensional arrays, in display, you will not get any brackets around it. It's still that is an array. For 1D array, you will have 1 square bracket around that entire data. When it becomes 2D, you will get 2 brackets. When it becomes 3D, you will get 3 brackets. When it becomes 4D, you will get 4 brackets. So if you need to know about the dimensions of the data at all, and if it is an array, you just look at the starting brackets or the ending number of brackets. Whatever is the count of starting number of brackets or the ending number of brackets, you can tell that that is the dimension of that array. Good. Here, it is ARR1D starting with 1 bracket. So my number of dimensions is 1. How many dimensions do I have? I have 1 dimensional. So for the first dimension, how many elements are there? Essentially means within the first brackets, how many independent individual elements are there? So within the first pair of brackets, this is starting, this is ending. I have 1, 2, 3, 4, 5. So within that first bracket, I have 5 number of elements that is given there. And since it is a tuple, so I can see comma. Size gives me the total count. That's the size. That's the memory size, a D type, and the memory size. Are we good? Anybody, any questions with this? Yes, no, maybe? Confirm. This is concepts comes from the tuple concepts. What is a tuple? The definition of tuple, right? Suppose if I make a value, for example, many people say that tuple is, a value is within the pair of round brackets. That's wrong, right? Let's say if I make a tuple t1 is equal to, and I want to write down a single value. Let's say if I put a 5 and I put that up within the pair of round brackets. Good. Now, what do you think? It should be tuple, isn't it? It is not going to be a tuple. It is not going to be a tuple. I'll tell you why. That why part. But let me just show you. Print the type of T1. It's going to be an integer. Look at this. Observable. Now, the moment if I just change that to a comma, right, it becomes a tuple. Now, what is the difference? The difference is, try to understand. For tuples, it is not mandatory to use the round brackets. The mandatory condition is it should be a comma separated value, right? I can write down, let's say, for example, T2 is equal to 5 comma. Did I put up any bracket? No. Yet, if I just ask you to print the type of T2, right, it's a tuple. Good. So brackets does not make a sense. What makes the sense is the comma, right? So if there is only a single value and I still want to represent that as a tuple, right, then I need to put up at least one comma. There are multiple values in tuple. Square brackets is must. No, it's not mandatory. If you need to take out multiple values, let's say T3, not mandatory again. T3 is equal to, I can put up 1 comma 2 comma 3 comma 4 comma 5. That still will work as a tuple, not a problem. See, the brackets are not mandatory. These are just, notional. In case of tuples, the round brackets are just notional. You do not require round brackets to create a tuple. It's just notional, just to make it separate looking kind of thing from lists and so on. That's the only ideology behind it. Otherwise, you do not require them. To create tuples, you do not require round brackets. See, I have not used round brackets on 1, 2, 3, 4, 5. I still. Yes, with a list, Narendra, yes, you require square brackets because that's the fundamental definition of list. These are comma separate values within square brackets. For tuple, it is not the fundamental definition. The fundamental definition of tuple is comma separated values. That's it. The use of round brackets is, promoted by many people, but it's not the truth. Many people say that, okay, tuples is, values which are enclosed in the round brackets. No, it's not. It is just comma separated values. Anything which is comma separated is by default a tuple. But if there is anybody else questions, 1D array, I have talked about endim shape size, D type, and item size. Typically, you will not see any difference. Okay, now I cannot comprehend that. The two-dimensional array. Now, when I combine multiple scalar values, I got 1D. So when I combine multiple 1Ds, I'll get 2D. Right? So I'll take this 1, 2, 3, 4, 5 again. I'll copy it, pasting the same thing again, but just changing the values to 11, 12, 13, 14, and 50. And combining them together again as a list. So if you look at this, this is a list of lists, right? I have an outer bracket that is defining that I have two lists in between, list 1 and list 2. And within that interior lists, there are 5 elements here and there are 5 elements here. Are we good? Changing the variable to 2D. You're supposed to reach out to a different place in this current situation. But if you can look at this part and tell me if you are okay with ARR 2D or not. I'm not talking about anything else apart from creating the two-dimensional array from a list. First of all, just look at the starting number of brackets, ending number of brackets. It's a 2D array, hence I've got 2 brackets. Then that is your number of dimensions too. That is why in my tuple I have 2 values. It says in first dimension I have 2 data points. What is your first dimension? First pair of bracket. This is starting over here, ending over here. How many elements? Element number 1, element number 2. Good. So that is why I have 2 over there. Then what is your second dimension? That is your second bracket. It starts over there, ends over here. Number of elements 1, 2, 3, 4, and 5. And I got 5 over there. Make sense? So what I want you to understand is how to read that shape output. Now, in a similar fashion, I can create up a 3D array too, a 3-dimensional numpy array. Great. When I combined scalar values, it became 1D. When I combined 1D values, it became 2D. So when I combine 2D, it will become 3D. Right? So I'll just put it up. Same thing, copied, pasted below. Good. And I'll put up create a 3-dimensional array. So that would be a rarity that you will be dealing with a 3-dimensional data at the beginner level. But maybe you might be dealing with multiple dimensional data. So you should understand what the dimensions are. Right? So I'll take up this 2D data that we already have had. I'll copy the same information, comma, paste it back again, and I'll enclose that another pair of brackets. So this is one 2-dimensional data from here till here. This is another 2-dimensional data from here till here, which is again enclosed as a single unit. So let me just put up as a reference a different numbers: 21, 22, 23, 24, 25. Here I'll make it 31, 32, 33, 34, and 35. Just to make the changes, right? And now you get the 3D information. What I want you guys to concentrate on the result of endem, result of shape, result of size. The D type item size is not going to change. It's going to be same thing because I'm using the integer values, right? So not into this part, but look at this. It is an array. Number of dimensions is 3. First dimension I have 2. Second dimension I have 2. Third dimension I have 5. Total number of elements is 20, which is a multiplication factor. 2 into 2 into 5. Get that value. Agreed? Thank you. Now, when it says that I have 2, 2, 5 shape part, look at the outermost bracket. This is the outermost bracket, right? Which closes over there. The number of elements that I have in that bracket is this. I have here till here. This is one element. This is your second element, right? 2 elements that I have in the outermost bracket. Good. So hence I have 2 over there. Then I will look into the second bracket. If you look forward for the second bracket, right up there, this is the second bracket, starts over here, ends over there. Number of elements 1 and 2, and hence I have the second 2 over there. Good. And then I look at the third bracket. Third bracket starts over there, ends over there. 1, 2, 3, 4, and 5. And I've got 5 over there. Is that sensible? Very critical for me, for you guys to understand the shape parameter. How is the shape calculated? What essentially it means, and how it talks about the real world information. Okay, thank you. Let's think of a data. I'll not take the same example. Suppose there is a cuboid. Good. There is a cuboid that you have, right? A cuboid looks like this. Agreed? I may be bad at drawing, so please pardon me on that. I've drawn up a cuboid. Now, there are three dimensions to this. I'll use a different pen. Okay. One is this dimension. The second is this dimension. And third is this dimension. Agreed? Now, can you tell me how many number of layers do you have in this dimension? That is your first dimension. I have 1, I have 2, I have 3, and I have 4. There are 4 layers. Accepted? So that is my first dimension. Second dimension is the one that you have in vertical. Can you tell me how many number of lines do you have in the second dimension? Rows? 3. That is my second dimension. Can you tell me how many number of columns do I have? 2. Thank you very much. That is my third dimension. That is the total shape of my data. Depth, rows, and columns. Make sense? Awesome. Thank you. So three-dimensional structure will look like a cuboid, or maybe it can be cube as well. Right? If it is equal all around, then it can be cube. But it's kind of cuboid. Are we good? Hopefully that makes sense. So when we look at this data over there, here, so I have, 1, 2. The depth is 2. That means I have 2 different layers of numbers, layer 1 and layer 2. On the layer 1, I have 2 rows and 5 columns. On the layer 2, again, I have 2 rows and 5 columns. They are, sandwiched together. Good? Yes, no, maybe up to 3D. Whatever I've taught up so far, if there is any problems anywhere with any of the things, you need to tell me, okay, I'm not able to understand this. This is way beyond, my level, or something you're talking, hypothetical. You became, kind of, let's say, how in terms of those things are way beyond anything. But ask it, please. So we use first 3 only. Essentially, you might come across Akshay with 4D and 5D data, but when we are going to do the data processing part, right? When we are going to deal with how to manage or manipulate the data, we do not deal in more than 2 dimension. Even 3-dimensional data is not very much comprehensible, not very much processable. So essentially, when you talk about data manipulation, data exploration, data analysis part, we deal in the data with 2D because that's the best possible way around to deal with the data. If array stores the same data type for data, why will we have to use D type for every element? See, the D type is a function, or it's an identity given, or attribute given to us to know the data structure or data type of every individual element available in it. It's going to be common for every single data element. It just tells us that what is the data type. It's an informative function and of no other use. It will be of use when I talk about Pandas library. Same attribute D type will become different for you when the data structure changes from array to a list, not a list, but to a series and a data frame. So the idea here is that you need to know what is D type tells you. It talks about the data type of every element into the array or into the data structure. That's the idea behind. Good. In arrays, we know that by fact that every element is going to be of one type. I'll also talk about what is the overriding factors and so on. When is what going to change up? What if it is a mix of type of values? A lot of things will come up into the picture, but not today, tomorrow. Confirm if you're okay with creation of 1D, 2D, 3D, 0D arrays. and basic properties. I'm not even looking for D type. Endim, no. Shape and size. And if you do not understand size, I'm okay with that either. Only the shape property. Or numpy. Not too many of those. We'll not talk about too many functions today. I'll start talking about very basic functions, to be very precise, and we'll talk about the arrays now. We'll start with the very basic functions of the arrays in terms of how will I put it up. So there are three basic functions that I want to start with, or rather two basic functions of the arrays, or in terms of understanding what numpy arrays are. So we'll start with some functionalities. Number one is the reshape function. Now, team, please try to understand that you may still not find it relevant in terms of when and why I'm going to use those functions. But as of now, just know them, that these are certain things that you can do. Good. So reshape function. What is the idea behind the reshape function? The reshape function allows me to change the dimension of an array from any shape to any shape. Now, shape does not make a difference, but the idea is that with the constraints in the resultant array, that's the idea behind the reshape. So let's consider an array for an example. Okay, I'm going to put that up array. Let's say ARR is equal to np.array. Good. And I'm putting up certain elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's put up 10 too, or 0. Good. Now, can you tell me, what did I miss? Invalid syntax of 2 commas over there. Number of dimensions that I have. Number of dimensions of this array, 1. The shape is a tuple of 10 elements. And the size is 10. When I talk about the reshape functionality, it talks about that the size will remain consistent. That means I will only have 10 elements, but I can modify the shape. If I modify the shape, that means I'm altering the number of dimensions too. Now, suppose if I have 10 values, right? Very simple thing. This is the last thing I'll take up today, right? I'll wind up the session for today. Maybe after these two functions, right? So if I have 10 elements, I can arrange them as a single data line of 10 elements. Or I can do them as 2 rows and 5 columns. I can do them as 5 rows, 2 columns. I can do them as one layer of 2 rows and 5 columns. I can do them as one layer of 5 rows and 2 columns. I can do it as one layer of 2 rows, or rather 1 row, 1 column, and another one thing, right? I can make it into 4 dimensions. So it is dependent upon to me what is the number of dimensions that I want. So I will have a given shape, and I want to modify that shape to a different form. But the only objective that I'll keep on remembering is that I want to make sure that the number of elements that I have before I reshape and after I change, that remains consistent. Good. Now, here I have 10 elements. How can I reshape them? Let's say I want to put up ARR underscore reshaped, and I'm putting up the reshaped as 2 rows and 2x5. Good. So how can I do that? Same array ARR, and I'll use the numpy function called as array of the reshape. Good. And I want to put up the new shape as 2 rows, 5 columns. Good. Let's have a look. Print, same thing, ARR reshape 2 by 5. And now you can see that those numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, which were linear or one dimensional, now has been changed to two dimensional. Just to verify, I can print ARR before the change and after the change. Good. Now before the change, you can see that it starts with one bracket, ends with one bracket. After the change, it starts with two brackets, ends with two brackets. Can I make it three-dimensional? The answer is yes. How? I can let's change it to the shape of one layer with two rows and two columns. Or the two layers, let's put it up of one element, and you can see this now. This is your three-dimensional thing. Outermost dimension has two things, 1 and 2. The second dimension that has only one thing, starting from here, that is only one thing that I have in second dimension. Third dimension has 5 things. That is 1, 2, 3, 4, 5. Are we good? Eyes, nose, maybes. So the ideology remains that the number of elements should be same. That is the idea behind the reshape function. Now, suppose if I have a two-dimensional array, let's create a look at the 2D array. I'm going to bring back my example. Next function that I will put up is flatten. What does it do? It converts any dimensional array to one-dimensional array, 1D array. Right? The role of the flatten function is to convert any dimensional array to a one-dimensional array. Let's take up an example. Let's take a print ARR2D. We have created a two-dimensional array earlier, right? In this particular batch. And that is how it looked like. I have 1, 2, 3, 4, 5, 11, 12, 13, 14, 15. Good. Is it 2D or 1D? 2D. Thank you very much. Now I can directly convert that without using the reshape. I have a choice that I will tell it, okay, I want to convert that into 1D. I can put up, let's say, ARR2D dot reshape, and I'll tell the number of elements. That's 10, comma. That's the shape. And I get a 1D array. Right? Now here, what is the problem? The problem is that I need to know the number of elements. Correct? I need to know what is the size of my data. Accordingly, I can use with the reshape to convert it to 1D. But if you do not want to take that into consideration, irrespective of the size, what you can do is you can put up ARR2D dot flatten. Flatten means what? It is supposed to convert anything and everything into one dimensional. Irrespective, it is 2D, irrespective, it is 3D, it is whatever D it is, right? Number of dimension does not make a difference, but flatten function, without knowing how many number of elements are there, it's going to convert everything into 1D. Right? I give you a block of iron. This is a block of iron, right? What is the dimension of this right now? Suppose it's a sheet, two-dimensional, right? Now, if I ask you to make it a wire, make it a wire. What is the thing that you're doing? Make it in 1D. Right? In order to do this, what you would have to do? You might have to, beat it around, molten it up, do whatever you want, right? But you want to make sure that it comes into one dimension instead of two. If I'm converting this to this form, isn't it? I might have to beat it around. I might have pass it through some kind of tools and gadgets, but I can get it 1 to 1D, isn't it? Same thing is done by the flatten function. The flatten function is going to take up any dimensional data and bring it to one dimension, right? Any dimensional data. It can be 2D, it can be 3D, it can be 100D. Does not make a difference to me. That's the use of flattening. What is the purpose? See, at times, to be very precise, it is very, very complicated to imply certain functions on two-dimensional or multi-dimensional data. When it is a multi-dimensional data, many functionalities I cannot directly implement on them, right? So what we would like to do is, I would like to bring that down to a lower level of dimension. That means one dimensional, apply certain concepts and bring it back to the upper level. So I would be doing those things at a later stage where I'm going down from, let's say, 3 dimension, let's say from 2 dimension, I'll come down to 1 dimension, do some job and bring it back again to 2 dimension. Because applying things in 2 dimension is complicated, but doing the same thing in 1 dimension is easy. For example, if I ask you, now this is coming from little bit of mathematics team. I've not yet talked about mathematics. But suppose if I ask you to multiply this is a two-dimensional data, 1, 2, 3, 4, 5, 6, right? Two-dimensional. I ask you to multiply it by 2. Is that easier or is this easier? This is option 1, this is option 2. Tell me which option is easier. Option 2. Why is it easier? Because this is flattened out. This is one-dimensional, right? This is two-dimensional. So at times, I'm not so talking about only the multiplication process, but in general, there will be a lot of processes that you will deal with in the future prospect, wherein dealing with high dimensional data like 2D, 3D, 4D, 5D will be very complicated. But the same thing could have been achieved by a lower dimensional data. So I would like to reduce the dimension of that data, and there flattening or reshape will help us. Make sense? I have taken an example here, which was a small array. Had that been a very, very huge amount of array, because at a later stage, I will introduce you certain kind of arrays where the number of data points would be in millions. I will bring those kind of arrays into your picture. In this scenario, if you try to do it that way, right, it would be a very, very slow and lagging process. You will not love it. Otherwise, it's okay. Yeah, you can take out the length and extract every single element one by one and make it 1D. You can do it. Allowed. Right? But in real life as well, there are a lot of things which are allowed but are not considered as a good practice. Right. So I have a backup question coming up from Asif about to go through with one-dimensional, two-dimensional, and three-dimensional. So I'll start with a very simple example, right? A very simple sort of example, wherein suppose there are 10 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, as you can see on my screen right now, these are some 10 dots, some 10 different data numbers, data points, data values, something like that. Okay? Now, if I arrange them in a straight order, in a straight line, one line, it means point number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's your one-dimensional. Good. If I arrange them, these things, these 10 dots, again, into a two-dimensional space, that means suppose I divide them into, let's say, something like this, 2 rows, and 1, 2, 3, and let's say put up a fourth line, and I put up dot 1, dot 2, dot 3, dot 4, dot 5, dot 6, 7, 8, 9, and 10. I am putting them into two-dimensional space. So it is only about the arrangement of the data, how you arrange the data in the memory is what makes the difference. When you come across 3D, right? Same information could have been arranged in three-dimensional space. Right? Instead of creating a plane like this, I can create up a three-dimensional object. Think of a three-dimensional, like a cube, like a little thick thing, right? Which contains 1, 2, 3, 4, and 5, like this. And then we have the same thing over there. Make sense? So that's the idea behind 1D, 2D, and 3D arrays. It's all about the data arrangement. How is the data being arranged? Are we good? Asif. Thank you. Now, moving on to the next part, which is very important, very critical for me, and that is the functions that we have been started discussing about, yesterday. We started with some of the functions in NumPy as of yesterday, right? So we talked about one of the important function, which was the reshape function. Good. Then we talked about the flatten function. Everybody okay with the reshape and flatten? Any questions on that? Next function that I have into the pipeline is called as the transpose function. I'll start with the transpose function. The transpose is something I am expecting should be a very common word for everyone. Can someone tell me what is transpose means? It converts the array. Reversing rows and columns. I will not say that in that terms. Reversing is not the correct word, but switching would be the correct word, right? Abhinitri. So, or rather, it switches rows to the columns. It switches the array rows as columns, or vice versa. That's the idea behind transpose. Let's understand that through an example. Let's import NumPy. Why I am doing that is because many of the people are not going to use, NumPy would not have been available for you guys. You might want to restart with a new file. I'm using the old file. I could have worked on the old file itself. But let's start with import NumPy as NP. Let's create up an array, a 2D array. So let's create ARR is equal to np.array. And there, let's create up a two-dimensional array. So in the first dimension, I have one element, comma, two element, comma, three elements. So I have three things in the first dimension. In the second dimension, I'm putting three elements again, 1, comma, 2, comma, 3, 4, comma, 5, comma, 6, and 7, comma, 8, comma, 9. Good. Let's have a look at the print ARR, just to look at what ARR looks like. That should look like an array or a two-dimensional structure with three rows and three columns. Everybody okay with this? Now, someone quickly confirm what is the first row data? What is the row data for first row? 1, 2, 3. Thank you. Second row is 4, 5, 6. Third row is 7, 8, 9. Agreed? Thank you. Now, what does the transpose function do? Now, there are two ways to do a transpose, right? One is a numpy method, one is a Python method, right? So, numpy way is I will ask my ARR that numpy, please do a transpose. So, numpy.transpose. Transpose of what? The ARR array. At the moment I do it, let me just print that up. And what you now see here is the first row, that is 1, 2, 3, has now become the first column. Agreed? The second row, 4, 5, 6, has now become the second column. The third row became the third column. Are we good? Yes, no, maybe? Use of transpose? Great. Abhinitri, transpose is essentially not for 2D array. We can use it for 3D array, but practically not useful. So if you talk about transpose functionality, yes, it is possible for 3D. If I do your multi-dimensional, you can go for that. But the practical implementation or the practical usage of transpose would only come across for the two-dimensional arrays. Why it is for two-dimensional array? That's the question, major question. So the idea behind the use of transpose, listen to that very carefully. The idea behind the use of transpose is to solve a set of linear equations. Solve linear equations. Anybody understand what is a linear equation? Yes or no? See, it's a part of mathematics. I'm supposed to take that care of that in the mathematics part. No, I have one no coming from Preeti. Okay, great. Let's Preeti take an example. Right, it's a part of mathematics portion. I will reiterate that in mathematics, but just to give you an idea. For example, suppose a data. I'm putting across a data in front of you that contains like information like this. Good. It has 1, 2, 3. I have apple, bananas, and cherries, and price P. Good. This is day 1. I bought 2 apples, 1 banana, 3 cherries, and I end up paying, let's say, $10. Day 2. I bought up 2 apples, 2 bananas, 1 cherry, and I end up paying, let's say, $12. Day 3, I have paid up, let's say, I have used 1 apple, I have taken up 1 banana, and I have taken up 4 cherries, and I paid up, let's say, $9. Good. This is random numbers that I've chosen. Now, day 4, let's say day 4, I am looking to buy 4 apples, 3 bananas, and 2 cherries. Can you tell me how much money should I carry in my wallet? It's a prediction, right? Isn't it? First of all, do we agree that it is a prediction? It is a prediction. Everybody agreed to that? Thank you. Now, if it is prediction, then I need to have a mechanism to get this in. Right? What can I do? So I can now see here that the apples are being bought at a price X, bananas are being bought at a price Y, and cherries are being bought at a price Z, assuming common prices. Right? Then I can say that in mathematical terms, that if I take apples multiplied with its price plus bananas multiplied with that price plus cherries multiplied with their price, that equals to my p-value. Can I say that relationship? Thank you. Now, if I have to satisfy that relationship, that means I need to know the value of x, I need to know the value of y, and I need to know the value of z. I do not know it yet. Given data does not tell me what is the price of individual apple, individual banana, individual cherry. But can I extract it? The answer is yes. How? I have 3 separate equations available. If you look at this very carefully. Line 1, day 1 tells me if you take 2 apples plus 1 banana plus 3 cherries, you need to pay $10. The second equation says 2 apples, 2 bananas, and 1 cherry, you are going to pay $12. Third equation says an apple, 1 apple plus 1 banana plus 4 cherries is $9. Now I have an equation of 3 variables, A, B, and C, right? Right. So that should be XYZ. You can say that, right? ABC instead of XYZ, I need to have XYZ there, right? The prices, not the account, because ABC is representing the account. So other way around. But can I get the values from these three equations, the individual price for every single fruit, eyes, nose, maybes? If I solve this set of linear equations, I have a method of substitution, I have a method of replacements, which I can use and solve this. Three variables, three equations, we can solve it, correct? Mathematically. Good. But the problem is that when I'm doing the mathematical solution, as humans, we can solve it easily, right? I can tell it, okay, equation 1 minus equation 2, equation 2 minus 2 times equation 1, equation 3 will help me out, solving it out, and we can do that. Make sense? But the point is the machine cannot do it. Then we have an alternate methods. Right? In that alternate methods, I solve these set of linear equations using matrix and the concept of matrix, right? In solving that, I will require the use of transpose. I would require to use transpose somewhere because I need to calculate an inverse of a matrix that is called as inverse. The inverse is coming from the transpose of a cofactor matrix. It comes from the transpose of a cofactor matrix. Maybe may not find it very relevant right now because you do not know what is inverse, you do not know what is cofactor, right? You may not know about it. I will come across to these points. What is the cofactor matrix? What is the transpose? And how does it make a difference? How is the inverse calculated? How is the linear equations are solved using matrices? Everything is will follow. But the idea for the reason understanding the transpose concept is, because that's what we're trying to talk about, is to know that what is transpose. So everybody able to understand what is transpose, yes or no? Where and why to be used, there's a lot of things into that. Is that okay, team? Thank you, Abhinitri. Now there is an alternate way, which is called as a Pythonic way to do the transpose, right? A Pythonic way. This was a numpy method that I've used, but I can also take up the transpose of ARR. I can put up ARR dot uppercase T. When I do this, the uppercase T letter is predefined in Python to take a transpose of a two-dimensional data. You can see the same out. Can you see that? 1, 2, 3, 4, 5, 6, 7, 8, 9 as being separate columns. So either you can use the numpy method or you can use the Python method. Now, why did I talk about this part? np.transpose and T both, just because to let you know that there are multiple choices. Good. Thank you. Now I have a question for you guys. Would you like to work on that? I'm sending that data to your screen too. On my screen, can you see something? Read out that question and tell me the answers. If there is anything that you do not know about, well, the data attribute I've not talked, so leave out on data. It's not required. It does not. any kind of good information. It's okay. Rest of things. Let me see if someone can send me the outputs quickly. You can see the statement on my screen. That's also available on to your chat window. You have the data available. Give me the answers. And I'm not looking for the outputs. I'm looking for the codes. What you write down. Someone. So in order to solve, I have a given data of the temperatures. I will take that as an input. Temperatures is equal to this. And it says that it has to be a numpy array. Let's say create an array by the name temp is equal to np.array of temperatures. Good. Let's print temperatures. Print temp. Good. I got 1D array. The question says that explore the key attributes of numpy array, including endem, shape, size, dtype, and item size. Can we do that? Something came in. Let me just check. Array dynamic is np.array of that elements. Thank you, Narendra. Dynamic type, array dynamic.endem, array dynamic.shape, size, dtype, and item size. Great. Thank you very much. Good. Anybody else? There was some second part to it too as well, Narendra. I hope so you can do that. So I have 1, 2, 3, 4, 5, 6, 7. Typically, reshape is not possible. 7 is a prime number. I cannot reshape it. I can put it 1D, 2D, 3D. That's possible, but that does not make sense. It will still remain the same idea. Flatten does not make a difference. Transpose will not make a difference in this particular data. Should not make a difference. So question number 2 you can avoid if you want. But endem, shape, size, D type, and item size. Everybody okay with that? Confirm? I'm not going to solve it. I'll leave it to you guys. Good? Kunal is getting error in endem. So whenever there is an error team, paste the last line of your error. Whatever the error output that you're getting, just tell me that. List object has no attribute shape. So you did not convert Kunal the temperatures to an array. You need to convert that to an array. Right? You missed out on this statement. Shape is a function or shape is an attribute for an array, not for a list. The temperatures given to me in the information is a list, and this is a array that I've converted into because I want to use shape. Shape is an attribute, a property of an array and not of a list. Good. Abhinay3 says endem okay, type of ARR3, shape, size, D type item says good. I'm happy. Thank you very much, Abhinay3. Transpose is okay, Narendra. But essentially, we will not see that difference in the outcome. Can I move on to the next part? Thank you. Arithmetic and statistical functions. Great. Coming it from Kunal. Temp, type of temp, temp.shape, temp.size, temp.dtype, temp.endem. Good. Happy. We can have also use end dtype item size as well. I can see the results for dimensions, shape, size, dtype, and item size. Yeah, thank you, Akshay. Looks fine to me. Great. Someone got 8 at the NY, 8 byte. Okay, load 64. I'm okay with that too. Thank you. Great. Can I move on to the arithmetic and statistical functions? Thank you. See, very quickly, we want to wrap it up, team. We do not want to disturb too much time onto the things which are not needed for us too much. I just want to make sure that you guys know about those things. Good. Thank you very much. Let's move on. So when I talk about arithmetic and statistical functions, can you tell me what are the different arithmetic operators that are available in Python? Arithmetic operators. Add. Good. Like does not complete that. I want everything. Narendra. Kunal has given me addition. You have given me subtraction, multiplication. What are the others? Arithmetic operations. Percentage. That's remainder. Good. I'm still waiting for 3 more. 4 are there into the chat right now. Addition, subtraction, multiplication, and remainder or modulus. Remaining 1, 2, 3. So 3 more left out. Floor division, great. Powers, okay, 1 more left. It's a basic one. Exponential power is same thing, Asif. It's the same thing. Power and exponential. One more left out. Scroll back up into the chat and see what is missed. I can tell it in a flash of a second. Thank you very much, Abhinitri. Division. So we got all 5, all 7 kind of operations. Let's try to implement all these operations using NumPy, because we know as a fact that I can perform that operation using the basic Python operators, right? We have plus, minus, subtract, and so on. So let's try to create 2 arrays. Let us create 2 arrays, 2 numerical data arrays. Create 2 num arrays. Get. So I'm naming them as x is equal to an array with a value, let's say 10, 20, and 30. Good. Let's create another array y is equal to 3, 4, and 5. Good. Let's put up that as np.array of this data. And here too, np.array of this data. Now, essentially what happens here is, I missed out on the comma over there. So essentially here, whenever I'm performing an operation, right? Suppose if I do a mathematical operation like addition, for example, if I perform addition, I can, let's give that a try. I want to print out what happens if I put up x plus y. Can you tell me? X plus y. What should be the result I'm expecting? It adds. Adds what? Asif. So Narendra gets 13, 24, and 35, the numbers. Thank you very much, Asif. Do we agree? I tend to see if everyone agrees to Narendra. Thank you, Asif. Now here what happens is there is a element wise addition. That means first element of the first array will be now performed operated with the first element of second array. Second element with the second element. The third element with the third element. Good. So every individual element will be matched up together and perform the operations with. Good. Great. What I can see is 13, 24, 35. So 10 plus 3, 20 plus 4, 30 plus 5. Clear? Similar kind of operation. This is done using the basic Python operator, which is plus. Right? This is the basic Python operator plus. But can I do through NumPy? The answer is yes. Print NumPy dot add what? My array X and array Y. The only difference is this plus is common to any kind of things, right? It can be plus with a list, it can be plus with the two numbers, could be anything. NumPy add function is a NumPy function. It's applicable not for everything. Good. Still see the same output. So result wise, you do not see any difference, but there is a processing speed difference and efficiency wise, there is a difference. Good. The difference is in terms of efficiency. Great, everybody. Yes, no, maybe confirm. Thank you. Can I do that similar fashion subtraction? Give me the code string. Pythonic way, x minus y. Good. 10 minus 3, 20 minus 4, 30 minus 5. May I know why the results are repeated twice? Because I have used two different statements. Asif. One is the print statement using the Pythonic way, and another is using the NumPy way. Great. Now, for the subtraction. Length of the array should be same. I will come to that, Sitish. So x minus y, and I'm going to replace the word add with the word subtract, not sub. The word is subtract. NP dot subtract. Works well. Good. Again, two outputs because minus operation using Python, minus using operation NumPy. Good. Multiplication. So x multiplied by y and NP dot multiply. Good. Division. I'm putting down all things together now. X divided by y and NP dot divide of x comma y. So divide x by y. Then we have the modulus. Modulus or the remainder, right? You can say that. Modulus. X percent y, or you can put np dot mod, mod. And lastly, we have the floor division. Or this is exponential as well, right? So floor division. X double slash y and np dot floor divide. Name of the method is floor underscore divide. Objective that I'm trying to achieve is to get you acquainted with the name of the functions that are used in NumPy to perform the arithmetic operations, which are the basic arithmetic operations from the core Python. How can you perform them using NumPy? Sensible? Not sensible? Yes, no, maybe. Thank you. Last option that I want to put up is your exponential. So x operator that we use in Python is double star, x raised to y, or here I can put up np.power. Name of the function is np.power. Done all the executions. Can you check that? Any questions with the results or the outcomes that has been displayed to you? Let me know. Please explain the floor division and power. Good. So floor division, I got these results. Power, I've got these results. Are we good? So floor division, I have 356. Good. Let's have a look. I have 10, 20, and 30 as a part of X, and I have 3, 4, and 5 as a part of Y. When I perform a floor divide of X with Y, what does essentially that means? Essentially, it means, now I'm not pretty much sure how many of you know about the floor division very correctly. Taking first example, let's say take up the example of 10 and 3. Good. So what I'm trying to say here is with the floor division, that when you're doing a 10, a floor divide by 3. Good. Essentially, it means that I have to perform a division of 10 by 3. Can you tell me what will be the result as if I divide 10 by 3? It's going to be 3.33, right? Acceptable? Thank you. Now, we look into the number line. In school, you would have studied about the number line that has a 0 at the center. You have minus infinity on the left. You have positive infinity on the right. Right? Good. On to that number line, let's imagine this is 1, this is 2, this is 3, this is 4. Good. If, let's say, on the other side, I have minus 1, minus 2, minus 3, sorry for that mistyping, minus 4, and so on. Good. Now, the division result that I get, what is my division result? 3.33. Where will it lie? On that number line, that's going to be somewhere here. Agreed? That red line. Great. From that red line, the floor division, the concept of floor division says that whatever the division result is, right, in absolute terms, from that point, move towards the negative infinity. I need to move towards negative infinity side. Good. That means from here, I'll move towards negative infinity. That's on to the left. Good. Once I move towards that side, whatever is your first integer value, that is your answer. So floor division is a value coming from the division results moving towards the negative infinity, or rather our integer value, the nearest integer value. Good. So I'll get 3 over there. Make sense? If I talk about 20 and 4, so that come out to be 5. When I divide that is 5. So I do not have to move at all, right? It will remain at 5 somewhere. I do not have to move around because it's already an integer value. 30 by 5 is 6, so I'll already have 6. So 356 should be the answer. Good? Did you understand the ideology behind? Thank you. So can you tell me what will be the output of this? Double slash floor division operator. Can you tell me what is the output of this quickly? Don't execute it. Minus 3, I tend to disagree. Chinna, Keshwara, 14, minus 14, never allowed. That's way different. Minus 3 is not right. Minus 14 is not right. Minus 4 is right. Thank you. How many of you can get to know why it is minus 4? Because a very common understanding that people think about floor division is rounding off. No, floor division is not rounding off. We need to understand this very clearly. Let's take into consideration a simple example, very simple example. What if I ask you 17 double slash, or let's say 19 double slash 5? What is the result? Think of it. 19 double slash 5, when you will do it, not 19 double slash 5, I'll put it up as 95 double slash 5 or double slash 50. What was the result that I'll get? I would get 1.9, isn't it? Now, if I round off, that should become 2, right? A rounding off should make it 2. But floor division will give me 1. It's not clipping off the decimal point, but from 1.9, if you move towards negative side or to the lower integer value, then 1 will be the integer value, correct? Similarly, if I do minus 7 double slash 2, let's say for example, this one, the previous example, the division result is going to be minus 3.5. From minus 3.5, if you move towards negative infinity, you'll reach to minus 4. Sensible? Thank you. Coming to the exponential function, Asif, can you tell me what is the value of 10 raised to 3? 1000. What is the value of 20 raised to 4? Whatever that number is. Right? 2 into 2 into 2 into 2. So that's 1000, not 80,000. 10 raised to 4 should 20 raised to 4 should be 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 160. So 160 and 4 numbers, 4 zeros. So that should be 16 million, close to 16 million or 1.6. Let me just check. Yeah, 160,000. 160,000. Good. Similarly, the third one that I have 30 raised to 5, that's 243. So 1, 2, 3, 4, 5, 6. So that's 24 million, 24.3 million. Good. Hopefully good. Exponential, Asif. Exponential means raised to the power. Any questions with the arithmetic operators team quickly? All kind of operations. There are 7 operations that you do in multiplication in terms of mathematics, and I've talked about all of them. Clear? Let's talk about the statistical function. The mathematicians in the house, economists in the house, help me with the statistical functions. Can you list out the names of statistical functions which are prevailing or which are very common in statistics? Got few responses like range, variance, mean, median, mode, standard deviation. Anything else? Apart from this, let me just check. No, nothing else so far. Variance has came in. Okay, good. Variance was there already. So statistically, to talk about, there are many statistical functions which hold the relevance in the field of data analytics, in the field of data science, in the field of machine learning, in the field of artificial intelligence. Many statistical functions are there. Essentially, many of the inferences, many of the conclusions about the data are derived through these statistical norms. We'll discuss those statistical functions and their relevance with respect to the data at a later stage, not now. Why later stage? Because I want to talk about some data first, and then we'll talk about the statistical functionalities of those data and what is the relevance of those statistical values. As of now, our concentration is to understand what are the different statistical functions that we can use and how to use them. Good. For an array. Great, everybody. So we'll talk about statistical functions of the nature. Number one, a mean. Talk about mean. Let's talk about median. Another important, speciality in statistics is mode, which is not available in NumPy, so I'll not talk about mode. Then we have standard deviation. We have variance. What else? We have percentile. Then we have a range. Then we have interquartile range. Good. So basic things. There are few more tools like covariance and correlation. I would not like to introduce them right now. We'll talk about them at a later stage. Why later stage? Because it does not make sense right now to talk about them. Good. Let's talk about all these things. How many of you know what is mean? Everybody knows what is mean. So mean is the sum of all number. Forgot Asif. So mean means an average, right? Suppose if I talk about 1, 2, 3, 4, and 5. So the mean would mean that I sum up all those values and divide with the number of values that I have. So add them all. That becomes 5 plus 4, 9 plus 3, 12 plus 2, 1, 14 plus 1 is 15. And I'll divide that with the count of values. 1, 2, 3, 4, 5 values. 15 by 5, that equals to 3. So I've got a mean value is 3. Good. Add all, divide all. Divide by the count. That's your mean. What is the purpose? So mean is the central value. We'll talk about what is the centricity and everything. But mean, how do we calculate that in Python? I'll take an array ARR is equal to any random array. Good. I've taken some values. I can find out print np.mean numpy.mean value of the ARR. That's going to give me the mean value of the array. Good. 74 1 point whatever that number is. It would have added all those numbers and divided by that count. Next comes is the median. What is the median? Anybody? So median is the centrally positioned value when the data is arranged in an order, like ascending order or descending order. So if I talk about in this particular scenario, you can look at this. I have numbers 1, 3, 3, 1, 3, 4, 4, 3, 2, 4, and 572. So that will look like 1. If I arrange that in order, 1 followed by 2, then followed by 3, 3 2 times. So 3. Why it is not typing in? Something was wrong. So let me put up 3, comma 3. Then I add 4, 1, 2, 3 times 4. 1, 2, 3 fours are there. Good. And lastly, I had 572. Correct? That's how the number look like. That is something that I've arranged in an order. Right? Ascending order, descending order does not make a difference. But usually we'll do it in ascending order. Now once that is done, now I need to look at it centrally positioned. In terms of central position, you can think of, let's say, take 1, 2, 3 numbers from the left, 1, 2, 3 numbers from the right. Good. Now I'm left out with two central values. If I take both of them off, I will not be left out with any number. So I need to look for a central value in between them. So that will be the average of those, or mean of those, 3 plus 4 by 2. That is going to be 3.5. And my median is going to be, for this data, a 3.5. Are we good? If there are two numbers left at the center, take the mean of them or average of them. If there is a single number, that becomes your median. Good. Same functionality, same methodology, only the name changes from np.mean to np.median. 3.5. Good. Next comes the standard deviation. With the same data, I'll talk about the standard deviation, STD. Good. We'll talk about standard deviation. Functionality is by np.std. And you can see, look at this value. It says 188.18. Anybody knows how is the standard deviation calculated? I'll give you the formula right now. I will not explain what is the purpose. The formula for standard deviation is, you can note it down on a piece of paper. It is usually represented by a letter sigma, and sigma is equal to, is given as square root of sigma, there is summation sign, of every value minus the mean, which is usually represented by letter mu, the whole square, divided by n, where n is number of elements. So I is equal to 1 to n. Okay? That's the standard formula for standard deviation. Are we good? Do you want me to practically solve that for the current data that I've used? How did I read? How has it came in with 188? Okay. Very simple thing. Keep that formula in the mind. So my x has value 1, 3, 4, 4, 3, 2, 572, and 4. Agreed with this? This is my input x. My mean value is 74.125. Good. So 1 minus, so I will try to find out x minus the mean value. That will be minus of 73 point something, right? 73.125. 3 minus this, so that is going to be 71.125 on the minus side. Good. Abhinay 3. And so on for the rest of the list. 4 minus will be 70 point, again 4 minus 70.3 minus 71.2 minus 72.5, 72 minus 74, that will come out at some value, and 4 minus something will come out at some value. Let's take up, for ease of convenience, can I take up some smaller values, simpler values? Calculation purpose. Because 1, 2, 3. Okay, I've taken this. 1, 2, 4, 5, 6. Good. Let's say standard deviation is 1.85 some number. It is easy for me to solve it. So here, my input data is 1, 2, 4, 5, and 6. Good. My mean value is 3.6. Acceptable? So if I talk of this, if this is your x, can I calculate x minus affecting outliers? I'm not going to talk about that stage at all right now. Outliers and everything will come into the picture later on. X minus the mean value. My mean value is given as 3.6. So 1 minus 3.6 is minus 2.6. 2 minus 3.6 is minus 1.6. 4 minus 3.6 is plus 0.4. correct? Then I have 5 minus, that will be plus 1.4. 6 will be plus 2.4. Agreed? Now, next I calculate the square of this term. X minus mu the whole square. Calculate the square of this. Everybody help me with 26 square. 2.6 minus 2.6 is just 0.26 square. So that is going to be minus of 2.6 multiplied with minus of 2.6. 6.76. Abhinitri, no, not 5. So I'll have 6.76 here. For 1.6, it is going to be 16 into 16 is 216. No, 256, right? So 2.56. Just to re-verify. 2.56. Then for the third one, 0.4 into 0.4 is going to be 0.08. No, 4 into 4 is 16. 0.16. Get 1.4 is going to be 1.6. Why? 0.4 into 0.4 is going to be 0.16. 2 decimal places, Mandeep. See, I am very bad at mathematics, team, but 0.16. Right. Then 1.4 into 1.4. That should be 14 into 14, 1.96, right? 1.96. 2.4 into 2.4, that should be 576. 5.76. Good. Thank you. Someone has given me that answer. So I got these square terms. What did I do? I had the individual data. I subtracted that with the mean. And whatever the subtraction result was, I took up the square of it. Good. Can you sum it up for me quickly? That's going to be 6.76. There is a reason why we do squaring operation. It's not random. It has a logic. Then I have 0.16 plus, then I have 1.96 plus 5.76. So 1, 2, 3, 4, 5. 5 numbers are there. Good. That will be your summation part. It says 17.200 something. And I have 5 numbers. So I'll divide it by the whole result by 5 to take an average. 3.44. But what I need is the square root of this term. Right? So I'll copy this and double star, since I need to take a square root, 0.5. 1.854723699099 My one is rounded off to one place. The result in a manual way and result in the Pythonic way, into numpy. Is that same? If that does not help out, what did I do? Listen to that very carefully. I found out first my individual value x of I, subtracted that with the mean minus mu. Good. Once I subtracted them, I calculate the square of each one of those and I added up that squared value. Good. Then I divided that squared value summation by the count of values. Once the division is completed, I took the square root of it. Simple, understandable, yes or no? How is the formula created? Now, many people ask me this question, why we have taken up a square? Why was there a subtraction from mean and not from any other central value? So there are a lot of things behind it. And there is a reason and logic behind it too. Now, it's not a formula. It's not random, Asif. I will not say Pythagorean theorem says a square is equal to b square plus b square is equal to c square. I'm not saying going to say that to you. If c square is equal to a square plus b square, I will tell you why it is happening, what is the reason. Everything is going to come up. But as I said that, this is not the mathematics class right now. This is a NumPy class. So I am only talking about how to use those features using NumPy. I do not have to do all this manual work, understand the background information right now. I just need to know that I can calculate the standard deviation just by merely using the function called as std. Is that good? Thank you. Again, objective is different. At this juncture, my objective is not to teach you mathematics. My objective is to teach you the syntax. Yeah, I tend to agree with that point, Abhinati. That's what I try to tell you. There is a huge conceptual meaning of standard deviation in terms of data analysis, data science. Huge meaning. But I tend to not use it right now. I do not want to get into that field right now because I have to explain you a lot of things about the data distribution. I have to talk about probabilities. Before I come to that part, what role standard deviation plays? How is the standard deviation such an important factor when you deal with the data? Right? It has a very, very deep meaning for us. Very deep meaning. As data scientist, analyst, whatsoever profile you think of, similar fields. Good. But as of now, please concentrate on the fact that you know how to calculate the standard deviation using NumPy. I am not asking you to interpret what does it mean. Just understand how to calculate. Good. Thank you. Let's move on to the next property, which is variance. See, variance also talks about the same strategies, same scenarios, what standard deviation talks about. Same thing. Formula wise, there is no such difference. In standard deviation, which was represented by a letter sigma, that was equal to the square root of summation sign, individual value minus the mean divided by the total count of values. Good. That was the formula. Good. Now, in variance is nothing but a squaring operation. Square on left side, put up a square onto the right side. Square of the same thing. So essentially what is going to happen? I am going to remove out this square bracket. The square root operation is not done. So essentially 1.85, if I take a square of it, I'll get the variance. 3.4. Right? Manually also we got that. Good. Next comes the percentile. What does percentile represent? Anybody? It's a value. See, I've not written down any definition for mean, median, standard deviation, variance, but I'm putting it for percentile. It's a value in the set or in the sorted set of data, that depicts a value which, excluding itself, excluding itself divides the data in percentage. Now, may not make sense to you. Okay. In order to understand the concept of percentile, try to look at the same data 1, 2, 3, 4, 5, 6. Get if I write down that in order 1, 2, 4, 5, and 6. If you look at number 4, right? Look at the number 4. If you exclude that number, good. If you exclude that, the remaining data that is left out, 50% is lesser than that value, isn't it? And 50% is more than that value, isn't it? Correct? That means this is the data point that divides the entire data into two equal halves. If you go lesser than that, 50% will be the less number of values, 50% are more than that. And that is what percentile tells you. So if I just give you a simple example, let's put up print np.percentile. Percentile of the ARR, which percentile value? 50th percentile. Good. And you can see the same value coming up. 4. You can also look at some very prominent percentile numbers which are of use. We call them as. So one of the important percentile is called as 25. Another important percentile is 75. Very important percentile numbers. Look at this 25th percentile and 75th percentile. 25th percentile says 2, 75th percentile says 5. Look at your data and then tell me. Same data that we have here. 25th percentile means what? Once you select a value, remaining values that are left out, I have left out with 1, 4, 5, and 6. Good. So the remaining values that are left out with remaining data that is left out, 25% of that is less than that value and 75 is more. That is 25th percentile. Similarly, when you took 75th percentile, that will be that 75% of the values are lesser and 25% are more. Sensible? Thank you. Can you tell me what will be the 0 percentile? Is nothing but it's the minimum value, right? And if you talk about the 100 percentile, that is the maximum value. Good. Always remember this. This 25th percentile in statistical terms is also called as Q1 or quartile 1. Good. The 75th percentile is called as quartile 3. 50th percentile is called as quartile 2. Minimum value is also termed as quartile 0. This is considered also as quartile 4, Q4. Now, what is the purpose? Very important purpose. There is a data, right? Starting from this point till this point. Good. That is your minimum value. Agreed. This is your maximum value. When you divide that data into two equal halves, what you will have is a central line. This is called as your median, right? Which is equal to nothing but the 50th percentile, which is equal to nothing but Q2. Why Q2? I'll come to that point. Now, when you divide that entire data into four equal spaces, that means 25%, then 25%, then 25%, and 25%. No, there is no function for mode, right? So, first 25% data lying here, next 25% here, third 25% here, and remaining 25% here, right? So, I'm dividing the data into four quarters, four different sections, right? This first quarter, right, starting from Q0 ends at Q1. So quarter one ended over there, quarter two ended over there, quarter three ended over there, and quarter four ended over there. Get endpoints. Essentially, quarter four and max are same, quarter zero and minimum are same. Quarter one is your 25th percentile, quarter three is your 75th percentile, quarter two, median, and 50th percentile are same. Are we good? Just a nomenclature team, just to understand. Good. Thank you. Now, there is a huge implication of that. Next statistical property that is very prevailing is called as the min and max value. Min and max. So I can find out print np dot minimum of my ARR. That's my array. I can print the maximum np dot ARR the max. np dot max of the ARR. Good. I have an extra p over there. So minimum maximum values printed out. Slight difference that you can notice with the percentile, there is a mathematical calculation with the division operator, and hence I have a floating point answer. But here there is no mathematical calculation, it's just directly finds out whichever value is there and gives me that value. So that is why I can see the integer output, because I have the original data as integer. Yet, but the value is the same, min and max. From there comes the range functionality. Range. So range is the difference between, see, all these things have a relevance at a later stage. So I want you to make sure that you know the function, the numpy function, not the logic, why and when and how to use them. No, just know that what does it mean and what it tells you. So syntactically, difference between the maximum and minimum value, right? That is called as your range. What it tells, we'll talk about that later. So I can find out print or the range of the data. Let's put up, I'll put up that as print np dot max of ARR, right? Maximum minus np dot min of ARR, right? So maximum minus minimum, we need to do that way. Good. I get my range. That's the value number 5. Or there is something else which is called as the interquartile range. Interquartile range. Interquartile range is the difference between the 75th percentile and 25th percentile. Good. So how can I get this? np dot percentile of ARR, which percentile value? 75th percentile. And again, same thing. Both has a relevance, 25th percentile. Good. So I got the interquartile range as 3. Good. In the outputs that I've shown up so far, Do you want me to put up some messages, right? Like let me in the output like this formatted string, mean is, and then this thing. Do you want me to format like this? I can do it, but I don't find the relevance again. That's the purpose. Considering there is no input coming through, assuming people want it. Right, rest you can do on your own. Just a piece of writing the text in Python. I'm not teaching Python to you guys. Questions so far, team? Any questions? Please let me know. We talked about these statistical functions. Let's talk about the next part, which is the string functions. Do you know about strings? Yes, no, maybe. Please confirm. Thank you. Great. So if I talk about an array, till now what we have used is an array for numbers only. But when I created array, I used list. So what if I think of an array? Let's say I create up a list here. This is a list that I'm creating up containing first value as Narendra. Good. Next value as Abhinitri. See, that's going into the reverse chronological order. Abhinitri has an extra H. Third one is Akshay. Good. My basic question is it a valid list? First of all, is that a valid list? Great. Now, if this is a valid list, can I create an array out of it? Let's say names is equal to np.array. Earlier also, I have created arrays using valid list. So if I create this, what happens? A valid array is being created. But if you look at this front, names dot d type, if you look at the data type of it, that's going to be type object, u10. Can someone tell me why u10? What does that mean? Hopefully someone can. Say no if you cannot, so that we can save on time. Maybe the maximum number of characters. Okay, great. No idea. Thank you. See, the idea is the representation of the array. This is an array. So that means I am representing every element of this array into the memory. My every element is a string here. So whenever there is a string array that contains string elements, right, it allots a space in my memory, right? So if this is a string input, it finds out whichever is the largest string, the longest string, right? So here I have a string that is Abhinitri that contains 10 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 characters. So it thinks that the longest string requires 10 characters. It allows 10 characters for this. Another one also string will get 10 characters. So every character, every individual input will have a space of 10 characters. It may acquire the entire 10 characters or less. Sensible? Great. So that is why U10. The word U stands for Unicode. That means I am representing those string things in numerical format in my memory using the Unicode character format. I'll not talk about what is Unicode character format. Essentially, any character from any language in the entire world. Known languages, right? Unknown languages I cannot promise. But almost like more than 200, 250 languages are, the written and spoken language, not computer languages, right? Whatever symbols they have are available in Unicode. Good questions, if any, till now. So U stands for the word Unicode and 10 represents the number of the or the length of the longest character. But that is not my problem. My problem is with the string functions. That is what I want to talk about. Good. Now, what happens is NumPy offers me a separate module, a sub-module. We call it as a char module, CHAR. What if I write down? Suppose this is an array. Good. Execute. Now, let's take up another array here. Let's say greet. Let's say Narendra, I want to say Mr. Abhinetri, I want to say Miss. Akshay, I want to say Mr. Okay, just a simple thing. Now, I want to print out greet plus names. Could not work. See, there are two arrays. I'm trying to add them up. I want to print the greet one on one, Mr. plus Narendra, Miss plus Abhinetri, Mr. plus Akshay. Had that been numbers, that would have worked, correct? That would have worked. Or this was not available in the earlier versions of Python, but now, see, with string it can work. I can write down a string, Mr., and I can put up a plus symbol and I can add Narendra to that. That will work. This is going to work, no problems. Narendra. So I can add two strings. Concatenation can happen. But here it is not happening. It's not happening over there. Mr. plus Narendra is not working because we know that addition is supposed to do element-wise things for array, but it's not happening with the list with the string. So how to solve it up? So earlier, if I talk about in historical manners, this was not allowed. In recent versions of Python, this has become allowed. That is, I can write down numpy.add function, the numpy add function, and I will tell it I want to add the greet array with the names array. In recent versions, mine Python version is a little older one, but in recent versions, this has started working. You can directly use add. But if you do not get that working, you can also use this character functionality. So NumPy has a char submodule, which I can use, and that works. Can you see this? MR Narendra, MS Abhinetri, MR Akshay. If I missed out on the title parts, team, please pardon me on that. Are we good? Not good? Yes, no, maybe confirm. Great. So again, I will not get into very much elaborative nature of this np.char. Why? Because it is not supposed to be used, in real world scenario. Whenever there is a string kind of situation, we generally do not prefer using numpy. We do not prefer using that. We directly go on to the string methods. But just to showcase, I'll just try to show dir np.char. What is that going to give me? It's going to give me the list of all functionalities which are available in NumPy character submodule. These are the functionalities. If you take out into the picture these underscore things, these are the functions which are available. Give that a read and tell me if there is something new which is different from the basic string functionality. One or two might be different, right? And depending upon the version of Python that you're using, you might have some different options. Good team. So like converting string to lowercase, uppercase, removing the characters from left or right, stripping those things, splitting the string, checking for the alphanumeric thing, and rest on basic functionalities of strings. The same things are available with the Python too, with the NumPy. So we'll not delve into that. Good. Questions? Can explain again. What part? I can explain anything. Cannot. But which thing? Okay, Kunal. Let's take a simple example. Suppose I write down a name. Let's say a variable name is equal to a simple string. Let's say your name, Kunal. Acceptable input? Good? Great. Now, I want to convert your name to uppercase. How can I do this? First method I can use is name.upper. Good. That gives me your name in uppercase. Agreed. Now here, name is a string. Good. And I'm using a string function called as upper. Acceptable? Thank you. Now, instead of doing this, if I write down np.char.upper of name, the ideology changes that now I am trying to do the same thing. I'm converting a string into an uppercase character string, but instead of using the normal Python, I am now using the NumPy. Sensible? I still get the same result. The difference, the output with a string, I'll get a string. The output with NumPy char module, I'll get an array. Are we good? If not good, tell me. So when I use NumPy, I get the output as an array. When I do not use NumPy, I get the output as string. That's the difference. Otherwise, in terms of functionality, in terms of the results, no such difference. Hope so everybody is okay with that. Great. Thank you very much. Now I'll talk about some NumPy miscellaneous functions. Why I'm putting the word miscellaneous is because these are too many functions. Repeat percentile, okay. Okay, let's take up this 1, 2, 3, 4, 5, 6, 7, 8, and 9. Good. Can you tell me how many numbers are there, Asif? Count of numbers. 9. Great. If I ask you to choose a number that divides the data into 50-50 ratio, can you tell me a number? Number is 5. Why you chose 5? Because the remaining digits are 1, 2, 3, 4, and 6, 7, 8, 9. Correct? So I have 4 numbers onto the left. I have 4 numbers onto the right. Acceptable? 50% lower than that, 50% upper than that. Good. Now, if I ask you to choose a 75th percentile, what does 75th percentile means? That means there will be some number in such a manner that below that there will be 75% of the remaining data. and above that will be 25%, excluding that number. So number is not included. Can you tell me what can be that number? It has to be exact 75-25 difference. Till 7. Why? Tell me the number. Exact number. 75th percentile. Why? You said 7. So let's assume you're right. Assume that you're right. Good. I'm not saying you are. So 7 is your 75th percentile. I'm left with 8 values, correct? So 75% of 8 is going to be how many? That is going to be 75 into 2 is 150. 150 into 4 is going to be 6 values. So I have 6 values lower than that and 2 values upper than that. Agree. Good. 7 will be your percentile. 75th percentile. Are we good? Did you understand this? Logically? Right. What if I add another term here? Just for the sake of confusion. Why multiplied by 4? See, I tried to solve my mathematics as if I had to do a multiplication by 8. So I do it multiplied by 2, then multiplied by 4. That was I was trying to look at. That is a calculation process. Let's suppose, what if I have a number 10? Let's suppose I have a 10 over there too at the end. Can you now tell me what is the 75th percentile? Will it change, first of all? Will the median going to change? The 50th percentile? No, it's not going to be 8. Asif. Because if you take 8, you have 7 values lower, you have 2 values upper than this. So out of 9, 7 by 9 is some percentage and 2 by 9 is some percent. That is not definitely 75-25, correct? Not even a 7.5 quotient. It has to be 7.25 if I'm not wrong. Just to showcase. NP.percentile percentile number is 75. I think so. It's 7.75. Yeah, correct. Not 25, but 7.75. 70% is going to 7.75. That may not be the exact number in the range. It can be something in between them as well. If you look at the 50th percentile, that's also not going to be 5 or 6. It is somewhere in between the 50th percentile. 5.5. Right. Great. So when I take that up, I need to divide this data into such a manner that I need to find out a number, let's say 25th percentile. That means 25% of the value will be lesser than that and 75 would be lesser than that. So if I have altogether 10 numbers, I would require to see a value somewhere. There are 10 numbers. So that means it has to be divided in 25-75 ratio, right? That means I will have a value somewhere here between 2.5 and between 2 and 2.5 such that these values are lesser than and these values are greater than. Right. So first division will come between 2 and 3 for me. Between 2 and 3, I would again require 25-75 ratio. So 25 will come this side, 75 will come this side. 2.25 should be the answer for 25th percentile. Or 3.25, right? Somewhere like that. Good. It starts with the 1, not 0. That is why 3.25. Any questions, team? Can I move on? Again, please understand, the objective is not to know how to calculate percentile. That's mathematics. I do not want you to learn that. I want you to know that the relevance of using percentile. The idea is, let's understand first of all, very simple idea. Suppose I give you two numbers, that is 1 and 10. And I want you to tell me that I want to create a data wherein I have the values that starts from 10, which closes at, which starts at 1, closes at 10. 10 is not included. It is not included. Good. And I want to keep a gap of 1 between two values. You will say the numbers will be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Agreed? Thank you. And that is what we do with the arange function. So arange function essentially generates the array of numbers that will be with the equal gap. How is the syntax? The syntax is, I can use numpy dot arange and tell it the number I want to start at. I want to start at 5, comma, the number at which I want to stop at 25. And then I want a gap of 3 between consecutive values. So what I'm telling you here is 3 terms: the start value, a stop value, and a step value. Step value means or a gap. So what did I say here? 5, 25, and 3. So what I want here, start with 5, end with the 25, and keep a gap of 3. So 5 will be my first value, plus 3, 8, plus 3, 11, plus 3, 14, plus 3, 17, plus 3, 20, plus 3, 23. Plus 3 will become 26, which is beyond 25. I can go up to 25, but not 25. Is that okay? If you look at the outcome of this, can you see the same numbers? 5, 8, 11, 14, 17, 20, 23. All right. So there are 3 important things that we need to notice. That we need to tell it where we want to start at, where we want to stop at, and what is the gap that we want to use. Now, I have a variant of this, not in terms of variant, but the choices. I would say that. Friends, what if I do not tell it this thing? See, here I have 3 comma separated values going to the function. What if I just mention friend np.arange and I just tell it 25? I do not tell it any number other than this. What you will notice is that it started with 0, ended with 24, generated 25 numbers with a gap of 1. Essentially, if you look at this statement, I can write down it in elaborated form as np.arange start at 0, comma, stop at 25 with a gap of 1. Eyes, nose, babies. Thank you. Now, so when I mention a single value, it means I will start from 0 and I'll end at the given number and I'll keep a gap of 1. Though I have in control whatever the things that I want, I can control where do I start at, I can control where do I want to stop at, and I can also control the gap between. The gap can also go in a negative factor. For example, what if I mention that I want to start at 10, stop at 0, there's a gap of -2. Essentially means that my first number is 10, second number is 10 plus of -2, that is 8. Third number is 8 minus 2, 6. Fourth number is 6 minus 2, 4. Then 2, then 0. But 0 will not be included, it is excluded. Good. 10, 8, 6, 7, 4, 2. Are we good with the arrange? Thank you. Next functionality we have is called as linspace. That stands for the word linear spacing. Linear spacing means same idea. This function is used to generate 1D array of numbers within a specified interval with a specified, I had missed the word gap over there, right? With a fixed gap between consecutive values, and there is an AND condition. And the AND condition is that of specified count. When I say specified count, suppose if I ask you a very simple question, let me see how many of you can answer it. Good. Let's take a number 1 and 10. Good, two numbers. I want to start at 1. I wanted to close at 10. Good. That means the first value is 1. The last value is 10. Good. And I tell you to design it in such a manner that there are 5 numbers. So 1 is this, 2 is this, and I need 3 more numbers in between. Can you tell me? The only question is that the gap between 2 numbers will be equal. Can we say that that is going to be 1? What could be the next number to you? If not, you're not able to calculate mathematically 4. No, 4 cannot work. 4 plus 3 is 7 plus 3 is 10. That does not work well. 3 cannot work well. 1 plus 3 is 2. No, 2 is not possible. It will be sum in decimal point notation. But how will I put it up? I'll put a print np.linspace, linear spacing. I want to start at 1, close at 10, and I need 5 numbers. So 1, 3.5, 3.25, 5.5, 7.75, and 10. If you look at the gap between these two numbers, or these two numbers, or these two numbers, or these two numbers, is that same? But the numbers of number generated, count of the numbers generated is 5. 1, 2, 3, 4, 5. If I put it up here, I want 10 numbers. It gives me 10 different numbers. If I need 100 numbers, it gives me 100 numbers. Are we good? The only strategy, the only change, the only ideology that we have between the linspace is that between the given interval, I will have an equal spaced interval values, but the count shall be controlled. In A range, what we control is only the gap. Here, in A range, I control that how much gap will be there between two consecutive values. Here, I'm not controlling the gap. I'm leaving it out. What I am controlling is the number of values being generated. Sensible? That's linspace. Next, we talk about the random submodule. Very important. You may not find a relevance of arange. I can repeat that, Narendra, not a problem. So linspace is talking about linear spacing. Suppose, Narendra, there is a one number called as 2, another number called as 20. Good. I have told you that this is your starting point, this is your stopping point. This is given. And now I'm asking you to give me 4 values. I want a data that contains 4 values. And the condition is that any 2 consecutive values will have equal gap. So essentially now what I'm looking forward to is a set of 2 values. I need 1 and 2 more values because 2 are already there. I have 2, I have 20. But I need 2 more such values such that the gap between 2 and this, the gap between this and this, and the gap between this and this is same. Sensible? But I have specified that I only need 4 terms, not more than that. So how can I get that? I can give a mathematical solution to do that too. Think about 2 numbers. Let's say I put up here 8 and let's say 16, let's say 15. Now the gap between 2 and 8 is 6. Between 8 and 15, the gap is 7. Between 15 and 20 is 5. So this gap is not equal, though I have 4 numbers only. So I need to alter that gap somehow. It has to be between 6 and 5. Let's make it 6.5. Let's see what happens if I make the gap as 6.5. 2 plus 6.5 is 8.5. 8.5 plus 6.5 is becoming 15, and 15 plus 6.5 is 21 points. So that does not make difference. So I will have some more gapping difference. Exact calculation wise, how will I get to know? I have starting value 20, ending value 2, starting value 20. I need 4 numbers. That will be ending value minus this value plus 1 divided by the count of numbers that you want. So that is going to be 18, 19 by 4. That will be the gap that I would want. Just the mathematical explanation, 19 by 4 is 4.75. I would require a gap of 4.75. So 2 plus 4.75 is going to give me the next number, which is 6.75. 6.75 again give me 11.75. That becomes 1 more number, 16.25. So I need 1 number less. So divided by 3, that will be the gap. 6.33 is the gap that I would require. Start with 2. The next number is going to be 8.33. The third number is going to be 14.66, and then I will have the last number. The gap will remain same. If you do not agree, you can look at this example. I can write down np.linspace, and I ask it that start from 2, end at 20, and I need 4 numbers. You will see the first number being 2, second number being 8.33, third number being 14.66, and so on. So 2, 8, 14, 20, gap of 6. Why did I put 19? Oh, that should be 18 by 3. Correct. 6, gap of 6 will be accepted. Make sense? Between two consecutive values, the gap remains same and we have the result. Thank you. That's the use of linspace. It has a utility in real world. It has a meaning in the real world. It has a purpose. But as of now, we are only concentrating on the syntax part. Okay. So as of now, try to understand, team, the objective is not to know when and what is the relevance. As of now, the objective that I'm trying to fulfill is to know that we can do this. Good. Next is a random submodule. Random submodule of numpy is a module that is used. It is a submodule or subpart of library, right? Submodule of numpy that is used to generate arrays with random numbers. Good. So if I have to create an array with the random numbers, I can use that. The first function that I have is called as rand. Right? Rand function. What is the utility of it? It is used to generate it is used to generate any dimensional array of random floating point numbers. Floating point numbers means numbers with a decimal point notation. Floating point numbers between half open interval of the other way around. So open on 0 side, right? So that should be good. 0, comma 1 close interval. Half open interval of 0, comma 1. Now, I'll ask a very basic question. Read the statement that I've written down and tell me if there is something you cannot comprehend. I'm okay if you cannot comprehend even generate dimensional array, random, floating, half open, anything. But tell me. I'll explain. Somebody? No one? 0, 0.5, 1. What does that mean, Kunal? I've not yet talked about the syntax, Kunal. So it does not find that message that you put up relevant with rand. You may have that relevance for linspace. You may have that relevance for arange, but not with respect to rand. Half open interval of, so I guess I am assuming you're trying to talk about half open interval means dividing that into half part. Is that what you're trying to say? So 0, 0.5 and 1. What does it mean? Half open interval. Mathematicians in the house. Let me just check. I have mathematicians in the house. Let me just check with them first. They will help me. See, team, I'm only looking forward today to complete NumPy if I can. So I have all the time in the world to discuss. Mathematicians in the house. Narendra says half open and means 0.0 less than equal to x less than 1.0. Great. Here 0 should be excluded and 1 should be included. Open means inclusion and closed means exclusion. Abhinetri. So I tend to agree with the definition that Narendra has given. You are right on target, but slightly different. The word excluded and included needs to be replaced. So when you talk about half open interval, essentially that means that wherever you have the round bracket, whichever side, that value is inclusive, and you have a square bracket that is exclusive. Essentially, what does that mean? That the data can go up to a value where it is open, but will not reach to the value which is closed. Get? Closed is a square bracket. Round bracket means it's a mere representation in mathematics. I am not even bothered about it. Just to give you little jargons. I talked about that word. Right? So rand is a function which has a by default range of 0 to 1. It has a range of 0 to 1. Its objective is to generate a random data of floating point decimal point notation numbers between the range of 0 to 1, with a limitation that 0 may appear up because it's random, so we cannot guarantee that 0 will come, but it may come up, but 1 will never come. That is what half open interval means. So when you mention an interval in brackets like this, if you mention two round brackets on either side, that means this is inclusive, this is inclusive. If you mention a square bracket on any side, so whichever side has a square bracket, that is exclusive. That means that value is not available, but other value is available. Good. If there is a round bracket, value available. If a square bracket, not available. Thank you. So let's try to generate some random array. Now, I mentioned any dimensional array. So let's try to create up a 1D array of random data. So I'll try to use print. I'm not saving that to a variable. NumPy has a random submodule which has a rand function, and I need an array of a shape of 5 data points. Now I've mentioned one data, 5. That means I need 5 random points between 0 to 1. That will become a 1D array. Can you see that? Is it 1D? You will not have the same values as I have. It will be different. Good. If I need 2D, into the same parenthesis, I will mention the shape. Let's say I need 5 rows and 3 columns. Look at this output. 5 rows, 3 columns. If I need 3D, I will mention 3 different shapes, 3 different, dimensions. When I mention single value, single number, 1D. When I mention 2 numbers, 2D. If I mention 3 numbers, let's say 2, 2, 2, 2 rows, 2 layers, 2 rows, and 2 columns. I am putting W. Good. What did I miss? Another bracket. So here you can see it's 3D. Sensible, not sensible? Yes, no, maybe. Now, similar to that, we have another function similar to rand. We have another function called as rand, not rand, but random. Name of the function is random. Not something wrong copied. Name of the function is random. It is used to generate any dimensional array of random floating point numbers between the half of 0 to 0, 1. Requires the shape to be given as a tuple for 2D or more dimensional arrays. So the ideology between random and rand is the same, right? It is going to generate random floating point numbers of specified shape within the interval of 0 to 1, half open interval. Good, 0 inclusive, 1 not inclusive. But the only difference is, if I just talk about, is look at this part, right? I am using rand function in this example right now. If I write down the word random here, I write down the same random word over there and random over there. For the first one, it will work well, no problems, right? It works well for the first one. I can see this is the output coming in. For the second one onwards, it says there is an error. What is that error? That here I have told it that I need 5 rows and 3 columns. It knows to know that as a tuple. So I need to give that as a single entity. So I need to include 5, 3 into brackets and include that shape, 2 rows, 2 layers and 2 columns into a shape. It works well. Good. So essentially the difference between random and rand is in terms of the syntax and not in the nature. Are we good? Nature of the value is being generated by random, nature of the value is being generated by rand or same. Ask if where is the question? Confusion, rather. You can unmute if you want to. Let me just give you that access.
Hello.
Yeah, Ashish.
Good day, sir.
Well, good day.
Yeah. So actually, here my question is, so here random dot random, two
Mhm.
columns, two rows, and two. What exactly is this? I didn't get
See
this.
the last this one,
Yeah.
right here. I'm trying to generate a 3D array
Okay.
that consists of something like this, right? This is first layer containing 2 rows and 2 columns. Then
Correct.
I have a second layer consisting 2 rows and 2 columns, and I have a third layer consisting 2 rows. So look at this. This is the data. I have a depth of 2, number of
Mhm.
rows 2, number of columns 2. That's what we have mentioned over there. The
Okay.
shape. Remember, I talked about the shape property in the
Yeah.
history.
Yeah. Yeah. Yeah.
Right? So same thing. What shape of the array that I want? In
Mhm.
rand function, I do not have to mention that shape as a tuple.
Uh-huh.
Right?
Okay.
In random, I need to mention that as a tuple. That's the only difference. Syntactical difference,
Oh.
no difference in the nature, no difference in the kind of values being generated.
So here it's two rows, two columns, and like
A
two.
depth or the whatever you want to say it as depth, height, whatever you want.
Okay. Fine. Okay, sir. Makes sense.
Thank you.
Yeah.
Anybody else? Any other question? Or you can mute yourself. So random function does the same job, but slight difference in terms of syntax. Then comes the next function. People ask me that in best question, why only in the numbers in the range of 0 to 1? What if I want a numbers, floating point numbers in a different range? So here it is. That is called as a uniform function. What is the role of it? It is used to generate random floating point numbers, random floating point number array of specified shape. So shape is under my control, right? Within a specified interval, within the specified interval. But the only concern is which follows uniform distribution. Now, in a very simple terms, I'm not pretty much sure how many of you know what is uniform distribution, but I'll talk about that in a short while. Let's try to look at the syntax of this uniform function first. Good. So, friends, let's say I want an array of 5 numbers from the range of 2 to 20 in such a manner that all those 5 numbers are a floating point number representation in the range of 2 to 20. Any random number. Good. So between print, I'll let it as numpy. Please use your random submodule. And random module has a uniform functionality. Use that. I wanted to generate numbers between 2, 20 and comma. I need 1D array. So size is equal to is the parameter. I want, let's say, 5 numbers. So 5 comma. So look at that. What did I mention? A shape with the term size over there. I can avoid the word size as well. Good. And that's how it looks like. Great. Look at this. If you look at all the floating point numbers that are being generated over there, are those numbers between the range of 2 to 20? I have used a word in the definition that I've given, which follow a uniform distribution. Now, when I talk about in terms of numbers, whenever there is a data, right, a data in a particular range, see, I have used a range of 2 to 20, right? So I have tried to understand it. I'm not talking about in terms of mathematics right now, but trying to give you a layman definition. Mathematically, I'll talk about it later on. But suppose this is my minimum number 2. There is a maximum number 20. Good. Now, in between 2 and 20, how many numbers are possible? Let me ask it. How many numbers are possible? 18? No, Asif. If I would have put that question is how many whole numbers are possible? Then you would have said 18. Infinite numbers. There is infinite numbers which are possible. Thank you, Abhinetri. Or someone else was there. Now, in between the combination of those infinite numbers, I am looking for certain numbers whose probability of coming up, whose probability of being there is same. Let's say there is a number x1, there is a number x2, there is a number x3, there is a number x5, or so on. The probability of finding x1, the probability of getting x2, probability of getting x3, or probability is same, right? The probability of appearance is same. Then I will see those numbers as uniformly distributed. Make sense? Every single number within that range, if used, has equal probability. Are we good? Can you explain the same with our example code output? No, I cannot, Abhinetri, right now. Why? Because here I am just showcasing you the output. I can give the formula. It's a formula with respect to the probability distribution. I am not pretty much sure whether you will understand it or not. So the formula is for this, to find out the probability is given by 1 upon b minus a, where b is the maximum value and a is the minimum value. So 1 by 18 in my case, that will be my probability term. So any term in my entire data that follows, that part, it will be termed as this, right? Now, how did it reach to 8.744? Because I need to talk about, a lot of probability distribution before this, because I need to talk about what is Gaussian distribution. I need to talk about what is binomial distribution. I need to talk about what is Poisson distribution. What do you talk about? What is CDF, the cumulative distribution function? I talk about what is, the probability density function. And then and only then I will be able to make some sense with this data. It's random. You may not get the same numbers. Because the idea is to get 5 numbers that has an equal probability. There can be infinite possibilities. It is selectively choosing 5 ones. I can choose up infinite numbers. Let's say I put upon 1000. It gives me the list of 1000 numbers. So it's not that I only have 5 numbers available. There can be infinite different possible numbers that follows the same problem. The idea is with the uniform distribution is that every single number will have a probability which is equal. So whatever the probability is 2.41, same probability is held by 6.62. We'll stick to 10 numbers only. Good. That's the idea behind the uniform function. Essentially, use it for the purpose of generating random floating point numbers between given a specified interval. That's it. Right? Do not go into the distribution part. In a similar fashion, I have another function which is for random. Generate random integer number array of specified shape within a specified within a specified interval. Now, with integer array, there is nothing called as probability distribution. The same functionality, no changes at all. I'll just copy the same formula, same piece of code, but instead of uniform, I'll write down the word random. It has generated a random array of data points between 2 to 20, 2 inclusive, 20 exclusive, and 10 points. I re-execute that, I'll get a different set of numbers. You would have done it at your end, you would have a different set of numbers. Can you check that? Now, do you want me to fix it? Fix means when I execute a piece of code and when you execute a piece of code, we get the same numbers. That means fixing the randomization. Should I do it? Should I not do it? Think about a problem. Suppose you are solving a problem P. Good. That problem in its solution wants a random number to be utilized. Right? A random number. So you will Thank you. So that is the ideology. It is happening because of this seed number. If I put my seed number as any different number, 11, let's say, I and you will have a different thing. Now, many people do not understand what is seed. So I give them this example. Suppose this is your garden, right? This is your garden. If you plant a wheat seed, suppose a seed of wheat, what you will get is a wheat tree. If you plant a seed of rice, you will get a side rice plant. If you plant a seed of, let's say, a pomegranate, you will get a pomegranate. If you plant a seed of sunflower, you will get a sunflower, correct? It is not going to happen that if you plant a seed of mango, you will get an oranges out of it. Is that going to happen? Essentially not. Same thing is happening over there. Python has a particular seeds. Python has defined certain seeds, right, which is used for random value generation. These seeds are starting from 1, going till 2 raised to 32 minus 1. That number. That will come out somewhere around 42 million. Okay. So I can use 1, 2, 3, 4, 5, 6, 7, up to that number, 2 raised to 32 minus 1. Any number in between. And it has a specified sequence of numbers. Floating point numbers, it has integer numbers. Again, these are not, actually written down, these are calculated based upon the random algorithm. There is an algorithm that we study of the randomization. I will not get into that part because it's subject that I studied in 6 months and I'm still not very much comfortable with that subject. We call that as design analysis of algorithm in the field of computer science. Not to bother about it. It does not make a difference. But you can think of, there is some brain that is trying to generate random numbers. That brain has been told, okay, if I tell you number 11, generate these numbers. If I tell you number 111, generate a different set. Make sense? And no coming from the last. I was looking more of yes, not no's. Yes, Narendra Abhinetri, confirm. If your question is long, you want to get unmuted, you want to discuss, ask me to unmute. Just put the word unmute in the chat. We can talk. That is easier as compared to typing. But seed is really important for me to you guys to understand. Very important for me. It's not a part of your standard curriculum. It will not be into your documentation anywhere. It's something definitely different from what is given. But you will find it relevance later on. So I can see certain number of no's, like coming from Akshay, Abhinetri, Narendra, or anybody in the house. Till now, any questions, any concerns with any of the topics, any of the functions, any of the methodologies, any of the examples, anywhere, please ask it. There are 2 persons who have given me a rating to reduce down my pace out of 50. Is it possible to change the random numbers for the same seed? See, Preeti, to answer the question, the answer is yes. You can alter them, but that is not going to be universal. For example, let me just talk about, let's say your name. You write down as PRWTHY. Good. You can write it down as PRWTHI. You can change it yourself. For yourself, you can do it. But when you talk about your standard documentation, can you change it in your high school mark sheets or any other documentation? You cannot. Right? It's fixed over there. So similarly, this thing, it is the seed values are fixed. These are already fixed, and these are saved into the Python memory. Python already, any Python version that we have, right? Python by default generates those numbers the moment we start using Python into my memory. It generates all those sequences. Those are loaded into my memory directly without me asking for it. These are all default sequences that Python knows, which are predefined. For example, Narendra, we have 206 bones predefined, clear. Irrespective whether we are a male, we are a female, does not make a difference. Whatever kind of value, 206 is fixed. We can alter that number manually. It is possible. We can get a one bone out of our body and put it up with an iron rod or something. Possible. We can get an earlobe bone removed. That does not make a difference in the normal human lifestyle, right? Possible. You can get a bone removed from your finger, or you can add up an additional bones onto your body. Possible. But we don't do it because there are certain standards. Good. Again, I'd just like to talk about a little bit on the feedback that I have on the break part at the time of break, which is a poll activity. I have 2 people out of 15 who said that I am running at a very fast pace. There's 1 person rating 6. The rest of the people have rated as 8, 9, and 10. 18 people rated second question. So people are saying I'm going at a fast pace. Can you let me know where things which are being taken up in a fast-paced manner? I would like to take a pause. I would like to wait and then answer your queries and concern if you have any, and then move on. It is possible. I completely agree that I may have taken up certain topic in a little bit fast-paced way. That's kind of very human. I know about those things in depth, so I may have got exaggerated and maybe went on with the emotions and may have talked about that in a quick, fast-paced manner. Thank you very much for that input. But if you can just let me know things which are not clear for you, I will repeat it with slower space, with more examples, so that you guys are clear on that. Someone has drawn a green line. Jiva Raghava was the name. Yes, Jiva, if you have something to say. Jeev Raghavan. Quickly, team. Thank you very much. Now, I got a line from your end on my screen, so that's the only one reason I asked it. Great. So, till now, no questions. Hope so. Everybody's okay with the random part that I wanted to convey. It's fine, Jiva. See, my objective is to make sure nothing gets unnoticed. No need to be sorry about it. I'll try to notice every single thing. Yes, Asif. Random.random used to generate random integer array. Asif, can you give me 5 integer values? I want you to give me a 1D array with 5 numbers of integer data in a range of 2 to 20. So your all 5 values needs to be between either equal to 2 or less than 20. Less than greater than or equal to 2, less than 20. Any 5 numbers. You can choose 2, 10, 12, 4, 7. All are integers which are between 2 to 20, where 2 can be inclusive, but 20 is not there. Great. That is random integer function. Could be any randomized thing. If you talk about how many options or choices it has, 2 raised to 32, 4 to 9.96, 7 to 95. I can use up to that value for the seed term. I cannot use 6 over there. 6 will be denied. Seed must be between 0 to 2 raised to 32 minus 1. The idea is, if I use a seed value, the seed value will always give me back the same result. For seed number 10, remember, for seed number 10, if I want to get a random integer value in the range of 1 to 20, and I need 10 values, I will have the same 10 values always. If I change my range, the set of values will change. If I change the size, let's say keep the same range, I want 5, let's say 3 values. Only 3 values will be shown up. So for every possible combination, for every possible scenario, there is a given defined set, not only with the random integer. I gave an example with the random integer because it is easier to comprehend. Otherwise, for any random number generation, you can use seed. If you want to fix the randomization, suppose for example, if I use np.random.rand, I did not mention any how many count I want. It is going to give me one floating point number. Good. Look at this. I'm executing it multiple number of times and I'm every time getting different results. Good. But if I put up just below before that np.random.seed and I tell it that let's say seed value 10, fixed 0.77 this. So it has specified if my seed value is 10, rand will always generate this number. Despite how many numbers I executed, I will not have a C difference in the result. Good. So the objective of seed is to fix the randomization. If everybody is okay on that part. Next time we talk about indexing and slicing in arrays. Last topic of the arrays. Then we'll conclude the arrays and move on to pandas. If we can reach to pandas today, well and good. If we cannot, we'll move on to the next array. Good. I will try to generate some data. So let's make a data array. So data is equal to np.array. Good. Rather np dot, let's take it up from arange functionality, and I'll ask it to generate let's say np dot random function dot rand integer values between let's say 1 comma 100, and I need the size or the shape as 2 rows 3 columns, so 2, first dimension 2, second dimension 3, third dimension 3, fourth dimension 4. Good. That's the 4-dimensional thing that I've got. Good. Great. Unmatched bracket. So I have an extra bracket over there. Let's print data. That's the 4-dimensional data that I have. Good. Why it is 4-dimensional? Because you can look at this. I have 4 brackets right at the beginning. And you can look at this 4 dimensions, which tells me right at the right. Are we good? The point arises that if I wish to access any single element, let's say for example, I want to extract this 32 from here, right? Good. I want to talk about this 32. I want to do some actions on that 32. So I want to access that. I want to manipulate that. I want to change that. could be anything. But now, where is that 32? If you look at that information. So in order to tell that information, I would request you to look at the shape of this data. This is 2334, right? So what it tells me that in the first dimension, there are 2 elements. In the second dimension, I have 3 elements. In the third dimension, I have 3 elements. In the fourth dimension, I have 4 elements. Agreed? Great. Now let's try to number them up. The numbering that I'll try to do is going to start from 0. So I have, in the first dimension, I have 2 elements. So that will start from 0 and 1. Good. 2 elements done. Second dimension, I have 3. That will start from 0 again, 0, 1 and 2. 3 values. Third dimension again, 3 elements. That is 0, 1 and 2. And fourth dimension again, 4 elements, 1, 0, 1, 2, 3. Acceptable? So every dimension, I'm going to start the number with 0. Is that okay? And I'll keep up to a number or integer value on the positive side with a gap of 1. Up to the count of values of cup in that particular dimension. Now, if you try to look at it in a very simple manner, the outermost bracket, this is your outermost bracket starting. This is the first dimension, right? Which closes down at the bottom. How many elements does it have? The first element it has is this, from here till here. That is your first element. The second element starts from here and goes till the bottom, not visible in one single screen. Let me just try and reduce it down. Okay, now I can get it. So that is your outermost bracket. Look at this one. Here, closes here. The first element that I have is from here till here. Right? The second element is from here till here. Acceptable? Great. Now, if you remember my shape, that was 2, 3, 3 and 4. That is my shape. So first dimension has 2 elements. I gave them numbers 0 and 1. So first element is 0, second element is 1. Good. Acceptable till now? Numbering. Now, let's move on to the second dimension now. The second dimension is starting from this bracket, the second bracket, and it closes over there. Good. It has first element, which is from here till here. First element from here till here. Second element from here till here. Third element from here till here. Good. I'll number them again. This is 0. This is 1. This is 2. Similarly, for the second part as well, in this as well, second dimension starts here, ends over there. I have first element, second element, and third element. This is again 0, 1, and 2. Acceptable? Second dimension done. Let's look at the third dimension now. Change of color. Third dimension, this starts from over there, closes over there. Correct? So I have 1, 2, and 3. Similarly, in this case, 1, 2, and 3. 1, 2, and 3. So does here 1, 2, 3. 1, 2, 3, and 1, 2, 3 over there. Acceptable? Let's number them. So I'm putting that onto the right side. This will be 0, this will be 1, this will be 2. This is 0 again, 1 and 2. This is 0, this is 1, this is 2. This is 0, this is 1, this is 2. 0, 1, and 2. 0, 1, and 2. Acceptable so far, team? The numbering. Please follow the numbering. Great. Let's look at the fourth dimension. In the fourth dimension, this is the fourth bracket starting here and closing here. So I have 4 elements, 1, 2, 3, 4. I will number them as 0, 1, 2, and 3. Good. Let me just copy that. This is 0. Change of pen. This is a 0, this is 1, this is 2, and this is 3. And please assume that I am writing it down for all the things, right? This is all 0, this is all 1, this is all 2, this is an all 3. Good. Instead of me writing down it for every single data point. Common. Good. Now, I was asking you about 32. Right? This was the number I was trying to extract. Good enough? 32. That was my point of question. Now, tell me, out of all the dimensions that is being mentioned along with the numbering, good, the number 32, see, in your shape, you have first dimension, second dimension, third dimension, and fourth dimension. Acceptable? From the first dimension, which section, which number has the number 32? 0 or 1? There are two possibilities, 0, 1. We have that in 0, correct? So I'll use 0. Now, for the second place, right, within that 0, the second dimension, I have it in 2. For the third dimension, I have it in 2. For the fourth dimension, 0, 1, 2, I have it in 2, right? First dimension at 0th position, second dimension at second position, third dimension at second position, fourth dimension in second position. Agreed? Thank you. Now I can utilize this information and extract that value. What do I want is, in my data, put up a square bracket. Square bracket is used to extract a value. I want a data which is in the 0th first dimension, number 2 second dimension, number 2 third dimension, and number 2 fourth dimension. Did I get 32? Great. Now, on my screen, let's have a look again. And let me see, I've removed down the numbers. Let me see if you guys can tell me, how can I get 12? This 12. Where it is? See, we need to understand position-wise in terms of numbers, in terms of indices, where the thing is located. So this was 0, this was 1. So I am into 1. Into 1, this is 0, this is 1, this is 2. So I am again into 1. Within 1, I have 0, 1, and 2. So I am again into 1. And 0, 1, 2. So triple 1, 2. That should be the answer. Sensible? Please remember, whenever you have to extract a value, you need to use a pair of square brackets. Within that pair of square brackets, you need to mention in a comma separated form the position of that data, wherever it is, whichever the first shape place, second shape place, third shape place, whatever the dimension you have. If it is 2-dimensional, you will only have 2 values. If it is 3-dimensional, you will have 3 values. If it is 4-dimensional, you will have 4 values. Sensible? I've given you a very generic method. It is applicable to any dimensional array. That's indexing. Next comes is the slicing part. Confused? Okay. Why am I getting an output as np.int 3266-bit? Because you are using a little better version of me than Python. In Python 14. It's a Python version issue. How to find 12? Where is 12? X 0, 1. It is into the zeros place. Within that 0, it is 0, 1, 2 in the first position. Within that 1, it is at 0. And within that, it is again at 0. So it will be at 0th, first space, first, second space, again 0, again 0. Give that a try. You might not have the same numbers. I'll just show it on my screen because it's random data that I've generated. Let's print from my data, square bracket, 0th on the fourth dimension, then 1 on the third dimension, 0 on the second dimension, 0 on the first dimension. You always need to think about the shape. Remember the shape first, because if you concentrate on shape, it is easy. Otherwise, Numbering is very, very difficult. Sensible, not sensible, eyes, nose, maybe confirm. Now, just for the sake of understanding and make it easy to comprehend, the slicing part I'm going to do with the 2D array. Let's create another data is equal to np dot, and I'm going to take out a two-dimensional array, put up 1, 2, 3, comma, let's put up 4, 5, 6, comma, 7, 8, 9. Why I'm doing it with the 2D is because in real world scenario, you are mostly going to deal with the two-dimensional data, not three-dimension, not not four-dimension, not one-dimension. Majority of the problems you'll be solving with 2D or 1D. 3D, 4D will come, even if the data comes in that space, you will still redirect that into 2D, usually 2D or 3D. I'm going to print DATA for you. Good. Look at the numbering here. Outermost bracket, 3 elements, 0, 1, and 2. Second bracket, 3 elements, 0, 1, and 2. Acceptable? Now, if I ask you where is 1, 1 is at 0, 0. Where is 6? 6 is at 1, 2. Where is 8? 8 is 2, 1. Now, if I wanted to extract a single number, if I have to extract a single number, let's say number 6, I want to extract that. How would I write it? I write it the variable name followed by a pair of square bracket. I tell it where it is present in the first dimension. It's present in 1. Then I tell it where it is present in the second dimension. I get that value. Correct? Good enough? Now, let's change the topic. Let's change the complexity. Now, I do not need a single value. Rather, I need multiple values. For example, I need 1, 3, 7, and 9. Can I extract this? 1, 3, 7, and 9. So I need 4 different values together. So you can say that, okay, 1 is at 0, 0, right? 3 is at 0, 2. This is at 2, 0, 7, and this is at 2, 2. Are we agreeing on this point? Thank you. Now, let's try to concentrate. If I need all those 4 terms, I can use print and I can write down, okay, DADA square bracket at place 0, 0, comma, and I can put up at place 0th row, second column, or second row, 0th column, and I can have second row, second column. Correct? I got 1379. But here, these are not as a single, these are not coming as a single unit. These are separate values extracted separately. I've just printed them together. But what if I need them together? Think about it. So listen to that very carefully. When I'm extracting values from DADA, I use the square bracket to extract it. Right? It was a 2D array. So I mentioned 2 things. Right? The value or the index for the first dimension and index for the second dimension. It extracts me the values, the first dimensional index and second dimensional index together. Right? That brings me 9. Acceptable, eyes, nose, maybes. As an example. Good. Now, but I here require a different scenario. I need a data from row 0 and row 2. And when I'm selecting row 0 and row 2, I am selecting column 0 and column 2 over there. Similarly, column 0 and column 2 over there, isn't it? So essentially, what I'm looking forward to is in my data, use the rows starting 0, colon, ending 3 with a gap of 1. If you remember the range functionality, that would generate 0 and 1, or 0 and rather, give it a gap of 2, rather. 0 and 2 will be generated, isn't it? Start value, stop value, and a gap. Is that going to generate 0 and 2? Great. So that is what I defined for the row, because before the comma, the first dimension. After the comma, the next dimension. In the next dimension again, I need 0 and 2. So same thing can be repeated. Can you see this? Did I get 1379? So what did I do here? I extracted out a chunk of data or chunk of information, not the entire thing individually, but separately a small little chunk, just like pizza. If this is the pizza that is there and it has jalapenos, it has, let's say, a corn, it has, a tomato, it has a capsicum, right? It has, let's say, olives, for example. Let's say it has cheese, some cheese crumbs, whatsoever. Now, instead of talking about jalapenos, cheese crumbs, and all those things one by one, what we're trying to talk out is a slice that will contain anything and everything, could be anything, but it has a starting point, it has an ending point. Make sense? Same thing. A slice. Slice means a uniform set of information which is equally separated or equally spaced in terms of gaps. I can extract that out from the entire array. Good. What I need to make sure that I put up the things in terms of range while extracting. Good. Can you explain the command 116? See, Kotlin, for that you need to know range. That is very important. Or do you know arange? Either way around is fine with me. Let's take that into example. What I expected was, this was the given data to me. This was my given array. Good. Now, into this given array, I was looking forward to extract 1, 3, 7, and 9. Good. Great. Now tell me what index or what are the positions of all those 4 numbers. I have 4 numbers, 1, 3, 7, and 9. Where is 1? 1 is at 0 index, 0, 0. Where is 3? 0, 2. Where is 7? It is at 2, 0. Where is 9? It is in 2, 2. Acceptable? Thank you. Now, let's try to concentrate slightly onto this part. Slightly. The data or the information that you are seeking from, the outermost dimension that I have has 0, 1, and 2. and the second dimension also has 0, 1 and 2. Acceptable? The data that you are looking for is in dimension 0, this value and this value, correct? And this value and this value. Is that correct? So what you essentially require is a value at 0, 0, value at 0, 2, value at 2, 0, and value at 2, 2. If you look at this part, what is that? It's a sequence of two numbers, 0 and 2, right? What is on to the right side? Again, that is also a sequence of two numbers, 0 and 2. Good. So I need a mechanism by which I can generate these two numbers. If I can generate 0 and 2, again followed by 0 and 2. So I will have a combination of 0, 0, 0, 2, 2, 0, and 2, 2. Good. What I need to do is I have to now generate a sequence in such a manner that while I'm trying to extract the information, I need to give two dimensions. For the first dimension, for the second dimension. In this place, I need to put up a value in such a manner that it is a sequence of numbers 0 and 2, which I can get from 0, colon 3, colon 2. Range functionality. Start from 0, stop at 3 with a gap of 2. So 0, next number is 2, next number cannot be generated. Good. This will generate number 0 and 2. Acceptable? In a similar fashion, on the second index, again, I need zeros and twos. So 0, colon 2, colon 0, colon 3, colon 2. That is also going to generate 0 and 2. So now my machine will get to know that I need to take combination of 0, 0, combination of 0, 2, combination of 2, 0, and 2, 2. So 4 different values have been sorted out, and that will be taken up. Let's try to take that through a different example. Maybe that will help. What if I need, let's say, 1436. On the first side, first index and second index. From the first index, I need 0 and 1. Right? I need the data from 0 and 1. Second index, I need 0 and 2. Acceptable? How can I generate 0 and 1? Start from 0, stop at 2, take a gap of 1. How can I generate 0, 2? Start at 0, stop at 3 with a gap of 2. Acceptable? That's it. Use square brackets and put the data around it. 1436 should be there to showcase. 1346. Good. Thank you. That is called, we call it slicing. Great. That's your file for the day. So we have, almost completed certain line 116 again. Okay. What is the problem with 116? The count. That is notional. I can avoid that. Looks like I went to Siberia or Russia, maybe, Eastern Europe. But objective is not to type your name in reverse, print your name in reverse. I have a different objective over there. The code that I've written down over there, is that comprehensible for everyone? Eyes, nose, maybes. 3 has written down 9 colon 0 colon minus 1. 0 to 9. Abhinetri, that would have missed A at the beginning. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that would have missed your first A letter. You would have got IRHTENIHB. A would have been missed. Abhinetri. If we just copy and paste. As a part of just quick revisiting to the things, I'll just quickly walk you through with what we have covered up so far in the previous library, which was NumPy. Very quickly, in the meanwhile, maybe some more people might join in. So we talked about NumPy, as you can see on my screen. What is NumPy? Why NumPy? Then we talked about, the arrays. How do we create arrays using the array function? Some properties like endim, shape, size, dtype, and item size. Then we also talked about few things with respect to how to create multi-dimensional arrays. We looked at some basic functionalities like reshape functionality. We'll talk about the flatten function. Then we have talked about transpose. We have talked about some statements from arithmetical and statistical functions, addition, subtraction, and all. Then we talked about statistical functions like mean, median, standard deviation, variance, percentile, range, and interquartile range. I have talked about all of them. Hopefully you guys can remember and recall all those. Then we talked about the implementation of string functions on a NumPy arrays. We worked on that part. Then we looked around some miscellaneous important functions, not all of them, just some important functions of relevance, like arange, linspace. Then we talked about some random functions like random. I've talked about uniform. I've talked about randant. I have also given you information about the seed. What is seed and what is the role of seed? We have talked about indexing and slicing. How do I take out a single value from an array or multiple set of values from the array? That's what we completed at, and maybe this was the one question that we did it at the end. Good. Today we're going to start off with another library called as Pandas. So let's have some discussion on Pandas first. Let's see how many of you has what kind of opinion about Pandas. Tabular data, rows and columns, data analysis and statistics. Great. So let's talk about Pandas. Very simple library. We'll start with the word Pandas. Right. So Pandas is another library which is built on top of NumPy. A library, I'll say that. It is a library built on top of NumPy. So when I say on the word top of NumPy, what does it mean? That it uses NumPy as its base, as a base library, and using that base, it is going to process a lot of things, right? So it is built on top of NumPy and is useful for data analysis, is useful for data manipulation. It is also useful for, let's say, data visualization. We can create data visualizations from it. When I say visualization, it essentially means that we can create graphs and charts. We'll talk about some more libraries on graphs and charts. That's a separate thing, right? So data manipulation, data visualizations. Well, data exploration, you can say that. Data analysis and data exploration. Let me put that up together. Data exploration and analysis. Now, what is the problem? Now, why we need another library, right? So why we required Pandas was one of the very basic reasons. Now, for all this purpose, NumPy is also good. NumPy was effective for, you can say that it is effective for the numerical information, numerical data. However, it lagged in the data exploration and manipulation facilities, right? And manipulations. So the solution was this, which is the Pandas library. Now, what is the advantage? Why do we, use pandas? Is one of the prominent reasons. Pandas makes the pandas allows to explore multiple data forms or rather explore data in the form of tables. In the form of tables, or we can say that that is like a rows and column structure, a rows column structure. Now, how does it Panda does it? Pandas offers that. Pandas offers these facilities, some basic theory part, right? These facilities or functionalities, I would say that functionalities using two major data structures, right? Two major data structures. Can someone tell me what are the two data structures that are there? And these are, number one, we call it as a series, and the second one is called as a data frame. Two major data structures. However, with pandas, there are more data structures which are not commercially used, but they are theoretically present. One is called as a panel data, another one is called as panel 4D data. So there is two more categories into this, but panel and panel 4D are not commercially or practically not viable, so they are not used, but they are there, to be very precise, right? Certain scenarios over there. I'll bring into your picture right now. Why we prefer series and not a numpy array? I'm going to import numpy library. And team, I'll like you guys to practice along with me. Numpy as np. And I'm going to import the pandas library too. Import pandas as pd. Those who are using some tools other than Jupyter Lab might not have pandas installed. So how many do you know, guys, how to install pandas? Yes, no, maybe quickly. Or any library. Just a quick note to install. Yeah, you can use pip install. Thank you. To install pandas, I need to just execute. Remove the double quotes. Thank you. So if you do not have pandas installed, just execute this line. That should be good. Great. Let's just import pandas and numpy. Why did I import those? Because I want to create up an array. I'm going to create a very simple one-dimensional array. Okay. And you guys need to listen to that very carefully. I'm going to speak out certain things and I want your full attention onto this. I'm creating an array about my wardrobe. Let's say my wardrobe. Okay. My wardrobe has, let's say, 3 trousers, 4 t-shirts, 2, let's say, 2 ties, 3 pair of socks. I have 2 pair of shoes. I have 1 wallet. I have, let's say, 2 belts, and I have, let's say, 4 handkerchiefs. Did I give you some information? Let's make that as a numpy array. np.array. Everybody okay with this? I have created a simple array with some data points. Eyes, nose, maybes. Thank you. Let's name that as wardrobe array. Wardrobe underscore ARR. So that we can. Great. Now, can you tell me what was this to? No, I had 3 socks. See, my objective is not that. Hanky was 4. Kunal. I can show that from the transcript of this conversation. There will be transcript available if I'm not wrong. Or maybe after the session, it would be made available. See, objective is not that. I do not want you to remember those things. But point is, with this data, I am not able to remember anything. Now, if I just try to show it up, Let's say I'll print that wardrobe ARR. Let me just print that up. Let's print that. Good. Now these are the numbers. Now with this array, I also get the facility of index, right? I can also see the index values. Let's print wardrobe ARR again, and I'm gonna dot index. I can get the index too, correct? Oh, I cannot get the array index, right? But we know, right? For array, I cannot get the index. Good. We know that there exists an index, right? I can access any element. This is index 0, this is index 1, this is index 2, and 3, 4, 5, 6, 7, up to index 7 we have. Correct? Acceptable? Now the series gives me a better option. What series tells me is that I give you a leverage that you keep this data on, right? Keep this data on, whatever the data that you have. But along with that data, you have the leverage to use the index as a visualization or as a visual look. You can take a visual look at the index too. How will that happen? Let me just try to create up a series first, then I'll come to the syntax. Good. So let's say I want to create up the same series, wardrobe underscore SR, let's say, so that we can remember it's a series. Good. Is equal to same information, the same array I will use, no problems, but I'll say that pd.series, and I've used the same array. Good. Now let's have a look. How does that series look like? Same piece of information that you have seen before, but onto the left you can see that there is an index 0, 1, 2, 3 up to 7, correct? And on to the right you can see there is a data. Good. So when you look at this data, I'm saying about the look part. If you view that data, you now can see at what index what value is there. And then see with the series, you also get an option that you can manipulate this index. That means this is a default numerical index that is by default, it happens with everywhere. But I have the choice that I can manipulate that too. How? I can tell while creating the series. Okay. So let's say I'll put up SR with index. Same piece of code. No changes. I just change the variable and I'll change few parameters in the series function, series class. Good. I'll put a parameter called as index is equal to, and now here I can pass on a list of values which I want to put up as an index. Let's suppose I wanted to have this as 3, let's say 3 trousers. Good. Let's say I had, what was the number 4? Let's say I had 4 shirts. That's it. 2 socks. What was the next one? Let's say 3, whatever number that is. Let's say 3 shoes. So I'm giving some random things, right? Then I had 2. So let's take up 2 wallets. Let's say 1 belt. Let's say anything else. What else? I have next 2. So it could be anything. Let's say watch. Let's say the 7th one, 8th one is, let's say, hankies or handkerchiefs. Or let's put up something simple. Let's say tie. Randomly chosen. Now, when I create this, look at this. I had 8 values, right? I had 8 different values of different nature, maybe, right? All those values are as it is. And I am telling that, okay, first value indicates the trouser, second value indicates the shirt, and so on. Once I do this, look at this. What did I get? I get the same series, right? The same series. On the left side, I still see the index, and on the right side, I see the data. Now, if you look at this data that you see on my screen right now, this series, right, and compare that with the array, that is wardrobe ARR. I'll just print that for you here too. So this is your wardrobe ARR, which is an array. Good. And this is your series, right? Wardrobe series with the index. Can you tell me which one is more informative for you? Carrying the same data information. Data carried is same, right? The series is more informative. Now, if you have to make any decision-making process, or if you have to make any understanding about this data, this is much more convenient for us to explore and analyze data as compared to the series. Correct? As compared to the arrays. That's why Pandas. So Pandas gives me that leverage of using things with names. I cannot do that with the arrays. I can do that with the Pandas. Right? Are we good with the series? So far, what is the purpose behind series? So it allows me to use index of my choice. Will we do it later on? I will come to that point as well. Whether we would actually go with that indexing in real world or not, that's a separate issue. Good. I can definitely scroll up. Can I hide the outputs so that you can look at the piece of codes together? And definitely these indices you can manage as per your choice. I've just put them random. Thank you, Yosef. Good. Rest of the team, I hope so fine. Everyone, thank you. So that is the idea. So let's just try to bring down the syntax. Right. So again, as per the standard definition of series, we go with it. It's one-dimensional array. So a series can either be created using the series classes, or could be generated created as the series class object. Let's just put it in correct nomenclature. Or it could be generated through other methods. So there are some more methods which are available, which are series generative methods that directly creates the series for us. We don't explicitly tell them to create using these series functions, just like array function, right? You have a function called as np.array that allows you to convert any data structure to array form. In a similar fashion, we have a series class, and I can use that to create a series object. That's fine. Second thing, there are, let's say you have a function called as arange, or let's say a random. Those are the array generative functions where the array is generated from them. The outcome of a particular function, a particular process is an array. Similarly, we have certain functions in series as well, where the outcome is a series. Resultant is going to be a series. Good. There you will not explicitly use a series function, but yes, series will come out. So let's put up the syntax. The syntax. Create series, or I'll put up the generic syntax. Let's put up the generic syntax. Create series is, and I'll put that here. So I'll put up the word pandas dot, the name of the class is series. Within the pair of parentheses, pair of round brackets, I need to put up data, whichever data that we have, and an optional list of index, list of indices. So it has to go with index is equal to. There are some more parameters into that. I will not talk about them as of now. We will discuss all of them later on, as and when we require them. Okay. Good. Everybody. Simple thing. Here the data could be anything. It can be a list, it can be an array, it can be a dictionary. I'll talk about all of those options one by one. Good. So let's try to create the series using different methods. Or rather, not different methods, but different inputs, different sort of inputs. Good. Let's create series, creating series using. So do I need to put up another example for arrays? Because we did create one series above with the array. Okay, thank you. No problems. I'll do that. It's a creating series from a list. So I'm not going to make it very complicated here, right? I will try to keep it simple so that we can know about it. We can work around with this at a later stage. Good. So let's try to work around. Let's take up something as data is equal to a simple list 1, 2, 3, 4, 5. Good. A simple list. I'll create my series. Let's say SR1 is equal to pd.series of data. I'm not putting up any index by default. So very simple. SR. Let's take up the same data. Okay. I create another series with specified index. Let's say I want to use some specified indices over there, right? Some specified index. So how will I do that? Let's put up the same piece of code again. SR1, let's say put up with index. Now with index essentially means that I am putting across my own index. Otherwise, the default index is always there. Whenever you create up a series, when I put up a specified word, that means I'm putting up the specified index. I can put up here comma index, and let's take that up as, just wanted to save time. If you want, I can put up index as a separate variable and put up index is equal to something, right? That is my choice, but does not make a difference. Great. Yes, Rosie, I'll do that examples. Don't worry. We'll do the dictionary, we'll do the tuple, we'll take the arrays, everything. With dictionary, there is a slight, variation. So I need to talk about that variation too with dictionaries. So I'll keep that for the end. These are your building blocks of understanding pandas. To be very basic things that I'm talking about, but these things will make you, make your foundations correct. So whenever you deal with a bigger data, these basic concepts will help you a lot to understand that library. Okay, great. I'll just display those two things to you first. Print SR1 so that you can remember. Let's just print print SR1 underscore with underscore index. So team, it might be possible that I might be typing a little bit faster. So ask me to pause. I'll take a pause if you're coding along. Right. So we got the series, right? I have created data 1, 2, 3, 4, 5. When I print and I created a series SR1 and I create another series SR1 with index. With SR1, I did not mention any index parameter, but here I have mentioned an index value that I want A, B, C, D, E. Now, please remember that the number, if you're using index, that means whatever the number of elements I'll have in 1D, that many index are supposed to be given. I cannot make 4 indices over there with the 5 values, or I cannot put up 6 indices with this 5 values. That's not possible. With 6 indices, it will work, but 4 indices will not. Great, good, yes. Thank you. Let's move on to the array example. We'll copy the same information to you. I'm going to just change from list the word to array. Typically, there is no change. With list and array behaves in the same fashion, list, array, and tuple. The only difference is in the terms of the nature of the data. That's the only thing. So I can put up this here, data is equal to np.array. I've just converted that into an array form. Now, is that all created from an array? Do we agree? Thank you. So same output, no changes because it's going to behave in the same fashion. I can put up the same example with the tuple 2. Rosie wanted that. Copy the same example and that will work the same way. No need to put up anything. I can put that through tuple. That should be just a tuple. I just make it as 1, 2, 3, 4, 5. Rest of the things I'll keep it same. Rosie, still get the same results. Now that's not expected, Asif. Though I can explain that. Can you tell me very simple thing, Asif? What happens if I put a string A multiplied by 2? What does the multiplication behaves in the form of a string? Since it's 2, you can say duplicate, Sabnetriya. But this multiply sign is the repetition. Essentially, I'm telling it to repeat A 2 times. If I put up 4 here, repeat A 4 times. When I write down a dash multiplied by 50, what do I want? I want dash to be repeated 50 times. Why did I do this? Because there were 2 different series that I was trying to print in. There are 2 series that I'm printing in. This was the output for SR1, and then I use immediately SR1 with index. So I just wanted to segregate both of them so that you can have a clear visualization that this is your SR1 and dated here. This is your SR, the second one with index. That was the only purpose. So I wanted that dashed line in between. So my 2 outputs are separated. That looks little beautiful. That's it. The outcome looks little kind of, what do you say that? What word should I put it up? Kind of aesthetic. I guess so. Aesthetic is the word. Cosmetic. Thank you. Hope so that's it. Little bit bad throat, please. Okay. So everybody okay till now? There is an issue with the dictionary. So let's take up the same thing that I have taken up earlier. Let's take up a dictionary, dict1. Okay, that's a simple dictionary I want to create. Let's say I have taken up A, okay, key A, value 1, anything of your choice. You can take up any keys. B, colon 2, let's say C, I'll put up colon 3. This is just for the ease of access and ease of understanding. I'm taking simpler values. Let's say D, colon 4. Let me make it 7 because otherwise you will say that, okay, why are you taking them in sequence? Good. E colon, let's say Z colon 21, or let's say 3, or let's say any number 3, let's say. Good. Okay, so I have taken ABCDZ. Let's take any, okay, that's fine. Now, if I go create a dictionary from here, or let's say create a series from a dictionary, now there is no problem when I create it with the index, without the index. Let's say if I create up this SR underscore with dict, or SR from series from dict, so that we get to know it's a series from the dictionary created. Same function, same class, pd.series, and I will pass on the dictionary dict1. No problems. If I just print that up, there is the problem. Prime point is you need to understand it. Here, instead of putting up the manual or the default indices, right? The default indices 0, 1, 2, and so on. Instead of putting these index, what it does is the series will now take the keys of my dictionaries as the index, right? The keys will become the index or the label, right? You can say index or label, anything, right? And the values that we have, they become the data. Do we get this? Just to have a look. You see that A7, the key become the index and its corresponding value is the data. If that is sensible by any means to you, anyone. I will bring in the catch that is not yet there. Series converts anything to dictionary? No. That is wrong, the wrong assumption, Preeti. Series is a different way of arranging data, different architecture. Dictionary is a different architecture, completely different. They look similar, they appear to be behave similar, but series offers a lot of different functionalities than dictionary can offer. So we can't manipulate the labels now. We can manipulate the labels. The labels can be manipulated. I can change those. I'll talk about those, how we can change the labels. Suppose I do not want a B here. I want something else to be changed. I can do that. But that is something futuristic. I'll talk about those things too. Slowly and gradually. Time will come. How we modify any kind of label. Not even with the rows. Later on, when we talk about the two-dimensional data, you might want to change the column names as well. The column headers in a 2D. So I will tell all those things. Don't worry. Everything is going to come up. Any kind of basic, operations that you might have to deal with any kind of tabular data, you will not feel uncomfortable about it. Split function, where I use that ABCDE there, right, to split that thing. Is that what you're trying to talk, Asif? Here I used it when I wanted to do this. So I will have Asif and Khan as two separate words extracted because there is a white space in between. And that will be given to me back as a list. So I got the result as a split it thing. Good. If I would have, let's say I want to split on, there is no repeated character. You can say that, let's say if I put up, let's say I want to split on a small a, then it gives me two letters. One is Asif and what is n, because that will be omitted. Whichever character I want to split up, take it off, remaining things will become comma separated values from that junction. So you can split on any character, or you can split on white spaces. Thank you. But this is coming from very basics of Python. As if you have not gone through with the basics of Python, I'll recommend you and request you please go through with that. That will be easier and convenient for you to follow along. Great. Now let's bring in a problem. The problem is that I want to bring into the picture is a series. Suppose, what if I want to create a series with index? Till now, this is a valid series, correct? This is a valid series. This is a valid, this is a valid dictionary. This is a valid series conversion, right? I'm converting the dictionary to a series form. Acceptable? Let's say I'll put up with index. Good. Now I'm going to put in the index. Let's say index is equal to, I have put in, let's copy of the same index that I've used earlier here, A, B, C, D, E. Good. Let me put up a G there. Let me put up M here, not M. Let's put up a C here. Good. So look at this. What did I do? I have randomly put in a lot of things. Let's put up comma Z also. Great. Okay, that's fine. Now look at this. What is going to, will it work? First of all, think about it. Do not execute. If you're typing along, do not execute. Let me just think about for a moment. Should it work? Kunal says no. That should be the obvious answer. It should not be working. Why? Because we are using a dictionary from 6 or 5 values, and I am creating up, giving index out of bound. Many indexes are given, but that exactly is not going to happen. Now listen to my words very carefully. How does the series class is going to create the object from dictionary? Listen to that very carefully. It is going to create a series object of these index. That means I will have a series that will have index value A, B, G, D, E, and Z. Get? Then, in order to get the values or the data, so this will be my index. In order to get the data, what is series going to do is going to look for that index, whether it is present into the dictionary or not. If the index is present in the dictionary, it's going to take the corresponding value. So A is present, I'll get 7. B is present, I'll get 2. Then I have G. G is not present, I'll get a nan. I'll talk about what is nan in a short while. Good. Then I have D, which is present, I get a value 6. Then I have E. E is present, no. So I'll get a nan again. Then I have a C as per the dictionary. So C has a value 3, I'll get a 3. And then Z have a value 3 again. Do we get this? So series will create the series based upon index and try to fetch the value from the dictionary for those indices. If the value is available, it will take it up. If not, it will put up a nan. What was the word? Nan. Let's just have a look. What did I put? Oh, space. Can you see this? It did create up the series. It was not an error. It did create up a series for me for the index given. Good. But this index will try to fetch the values from here. If the value is available, I will take that value. If not available, I'll put up a nan. What is nan? Nan, those as a term of full form, stands for not a number. It stands for a not a number. That's the basic definition. But do not go by that word. The essential meaning of nan is none or nothing. It is nothing. Nothing means a blank area, not even a white space. I'll come to that, Kunal. Hold on. I have everything in my brain. It was integer here, now it is float. What changed? But did you get this point till now? Everybody? So please be cautious while you're using dictionaries. If you're using dictionaries to create series, please be cautious that are you using an index? If you're using the index, whether it is present, not present, you might land up with the nan values. Nan values means essentially we use the term called as missing data or missing value. Good. So whenever there is a key or there is a label, that particular label does not have a data, then we call that as a missing data. Let's take up another example of understanding what is missing data. Suppose I ask you to fill up a survey, right? At the end of the session, we usually ask you, right? You give a rating on first parameter 1, second parameter 1, third parameter 1, fourth parameter you don't give it, fifth parameter again 1. Right? Now this parameter will always be there, right? But I will have nothing over there, no input. That nothing will still be a part of my data, correct? Though it is blank. So that nothing will be represented as nan. Now, why nan? Why the float question, right? So essentially, now listen to that very carefully. Do you know the type of precedence in arrays? Did I talk about that? No. Type precedence in arrays. Did I talk about that? No. Okay, thank you. So again, conceptual thing, team. So remember, it's just a conceptual thing about the precedence. So I'm currently talking about array. Now, do we know that in terms of arrays, array have all data elements of same type, right? Array will have all elements of same type. That means if there is an integer array, every element is going to be an integer. If there is a floating array, everything is going to be float, correct? Every element is going to be floating point. That means there will be a homogeneous structure in arrays. Now, what happens is, let me just try to talk about this. Suppose I'm going to create up an array from a list. Okay. So if my list contains, let's say, very simple example, all integers, right? 1, 2, 3. Yet, if my list contains all integer values, the data type or D type of the array is going to be integer. Good. Agreed? Eyes, nose, maybes. If I create up an array that contains one integer, second one is also integer, third one is a floating point number, let's say 3.5. What is going to happen? It is going to convert both the integer values to a floating point representation. So what I'll get is a data type as float. It is going to convert 1 to 1.0, 2 to 2.0, and 3 to 3.5. Correct? 3.5 will remain 3.5. So every element is now in floating form. Good. Agreed. So if there is even a single element which is of floating nature, all the elements become float. That is what happens in array. Similarly, if I take the same example of an array, again 3 inputs, I have 1, let's say I have 2.5, and I have 3 as a string. Good. I'm talking about arrays right now. Good. So in this scenario, what is going to happen? If that would have been an array, 1 will become a string, 2.5 will become a string, and 3 will remain as a string. Everything gets converted to string form, correct? So if there is a single string present, then everything gets converted to string form. If there is a single floating point number present, then everything gets converted to floating form. If all the values are integer, then it remains integer. Correct? Everybody okay on that? Eyes, nose, maybes. Or should I showcase that first? Through example. Nobody? So essentially I can say with the arrays, highest precedence is to the string, then to the float, and then to the integer data. Integer and boolean are same. Bool type structure and integer type structure, scalar data structure. So bool will be given equal precedence to the integer. So if there is a boolean value, boolean will remain boolean because boolean is a subpart of integer now. Thank you. Now that is what with the arrays, but with the series there is a small little issue because series supports heterogeneity. It supports heterogeneity. That means if there are different types of data, the type will be maintained. Type will be maintained. Individual data type will be maintained. But there is a small little kind of exception to that, and that is with the integer values, right? If I'm creating a series with all integers, 1, 2, 3, let's say, right? It is going to be integer type. Good. If I create up a series with 1, 2, 3, and one of the floating point number, let's say 1, 2.5, and 3, it is going to convert everything into float form, and I'll get the floating integer, just like arrays. It behaves in the same manner. So integer and float, these are changeable. Good. How? So integer values will be turned to float if there is a float value. However, if I have the same sequence 1, let's say 2.5 as a floating point number, and I have a 3. Now, had that been an array, the data type of this array would have been string. Agreed? Every individual element has been changed to string. If I create an array out of it, if not, if I do not create an array, I create up a series. What happens is it shows me the D type as object. It will show me the D type of this entire series as an object, and it is not going to convert anything. Integer will remain integer. The floating point will remain floating point. A string will remain string. Individual item will hold to their data structure. Right? But the overall data type will be given as object. Good. So if you see a series showing its D type as an object, very critical point to remember, right? If a series is showing a D type as an object, that definitely means that contains a non-numeric input. The series will somewhere have a non-numeric data. Are we good? Thank you. Now coming to this point, why float? This is float because the default data type of NAND, let's try to check. Can I just, okay, I did not talk about how to access those values, but just to showcase, right? This is the thing. I can use a square bracket, and we know in order to access the value, we use the indices. So I can put up the index. What is my index? For NAND is G, right? If you look at G right now, it is NAND value. Good. If I print it up, I should not see, I see NaN word, right? If you try to look at the type of it, that gives you the data type of it, correct? It's a NumPy floating point number. Good. So essentially, by default, though it does not acquire any space, it does not have a value inside, there is blank, but there is a default data type given to the missing data or NaN values, and that is floating point. And hence you see that all the values is converted to float form, and the data type has changed to float. Here, right, I told you that I am using 5 elements. I should mention 5 labels. What if I make 6 labels over there? What happens? That's going to happen always. What if I, let's say, take up this example and I put up here another label, another index, F. So there it is not going to accept it. It is only and only going to happen with the series, with the dictionaries. If you try to create that through dictionary, then and only then you will get those things. Good. Or there is another thing. There is called as a scalar data. If I try to create up it through a scalar data, let's say 5, data is equal to 5, a single value, then it should create it 0 value, index 0. And when I put up, so when I printed that SR1, it was okay. If I print SR1 with index 2, you will see the difference. I get A, B, C, D, E, F all filled up with a common value. So the idea remains same, Rosie. The idea is that if it is a scalar data or a dictionary, your series is going to be coming from the number of indices given. Otherwise, if it is a list, it is an array, it is a tuple, you need to put up exact same number of indices as you have the data points. Ask if you would have an unmute option.
Hello. Hi, sir. Sir, actually, see, like A is to 7. Can you please scroll up, sir, please?
Let me just take this example of. Okay, go.
Yeah. So a little bit, sir. See, yeah. Here A is to 7, like string with the integer, string with the integer, string with the integer, like with ratio, like how you have converted. But see, all of a sudden, why A is 7.0? Why it is especially giving it as float? I'm a bit confused here, sir, in this case.
See, I have a very basic question again. Do you know what dictionary is?
No, sir. Actually, dictionary, it's like it's a
Dictionary
library.
is a data type. Dictionary is a data type in Python, because I specifically mentioned you that earlier too.
Yeah.
Go through the
Go through
Python
it, sir.
basics,
Sure.
right? So dictionary is a simple data type in Python that is created as a key value pair, right? It's a comma separated values, comma separate data structure that contains key and its corresponding value, comma. I can
Okay.
have another key, comma, corresponding value, another key and corresponding value. So where key is some entity and it has a certain value. Let's say
Got it.
name
Okay.
Asif, age
Yeah.
12, organization Google. So I have keys and corresponding values. Good. So that is what we call as a dictionary. So that is why that arrangement. Yeah.
Yeah.
Good.
That I understood, sir. But here, like,
And why the 7 converted to 7.0?
correct.
If you
That is
talk
my question. Yeah.
it, I explained that because the presence of NaN, because of
Okay.
this presence of NaN, right?
Mm-hmm.
Because NaN is present, so I have a floating element into this. There is a floating point because NaN is a floating thing. Good. It's a
Okay,
floating
sir.
point value.
Okay.
Because
Okay.
there
Makes
is a
sense.
float,
Yeah.
so it has converted all integers to float form.
Got it. Makes sense, sir.
Because
Okay. Thanks.
7 and 7.0 mathematically does not make a difference.
Yep.
Mathematically, 7 and 7.0 will hold the same value, same meaning.
Yes.
However,
Yes.
in terms of representation, there's a difference, right? Integer 7 and floating point 7 are two different things. Good.
Yes.
So the essential change that will happen into the real world is going to be the place or the memory space that is being allotted. Because in integer, we will have a lesser amount of memory space as compared to the floating point numbers. Floating point numbers will acquire more amount of space. So it's a space consideration that we need to look at. Otherwise, it's fine. Good.
Okay, sir.
Never any sort of Google form, any kind of form, maybe an enrollment form, any kind of form, you must have filled it up. Suppose if there is a field which is not mandatory to be filled in, which is not mandatory, and rest of the team will also tell me if it is not mandatory to fill in that field. Now, team, listen to that very carefully. Many people talk about it in a different way. There are multiple ways by which I can access the elements of the series. But what the answer that I'm going to give you right now, whatever I'm going to talk about, is a futuristic approach. It is a futuristic approach. For example, let's try to, so in order to access any element of an array, how do you do it? You take up the variable name followed by a pair of square brackets, and within that square brackets you mention the index, correct? To access any value. Is that correct? So same thing goes over here as well. Suppose I want to access something. So my series name is wardrobe with SR with index. I'll take that. Put up a pair of square bracket. Within the pair of square bracket, I'll mention my index. Now here, let's say I want to talk about belt, or let's say some other number. Let's say shirts. So I will mention shirts. That gives me the result form. Great, no problems. Everybody okay with that? Simple indexing. Great. I want to make it complicated too. Now, essentially, we also know that this series, had that been a case I did not provided those indices, would have had the numerical index, right? Acceptable? So despite I have given the index of my choice, the default numerical index still prevails. That means I can still use that default numerical index to access the data. I can still use that to access the data. How will I do it? Suppose the same shirts. Shirt will be at index number 1. Agreed? What is the index value of shirt? If I go in 0 to 1 from top to bottom, shirt will be at index number 1. Acceptable? Yes or no? Thank you. So let's try to see if I can get the value for index number 1. Good. Now look at this. Here it says that it gives me the output 4, but it also gives me a future values, a warning. It says that future series.get item treating keys as position deprecated in future versions. It will always be treated as labels and considered with the data frame behavior to access so on and so forth. Right. So the ideology is that in futuristic terms, or maybe in the recent versions of Python, I'm using might be a little bit older version. So for me, it is showing the warning. For some of you, it might not be even showing warning. It might be giving an error. Good. So point is, listen to that very carefully, that this approach using with the numerical index is not recommended. So what do I talk about is, do not learn these two methods. Do not learn them. Let us learn what is more standard and more going to be futuristic. Good. So what you have to do is, listen to that very carefully. Whenever you are going to use a user defined label or a user defined index, good. Whenever you're going to use a user defined label or a user defined index, you are going to use a word called as LOC. that is location. Good. If you are going to use a numeric index, you all numbers, then you will use ILOC, that is integer location or index location. Do we get integer keys or it's actually integer location? Can we remember that much? So same piece of codes that I have written down over there, I can write them down again. Only difference is that before putting those square brackets, I need to put in those two words. I did not get the warning. Now, good. So start using LOC and ILOC. LOC stands for location. ILOC stands for integer location. Stands for location and strictly requires user defined labels. Good. And when I talk about iloc, iloc essentially stands for integer location and strictly need integer indices or integer index or labels. Good. That is the idea behind. Let me just put it up like this. That will be helpful information. So if you are going to use indexed the user defined index, it should always be LOC. If you are going to use integer values, it should always be ILOC. Can we remember this much? Is that okay? Or is it going above the head? Thank you. Now, the next thing that I like to put up is accessing multiple values. Till now, you have seen only single data point. I have extracted one data point, right? Let's access multiple values. So there are again two ways. For example, I can use lock and iloc the same way. Same series that I've used before. And here in the index, right, .iloc, I can also provide the list of indices which I want. Let's say I want a shirt data. I want, let's say, a belt data. And I want, let's say, anything. Let's say wallets. Good. So what do you see here? A new series has been given to me, shirt, belts, and wallets. The order could be anything, right? I can put them up in any order. That does not make a difference. So the idea is I can specifically ask for any sort of values, right, based upon the user defined keys using the lock. What do I need to do? I need to put that across as the list. This is a list. Good. This is a list of list of my indices that is used under the outer brackets, outer square bracket. That is for the index operator. Are we good? Or slice operator, you might want to say this. Or I can use these data with iloc 2. If I want to do that with iloc, so I had shirts, that is index 1. So I'm going to take the same example. Belt is at index number 1, 2, 3, 4, 5, 6, or 5, if I'm not wrong. And wallets is at 4. So 254. List of indices. Which indices I want? I need 2, then 5, then 4. So I missed out on something. It's index 1. So you can see that here, shirts, belts, and wallets. Good. Extracted the same information. But there is a small little benefit also. Now, why you will say that if I can do it with a user defined, then why do I need that second numeric one? Let's suppose I may not need that sparingly like this. I need a small little chunk. Let's say from index number 2 to index number 5. So I can also use it for slicing the integer locations. I lock, and I can, instead of doing this, I can tell it, okay, 1:5. So index 1, 2, 3, 4 are there. Good. Sensible, not sensible, yes, no, maybe. If that works well for you. Thank you, Abhinitri. But there are too many people in the house. Let's just take some confirmation from them too. A blank print statement team, so to segregate the outputs. That looks slightly some gap. Ah. Great team till now. Any questions, please ask. I have not yet talked about any kind of. So if you want to print 1, 3, and 4th call values alone, how should we slice? See, I do not have multiple columns. I have multiple rows there. Rows you can say if you want to look at that way. So essentially you can tell me this is your data. I am putting up the numerical index as well for you. 0, 1, 2, 3, 4, 5, 6, and 7. Now you tell me what do you want. I'll tell you the way. Whichever way you want. Either you need to tell me index numbers or index values, or that's two things. Any of those two things. 1, 2, 3. Write down your series name dot iloc square brackets. Within that, put up another pair of square bracket to make a list and mention the index 1, 3, 4. Give that a try. Should I do it? So 1, 3, 4 is shirts, shoes, and wallet. I did it, the same, almost similar example. I did it here. Look at this. I have taken 154 instead of 134. Okay, now let's try to follow up with the basic problems that we have seen before, right? You have seen these basic functionalities in NumPy. So we'll talk about all those basic functionalities one by one. So that is your series. Good. So we have 1, 2, 3, 4, 5, 6, 7 elements or 8 elements into that. These are the indices. These are the values that we have. Great. The first property. Let's print the series name dot endim. Now, I never found out what is the relevance of it, because we know as a matter of fact with the series that it is going to be one-dimensional instrument always. So according to me, endim does not make a sense to me, but yeah, as a part of information you should know. Endim, just like an array, it talks to me about the size or the dimension of the data. So I have one dimensional thing. It is one dimensional. Series is going to be one dimensional. Expected answer is 1. Next thing that we have is, let me copy the same thing. Just like series, just like the good. So Next thing that we talk about is the shape. What does shape tells us? Shape talks about the number of elements in each dimension as a tuple. That's what the shape meaning is. Isn't it? If you remember it correctly from arrays. Thank you. Then you have the size. Size talks about the total number of elements present, data points. Then you have D type, right? These are the 4 basic points. Item size does not exist over here because it is a heterogeneous structure. So every data point may be of different sizes, and hence item size is not available. Just like arrays, we do not have item size over here. In arrays, we have an item size property. Here, I do not have an item size. But instead of that, I have 2 more things. I have an index and I have a values. Good. So if you look at this, endim talks about, gives me the shape, gives me the number of dimensions. That is going to be 1. Good. Here, number of elements in each dimension. The shape will hold the same functionality each dimension as tuple. Good. I'm expecting here the output for this particular case. I'm expecting that to be a tuple 8 comma. Good. Then the size. Is total number of elements. Get D type. It gives you the data type of the series object, not of the individual element, but series object. Data type of the series. Right. So if I will have all integer values, I'll get integer. If there is a floating point number, everything gets converted to floating point, and it gives me the data type as float. If there is a string present, it gives me the data type as object. Good. Index gives the, or it gives the array of indices. So whatever the index that we have used, I'll get those indices here. What is values gives me? Gives the data as 1D array. Right. So I can extract the values, I can extract the index separately. Good. If you look at those. So I can see 1, I can see 8 comma, that's my shape. Size, integer 32 is the D type that I have got. Index, is this what we have got is, this is an index type object. Trousers, shirts, socks, and so on. Let's put up a list of indices. Good. And finally, you can see gives the data as 1D array. So my data 3, 4, 2, 3, 1, 2, 1, 2, 4. So whatever my input was, the array that we created the data from, I can extract that array as well. Are we good with these 6 functionalities, team? Quickly. Thank you. Now let's move on to some more basic functions, right? The first function that I'm talking about is head. Right? What does it show me? Returns top n data points. And the value of default is 5. What does that mean? So if I take up a series, right, any series, let's say we have the series water with index here. Let me copy this. Okay. And I put up dot head. I do not put anything inside those parentheses. It shows me first 5 data points. Look at this. Trousers, shirts, socks, shapes, and wallets. right? It has shown me top 5 data points. Are we good? Or I can control that, and I can also view. Let me put that into print. Let's say I'll put up here, let's say 2. When I put 2, you can see that it only shows me 2 data points. You can see the difference. Let me put up a print in between to differentiate the results. Can we notice that? So I can choose out how many data points I want to look at, because it is not mandatory that you will have 4, 5, 6 one view data. You might have thousands of data inputs. So you might want to choose out, I want to look at top 5, I want to look at bottom 5, or I want to look at wherever I want to look at. Sensible? So if you have to get the top data, use head. Then what could be the bottom part? A tail, right? So tail gives me the returns the last n data points. And again, the default remains the 5. So head, then I can have a tail. The same example. When you look at tail, it shows me the last point. Last 5 here. You can see last 2 over there. Watch entire. Because I have used 2 here. If you put up a number which is greater than the size, that it is going to show up the entire thing. Are we good? Hold on to that question, okay? I want to talk about 2 more functions, 2 or 3 more functions. Okay, let me explain that first. Because I have a lot of explanation to be done. Great. So Asif has a question, how did I got this shape as 8 comma? Is that correct? Great. Now, if you look at this was your series. Good. This is your series. I printed that up. Now, in this series, we created this series using this index and this array or this data, correct? So if you look at this, this is one dimensional. It is one dimensional info. Because it is one dimensional, I am going to represent that as a tuple. The shape is always in a tuple form, right? And since it is only one dimension, so I will have only one value over there. Since I have to make a tuple, so I need to put up a comma there. A single value tuple is made with a comma. Value followed by a comma. Now, how much value will come over there? That value is the total number of elements. In this particular case, that is the first dimension that I'll have, which you can check from the values. If you look at the values output here, this is the first values. So my values are represented using single pair of brackets. I'm pretty much sure you have attended my array session. And in that dimension, I have 1, 2, 3, 4, 5, 6, 7, and 8 elements. So my shape becomes, in the first dimension, I have 8 elements. There is no second dimension, so it's blank. Good. Had there been second dimension, I would have a second value here. Had there been third dimension, I would have a third value over there as well. If you cannot recall it correctly, revisit the video on the arrays part, numpy arrays, indexing and slicing. I have explained the shape functionality in detail there. Yes or no, team? Thank you. Moving on. Next important function, same array. Let me bring it again. The next important function that I want to talk about is called as info. It gives the general summary. We'll talk about general summary, right? Let's have a look. Look at this beautiful summary. What you see here is number 1. It talks about what is this. It's a series object, right? So type. Then it talks about the second thing, index. It tells me that there are 8 entries in my index. So there are 8 values in my index. Those are starting from trouser to tie. It does not give me the detailed list, but tells me it starts from trousers, goes till tie. So first index is trouser, last index is tie. That's two things that is available. Good. Then it's a series name. We'll talk about that functionality later on. What is the series name? Then it says non-null count. Non-null count essentially means out of my index, how many index has a data. That means if there is any blank, that will be considered as null. Make sense? We'll take the null example too. Okay. So I have 8 entries. For all 8 entries, I have 8 non-null values. That means for all the 8 values, the data points or indices, there is a value present. The D type of that particular values is integer 32. Good. And then it says memory usage, how much memory it is acquiring up in my machine. Entire memory that is taken up by that particular information, that particular series. Is that okay? Explainable? Now, just to notice the difference between the non-null count part, right? We created up a series here, which has the missing values or none values here. That was by the name SR from dict with index, correct? So let's have a check for this too. Let's print dot info. Now you see that there are 7 entries. That means I have 7 indices, and for which it says 5 non-null. That means it tells me in this series there are 7 entries, 7 indices are there, out of which only 5 are filled up, 2 are not filled. Are we good? Next function that I want to bring into the table is called as describe. Now that gives me the statistical summary. Okay, it gives me the statistical summary. Now remember in in NumPy, I talked about multiple types of things, right? In statistical functions, you don't have to explicitly calculate them every time manually, right? You need to have something direct. So describe is your go-to solution for that. You just need to put up a series followed by the describe function, and what you get is number one, the count. How many values are there? How many values are present, right? Not exact the count of values, present values. What is their mean? What is their standard deviation? What is the minimum value? What is 25th percentile? What is 50th percentile or the median? 75th percentile and max. So you got all Q1, Q2, Q3, Q4, Q5, up to Q4, everything is available. And then you have the standard deviation and mean. If you have the standard deviation, indirectly you have the variance too, right? Agreeable, non-agreeable, eyes, nose, maybe. Very important thing, team. It has a lot of meaning while dealing with the data. When I'll try to work around with the actual data or the exploration part, when I'll do that, you will see that, or when I'll start with the mathematics, you will see that I'll use this a lot. Describe function. Good. Can I move? Thank you. Next function that I want to put up into the picture is unique. Good. What does unique gives me? Gives the array of unique data points. Unique data essentially means that if my data has repeated values, it will tell me what are the unique values that I have. So I can put up unique. So it says that in your data that I have, right? That is my data. Where it is, here it is. Wardrobe. Yeah. It has unique values, either 3, either 4, either 2, then 3 repeated, 2 repeated, 1, then I have 1, and then 2 or 4 repeated. So I only have 3, 4, 2, 1 in that order. Good. Unique values. Are we good with the unique? Next one is n unique. N unique gives me the count of unique data. So how many unique data points are there? Earlier you had unique, that gives me which are the unique values. N unique talks about the count of unique values. How many unique values are there? Good. Sorry, I did not change the function. N unique. So I have 4 unique values. Is that okay till now? Thank you. 5 non-null pot. Explain, please. I guess my questions are getting slower towards Asif. So 5 non-null. Essentially, if you look at SR from dict, it has 1, 2, 3, 4, 5, 6, 7 indices. So that is 7 entries, right? Out of those 7 entries, 1, 2, 3, 4, 5 are not null. These are not null values, or null means nothing, right? There are 2 null values or nothing values. Good. Thank you. I thought that you might be able to recall that list sequence, but no problems. My mistake. So up to n unique, everybody okay? Let's talk about next function. And that is value counts. Now what does value counts gives us? It gives me the count of or the frequency. Let me just put up a frequency of the unique data. So I have 3, 4, 2, and 1. These are my unique data points, right? And then what I want is how many times each data point, each unique point has appeared up. Right? It can be 1, it can be 2, it can be 3, it can be 10 number of times. So how many times each unique data point has appeared up? That is what value count gives us. Are we good? Let's have a look. Now I said some series. You can see that the resultant that you see here is a series again, isn't it? It is a series again. Look at this. I have got 2, 3, 4, and 1. So I have a unique value 2 that has appeared 3 times. I have a unique value 3 that has appeared 2 times. I have a unique value 4 that has appeared 2 times. A unique value 1 appeared 1 time. Do you want to cross check? So 2 appeared 3 times. Thank you. That is what value counts gives us. Next function. I have lot many of those. I can keep on talking about them. Next function I want to put up is sample. Shows randomly selected, shows n random selected random data points. The default value is 1. So when I put up sample, so at times what happens is you might have a lot of data and you want to randomly look at certain data, right? Why do you want to look at a random data points? Any ideas? Why would, let's talk about some real world understanding. Why do we do it? Ever bought grains? Anybody ever bought grains like rice or maybe wheat or something like that, or maybe pulses? Usually what happens is you take out a random sample from the entire lot and try to judge its quality from that random sample. And based upon that random sample, you take up a decision. Is that what happens? Real time? Right? So same logic here. Maybe if I have, let's say, millions of rows of data, millions of data points are there, I may not be able to walk through with every single data point. It's not possible. Even if I can walk through, I will not be able to recall everything, right? So what do I want to do here is, I want to take out some random data points, check how they look like, and I can try to make up some conclusions about the data from that particular data points. So sample is one of the go-to things that you will use. Right. Another example I'll put up with sample n values. That's a print, and let's say put up 3. So when I put up, see, earlier I had tie, now I see randomly selected wallet. So it would be every time I'll execute, I'll get a different sample because it's random. Get up to sample. Look at the another function, which is the is null function. So I'll bring the same example again. Not this one. Let's take up SR with index example. The other one, dictionary one. That has the null values, that will help. Is null or is NA? Both are same. Good. It returns true or false. Returns true or false for every data point, or rather, it returns true for every missing data point. Else false. Yeah, that would be the idea. So if a particular series for a particular index has a data which is not present, is null is going to check out and tell, okay, true, it is not null. Is it's null? Yes, true. If it is present, it'll say false. Good. Look at this. So it says that index A value is present, so false. Index B value is present, so false. Index C value is not, index G is not present, so true. Index C is not present, so true. So I do not have data for those 2 data points. The rest of the data points are available, and I can see the true and false values. Good. Clear. Thank you. Now I can also use the function called as isNA. Is null and isNA are interchangeable. They are same functions. They have the same role. They have the same functionality, same methodology. God knows why they have created 2 functions. There are 2 separate entities which are available. They does the same job, exactly same job. Not even in terms of processing speed or anything. There is no difference. So I cannot pinpoint any difference between is null and is NA. They're the same. They're replica of each other. Good. But is that useful information for me? Any ideas? Now I can utilize this information to find missing values. Find the count of missing values. So if my data has a missing value, can I find it out? Missing values. How many missing values are there? Now you could say that we could have also derived it from the earlier information, but that was manual, right? Wherein I can look at the info, find out the index, how many elements are there in the index, and subtract with the number of elements, not null count. But here I can do it directly. Now listen to that very carefully. With Python or numerically, false is 0 and true is 1, correct? Agree to that? So if I think of this as 0, this as 1, 0, this as 1, this is 0, again this is 1, this is 0, this is 0, good. Now if I take a summation of all this, if I add it up, sum this data, will I get the sum of trues, or I have 1 and 2? So will I get 2 here? And that exactly is the number of missing values that I have. So if there would be any true present, then I'll get some number. If not, I'll get 0, correct? So if there is a missing value, I will have a number. If there is no missing value, I'll have a 0. And that's what I can do. So I can extend the same function, right? I can extend it after doing the is null. So to this, now if you look at this, this is also a series, correct? That contains Boolean type values. Right? This is also series. To this series, I want to take the summation. So dot sum. So connecting with that method chaining. And I got 2. A straightforward number. So I was able to find out the missing values. Good. Thank you. Next question arises, how to treat the missing values. That means fill missing values with appropriate data. Now, I have used the word appropriate here, but I have not defined what is appropriate. Right? I have not defined you what is an appropriate thing, because appropriate thing will vary very drastically depending upon the nature of the data. Good. It is going to vary in a huge manner. Now, I am going to make those changes right now on this SR from dict, because my job with the null part is done, right? So how will I do that? What do I want to do is, the name of the function is use fill NA function. Fill NA means fill the NaN values or fill not available values. Good. Fill NA. So how will I do it? See, this is my objective. I have a series by the name SR from dict with index. I want to modify it, so I'm going to assign it new values. Good. How? SR from dict with index. Good. Dot fill NA is the name of the function. So what do I want to tell it? In SR dot index, find out the missing null values which are null and fill them up. So this fill NA is going to find out wherever there is a missing value and is going to fill that up, all the missing values with one single data. So let's suppose in my case, I'm putting up here, let's say a missing data. So I'm putting up a text over there, missing data. Good. Deliberately putting up a text. Cool, good enough. If that is okay, then this SR from dict index, that should have changed. Let's have a look, friend. Can you now see that instead of NaN, now I'm getting the word which I've mentioned over there. I could have mentioned a number. I could have mentioned a floating point number. I could have mentioned a non-floating point number. I could have mentioned any appropriate value. How do we judge an appropriate value? That's a separate entity altogether. I'll talk about that when we have a real world data. Real world data means as in like we'll look into a tabular data and we'll talk about data frames. Then I'll talk about that too. Good. How does we find out what is an appropriate thing? It's not something that you could put up in random. Here I put up a random data for now. For example, it is used to apply a function to each element. Right? Say for example, we have this, let's say, for example, right? Let's go back up. We have this wardrobe with index, right? Let's suppose I want to see out squared values, right? So I can put up this series dot apply, and onto that, which function? So I can create up a lambda function over there. Lambda, let's say lambda x, taking up the square term. So x double star 2. I've given the function. Good. That's it. Done. Now you can see that I can see my series got the values applied with the function. So apply will take out every value from this series, give it to the function. The result of the function will be saved back, will be returned back. Are we good? So I got 4. Original data was 4. Sorry, 3 here. So 3 came to lambda. Lambda processed, calculated the square, gave it back 9. Next one would have been 4. So that would have been 16. Then 2 have been became 4, and so on. Are we good? Apply part. Very beautiful function, very useful function. And many of these functions will be repeated at the time when I'll talk about data frame. Why I'm putting those efforts here? Because with the data frame as well, when you're going to apply these functions, right, you're going to apply that on a series itself, right, at a later stage. Good. Eyes, nose, maybe, yes, please confirm very quickly. That'll help. Thank you. There would be few more functions which I would like to talk at a later stage. Now, someone wanted to talk about the index change, right? The names, right? A particular series, a particular index, right? Though we have another function called as a rename function, but since it is index, so I'll not use the rename functionality, right? Rather, I will use index. I would have to alter all the index together. I cannot alter a single index. Can't be applied condition inside apply. No, I cannot comprehend that, Narendra. You might be trying to say something. Do you want to get unmuted? If your background is clear, I am okay with that.
Yeah, so my question is like you have mentioned that we can use the apply function to process all the index. So I mean, if we want to process or made some changes for a specific index, then we can do with the help of some condition, like we can do
See,
in other programming languages.
yes, you can see conditional access of the data. I have not yet talked about how will you access a conditional data. You can apply it on any sequence. This can be apply function is specifically a series or a data frame function. So if there is a data frame, if there is a series, you can always use apply. That is the only requisite that it has, right?
Okay.
Apart from that, it contains one value, it contains 10 values, whatever it may have. You have that leverage.
Okay.
So for example, let's say I want to put it up for a particular, let's say in my wardrobe with SR with index. I do not want to do it for all the data points. I only want to do it where the data value is 3. If the data value is 3, I want to perform that action. Is that what you're trying to say?
Yeah, exactly.
We can do that. It is possible. We'll take it that example too. Don't worry. But I have not yet talked about accessing the data point based on condition. I have not yet talked about that because we need to first access the data using the condition and then move on to the application part or modification part. Make sense?
Yeah, makes sense. Thanks.
Thank you.
Yeah.
Okay. So let's move on. That is called as a conditional access. That's the next thing that I want to talk about. Accessing elements using a condition. Now, condition based. till now you have been accessing the elements using the index, right? Whatever, either you were using lock or ilock to get the data. Now, can I use that with some conditioning? So let's take an example. First of all, I want to apply a condition. I want to put up a condition. So first of all, how will I do it? Very simple thing. Take up your series and put the condition. For example, in my series, I want to find out all values which are greater than, let's say, greater than 3. Good. Just an example. Very simple thing. This is a series and I want to check out the values which are greater than 3. What is going to happen? It is going to check out for every single value, trousers, shirts, socks, every single value. So it is going to check out for every single value, just like is done. Is that condition holds true here? No. It holds true here? Yes. Not here. So these are the two values for shirts and for tie. This value holds true, where it is greater than 3. For rest, it does not. Make sense? Now, suppose now this is showing me a true false thing, but I do not want that. I want to extract that data where this condition is satisfied, right? I want to extract that data where this condition is satisfied. So what I'll need to do is I need to select that data. So I can use this condition, the same condition that I have written down. I can use that as index. I will put that condition as index and I will use the same series. So what I'm trying to tell it, look at this very beautifully. Look at this part. I have used the condition in the index, good, and that is the square brackets. So what I'm trying to tell it now, apply this condition to the series, and for whatever index, wherever you are getting the true value, select those indices and show it here. Show it from here. So what I want those, so you see it has got a shirt and it has got a tie. So shirt and tie, that will be resultant of this, and those shirt and tie values will be displayed now. Let's have a look. Team, please confirm if once it goes beyond head. What did I miss? Oh, P is there. Can you see that? Shirts and tie extracted. Once we extract that, now if you want to apply something, like let's say Narendra had that question about application. So I can take that extracted information, dot apply, and let's say I want to put up any lambda function, lambda x colon, let's say I want to put up anything, let's say x cube, let's say put up cube for that matter. Good. So it applies that function only on that data. Good. I have not yet talked about how to merge certain lists, merge the series, join them, concatenate them. I want to talk about those, but not now. I want to talk about those with the data frames. Everybody okay with this? I guess Narendra, that answers your question too. Conditional access or changing or using the apply method using condition. Any questions, team? And if you find it difficult, let me know. So using lambda here is a must. No, not exactly, not lambda is a must. You can use any function. If you have a predefined function, Abhinitri, then you can use that function too. But the point is that usually these would be kind of actions that's not fixed or permanent for us, right? We want to perform certain modifications in the data for one-time change. So usually, most commonly you will use a lambda function. Let me give you a real world example. It's a common example that I quote up to everyone, but let me give you another example. There is a very famous data set, practice data set. We will talk about that data set at a later stage, which is called as Titanic. Heard about it? Anyone? A Titanic data set. It's a row table data, right? But this is very good data for practice purpose to know about things. I will take the data into picture, which contains 891 rows, and I guess approximately 13 odd columns are there. I don't exactly remember the column numbers. 13 or 11, something like that is there. But I'm not bothered. One of the column in that consists the name of the passengers. Consists the name of the passengers. Good. Now look at this part. That one particular column is a series for me. One particular column is a series that contains name, and names are given in this order. Let's say like the first name I remember is Brown, followed by a comma, then Mr., followed by a dot, then I have Owen, and then I have a Harris. That's how the name is. First name I remember. That's essentially in the format. Suppose this is a string, right? Name is a string. So that individual value is a string, and it is of the format last name, followed by a comma, title, followed by a dot, then the first name, and middle name if there exists. Middle name if is present, I have a middle name too. That's how the data is given. Now the beautiful part is that the entire name may not be of any relevance. Let me just take up some thinking capacity. Everybody in the house is going to give me an answer. Okay. It's coming for the purpose of data understanding. It's my purpose behind asking this question is not to judge you, but to bring onto the table the perspective or the thinking capabilities that we should have as a data scientist or an AI engineer. Good. Great. My expectations for this questions is that you know what Titanic is in real world, you know, or you have seen the Titanic movie, at least either of those things. Good. Anybody who does not know what Titanic is? Okay, great. So my question is, suppose there is a list of some names. There is names given. Okay, that contains many names, right? Exactly 891 names. Good. Now, that also gives me another information on the side, that is the survive status. Let's say I have some survival status, name 1010, where 0 represent that this person was lost in the accident. 1 means the person has survived. Good. Now, think about yourself. Think from your own perspective. Completely your choice. You need not follow my choice. You can have your own option. The name, think about it. Will the name of a person, very clear question, will the name of a person has any impact on the survival or any role to play in the survival? Suppose you're supposed to predict a person is going to survive or not, right? Suppose the 892th person is Narendra. So let's say this is just a random example, good? So let's say that this person named 892nd person, right? His name is given as Shishodhya. So I'm just putting that in, then followed by a comma. Then let's say put up Sir dot, let's say Narendra and some middle name. Good. That's how the name is formatted. Do you think that it is going to make an impact? Will there be any impact of this name? Think very closely. That brings in a lot of concepts, like feature engineering is also a concept that comes out from here. There is a relevance concept. A lot of concepts comes out from this particular problem. But I'll only talk about one thing as of now, the apply method. If not the entire name, can you just think of title for a moment? Considering the Titanic has started as a ship from the then United Kingdom, where people who were living into that country were given certain titles like Mr., Miss, Mademoiselle, Miss, so on. Some people have a title like Sir, or maybe Lord, or something of great, a major, doctor. These could have been titles, right? Now the question is, will the title will have an impact? Rosie says yes, I agree to that point. Title would have may have an impact. I'm not saying it will have, but it may have an impact, right? Certain people with certain titles would have gone, the privileges, maybe. So now may not be the entire column given for me, or entire series that is given for the name is not relevant, but only the title given in that in between is relevant. So I need to extract that title. I need to extract it out, right? From the entire string, can I extract the title? Let me just see if you can help me with this. I'm putting down the one name for your example. Let me see. This is a string. The first name is Brown. Just hold on a minute. So fraud people are calling me. This is a string. Let's just check out your Python skills. What I want you to do is, can you help me to extract this name? I just want to take out Mr. from it. Help me with this. Name one. Let's name that as a variable. Though I don't want to do it. Name of square bracket one. So as per, if I go by the definition of Rosie, so name square bracket one. No, I get R, Rosie. What I need is, and R is this R, not Mr's R. Help me. Someone had asked me that question, not here, but some other batch. Need to split an index. Do it. Or should I do it? I'll do it directly. Dot split. That's gonna split on the basis of comma. I'll split on comma. I get two parts. Brown on this side, Mr. Owen Harris on that side. So I'll select that first index. I got Mr. Owen Harris as a string. Again, that string needs to be splitted up. Split. Now I want to split that on dot. So I got two parts. I have a Mr. on this side and Owen Harris on this side. I am not interested in Owen Harris. Mr. at 0th index. I got the MR, but it contains white spaces, so I can put up dot strip. Good. Now this was only for a single string. What if that single, I do not want to do it for single string. I want to do it for the entire series, because that will not have one name, that will have too many names. So I can create this entire thing as a lambda function, lambda x colon str of x, just to make sure it is a string. Good. Dot split. Good. Now this function is capable. I can use an apply function, apply this function, and I can pass on my whatever the series name is. I can put up that onto the before it. Now think about, there was one question coming from someone that essentially we need to use functions or lambdas. Abhinetri had that question, right? So lambda is must. No, it is not must. That was the point where we started this topic, right? So the idea was that I would only require to do that once. Should I need to create up a separate function that will always prevail in my memory? I want to use functions which are use and throw. I did it once, done. I don't want to reuse them. Sensible? Thank you. Where I was. Okay. Apply, done. There is another thing that you can use is a sorting function. So let me just show it up with the sort part. So let's bring up our series once again. That is wardrobe with index. Git. If you look at that, can you find it that my data is arranged in a sorted manner? So I have two choices. Listen to that very carefully. Choice number one, whether I want to sort as per this, either in ascending or descending order, right? Or I want to sort on the index, again ascending or descending. Good. Again, please remember, ascending and descending in terms of text means the alphabetical order, right? From A to Z is ascending and from Z to A is descending. So please remember that. Good. So let's try to do this. So we have two types of sorting. Sort a series. Good. One is a series sort with respect to the values. So let me just show you. So if I do this wardrobe with index dot sort underscore values. So name of the function is sort values. Using values. Good. Let's name that as, okay. So name of the function is sort underscore values. That's the name of the function. So sort underscore values will allow me to sort the series in, by default it is ascending. So look at this. I got that into the ascending order, the values 1, 2, 2, 2, then 3, 3, then 4, 4, and corresponding indices have changed, right? Indices have moved, right? So it's not that I have got 1, 2, 3, 4 index will remain consistent. No, it's moved along with the index. Good. What if I want to get that into descending order? So what you need to put up here is, in the same sort values function, put up ascending is equal to false. Take up a parameter, ascending, ascending, put that as false. So I'm telling it is not ascending. I want to go into the reverse possible manner. I got descending. Good. So if I'm sorting it up and I want to sort it up in ascending order, I do not have to put that. By default, it is true. So I can avoid that. Or if you want to put that into descending order, put up ascending is equal to false. Are we good? Yes, no, maybe. Thank you. Let's have a same look at the series. Sort a series using index. So I now want to check up the sort values in an index form. Name of the function changes to sort underscore index. That's it. You got them sorted up. The index are now sorted up. You can see that B is on the top, W is at the end. Correspondingly, the values have changed. Shuffled. Good. Same thing goes for the using index, descending order. Sort underscore index is the function. Good. When I put ascending is equal to false, I get the data in descending order of indices. Is that good till now? Thank you very much. Okay, I think so. That's more than sufficient for series. Let me just think of. Asif, keep that pending. Keep that pending. I'll come back to the example again, right? Because when I'll start with the Titanic data set, I will bring into that picture again. And to be very precise, it's happening because the basics of Python is not done. Ease of doing things with regex is quite complicated as compared to doing with pandas. Basic logic. Suppose I have two series. Let's say SR1 is not SR1. Let's put up series 1 is equal to np.series of 1, 2, 3, 4, 5. Good. And I have another series, series 2. That contains 1, 2, 3. Let's say put up 7, 6, 1. Good. 3 elements only. That's series 2. Now, you guys have seen element-wise additions before too, right? So let me just have a quick look. NumPy has no, oh, not np, but pd.series. My bad. Good. We got two series. Now, can you tell me what could be the expected output if I put up series 1 plus series 2? Essentially, if you look at it, this is one series that you have. Good. It has index 0, 1, 2, 3, and 4. Good. that has a value 1, 2, 3, 4, and 5. Good. You have another series here, right, that has an index 0, 1, and 2 containing value 7, 6, 1. That's the position right now. What is going to happen? Let's give that a look. I have not got any error. It worked. So the I'll tell you what is the logic that I want to tell you. Whenever two series are being added, they are not concatenated like arrays. They're not being concatenated like lists. They'll not concatenate like list. What is going to happen? It will check for the matching indices. I have a 0 here index. I have a 0 index over there. So matching indices will be added up. 1 will be matched up with index number 1. 2 matched up with index 2. For index 3 and 4, there is no match. So since there is no match happening, put up as nan. It will put up a nan value over there or a missing term. Are we good? So if there is no matching index, for example, if there is no matching index, what's going to happen? Suppose here, I'll just put up index is equal to, let's say, ABC. Now if I do it, it will take up index 0, 1, 2, 3, 4, 5. No problems. None of the matching terms, zeros. It will fill up with nan. Again, ABC index will also be considered. So I have indices 0, 1, 2, 3, 4, and as well as ABC. All indices from both the series are included. However, there is no matching indices, so none of all the values are filled up with nan. If I put up, let's say this index is 2. So AC comes in, 2 value matches up, index 2 matches up, so index 2 has a 6 and index 2 has a 3. 6 plus 3, 9. Good. Last function. Map. What is the role of it? Is data type always float? For nan, yes. Nan is always float till now. If there are any modifications in the fundamental definition that happens, then I cannot assure you, but because there have been certain, updates wherein people have recommended or asked for a PEP, right? Everybody knows what is PEP. PEP is Python enhancement program. It is Python enhancement program. So it's a kind of document that is created whenever there is any kind of update into Python or any Python libraries. So it is all whenever there is a version of Python that is released or any libraries, the PEP is always released with that. So it's a document. So there have been certain things about changing the float, the nan to float, because there is It's explicitly taking up too much space, but that did not materialize yet. So I was talking about map function. Now, map is used, it is used to alter, right, values using key value pair, using dictionary. Now, essentially, the idea is, listen to that very carefully. We'll take this series 1 into consideration. Good. Let me just print series 1 again. It's important. Good. Now, here you see that I have three values 1, 2, 3, 4, 5. Let me recreate it. I want to change it slightly. So I wanted to keep it as 1, 2, 3, 1, 3. Good. That's how I want it. Now, my objective here is that if in my series a value is 1, I want to change the word from numeric 1, I want to change it to ONE. If it is 2, I want to change it to TWO. And I'm not telling anything for 3. Good. So how can I do that? I can put up my series name dot map, and within the map function, I can write down a dictionary and tell it, if you find 1, please change that to ONE, comma. So my key is 1, value is this. Second key, if it is 2, change it to TWO. So I need to mention the value, the key here as the values of my series, and the value of my dictionary should be the value that I want to change to. Good. Look at the outcome. So wherever I had 1, I can now see ONE. Wherever I had 2, I can now see TWO. But for 3, I did not give any definition. So it is replaced that 3 with NaN. Any advantage of this? Suppose there is a millions of data. Let's say there is a 1 trillion row of data points, right? Out of that 1 trillion data points, there is only, let's say, 30 data points of type, let's say, type A, and 20 data points of type B. Good. Now you do not want to look at remaining things. You are only concentrated onto these 30. So you want to just cut short your data. What you can do is you can use a map function, put up a particular words for them, and convert rest to NaN. Rest NaN means they got missing. Good. And by that you will be able to access the data only with A and B, because when after that, when you run the is null part, it is going to be true only for the values which are present, which you can use as index and check it out. You will get only the data which is containing the values that you're looking forward to. So you can always alter that information and get the information of your relevance, your choice. So map is very beautiful function that you might want to use. You would have used a map function in Python as well. So that map and this map is different. Okay. Python map function is used to map a function to a sequence. This is a map function. This is a map function of series that is used to map values as dictionary. Good. Hopefully. All right. On that note, I'd like to switch to DataFrames. second data structure. Now, why did I put up too much time on the series, though it was not supposed to be that long? Okay, so we are talking about data frame. So what is a data frame? Simple definition of Pandas data frame is a two-dimensional. I will not get too much into theory part. Pandas data frame is two-dimensional tabular data structure that contains rows and columns. So no need to mention that, right? Tabular data structure, that means it has a, it is one of the base, or it is the primary data structure that is used to handle and manipulate data. To handle and manipulate the data. Now, to be very precise, if you talk about real world data, essentially you might get or see the data that is being stored into different database servers or different data storage devices in multiple forms. It can be in 2-dimension, it can be in 3-dimension, 4-dimension, or a huge number of dimensions, because they have their own space constraints. They want to efficiently manage the data. That is a separate thing. But essentially, when you have to work on a data, right, you have to do some data handling process. It's quite complicated to do it in more than 2 dimensions. It's quite complicated to apply things, analyze things when it is more than 2 dimensions. Really difficult. So when we need to handle the data, we prefer using it in 2-dimensional measure. At least as a human being, it is easier for us to understand the data which is in 2 dimension rather than 3 or 4 or multi-dimensional data. Good. So that is the idea behind it. That is why we try to extract, or what does the Pandas data frame offers is to work on the data in a tabular form. That means I get a data in the 2D form, 2-dimensional structure. And that is what we can make it up from here. Again, it supports a lot of things. I'll not talk about those. A data frame can be created using the data frame, can be created as an object of Pandas class, and name of the class is data frame, right? Or by reading external data sources. Data sources like CSV files, like CSV or Excel, HTMLs. You can read out XML. You can read out maybe a Parky file. You can read out SQL queries, etc. There are plethora of types that are supported. I will not talk about all of them. Essentially, in this particular course, we are only going to work around with the CSV files. That's the major file that we're going to work around, right? So I will concentrate only on the CSV part. Good. Thank you. So let's now quickly run through with this, and we will create up those things from here. Good. So let us create data frame using list. Now, essentially, we do not actually use list anywhere. We always use a dictionary. But I can create up a list too, but that will look really complicated to you guys, right? So I'll create it from the list first, right? Suppose I have 3 employees as an example. Good. So let's put up a data. This is my data list. That is a list. Good. This list contains information about 3 employees. First employee names, again a list in the set that her name is Alice. comma. Let's say her age is 25, comma. Let's say her salary is 50,000 USD. That's the first employee. Let's take up second employee. Another list. Let's his name is Bob. Bob is 30 years old and earns $60,000. Mind you, it's annual. Third employee. Let's take up Charlie. Charlie is 22 and earns 45K. Good. So that's a simple data list. Now, think about how would I like to represent this data. What I would love to do here is, listen to that very carefully, that I have a table like this, wherein I have a column header called as name, let's say age and salary like this, column headers. Then I have row number, some row number 0, row number 1, row number 2. And I have Alice, then Bob, and then Charlie, 25, 30, and 22. And let's say 50K, 60K, and 45K. Like that, figures like this. And will that look good? So if you look at this, these are the column headers. These are the column headers. If I consider each of them as columns, these are your column headers. And if you just try to concentrate on the thing that I am putting up in blue, does that by any chance to you looks like a series? Yes or no? Right? So essentially, if you look at this, if I consider this as index and this as data, so this is one series. You can say this along with this is another series. This along with this is another series, correct? Or I can say that every single column in itself is a series. Yes or no? And every column has, I would like to put them a name. So here, just like series, we have the labels, but I have two types of labels now. One is the column label and other one is the index label. Are we good? Great, thank you. So let's just try to create up some labels for the columns. Index, we know we have default. I just want to put up some label names. I can go with the default column labels as well. That is 0, 1, 2. But let me just put up some names for this. So let's put up columns is equal to, let's say the first column name I want is name. The second column I want is age. So I print another list. Third column I want is salary. Good. Let's create up another thing, which is IND. Or let's put up as IDX. That is for index. Let's say EMP1. Just wanted to mention EMP1, comma, EMP2, comma, EMP3. Good. We have 3 employees. So I'll take up just that. Now I can create up a data frame out of it. Let's say df1 is equal to pandas dot data frame function or data frame class. So it's constructor being called up. Great. And I'll pass on my data list. Original data, comma. Now, just like series, I have the 2 parameters over there. In series, I had 1 parameter for index. Here I have 2 parameters. One is for index, other one is for column headers. So I can put up columns is equal to columns. Let's name that as, change that name to CLMN. Yes. Why did I change that? So that you guys do not get confused. What is an attribute of the class and what is the variable? So CLMN is the variable. And I can use index is equal to IDX. Good. Let's have a look. Done. Now I'm going to show you DF1, right, in 2 forms, right? Let's look at the first type. I am using the print function and I'm putting print df1. Can you see it? Right. You can see that it looks like a table. I have the column headers name, age, salary, the index emp1, emp2, emp3, and I have the data in between. Correct? Now, the purpose of data frame, right? Okay, let me ask you, what is the purpose of print? To get the output, to display a value. Okay, let me just ask it. A very simple basic question. I usually ask that in interviews. If I write down, let's say, a string, good, and I execute, I have not used print. I am able to display that data. Or if I write down print, and then I write down the same thing, putting that within the print function, I still see the same information. Is there any difference? If yes, what? In both the scenarios, display the value is happening. "93 and 94 are two lines you can mention. There is a huge difference, Abhinitri. It gives data and string. Both are strings, Asif. So output wise, there is no change. Okay. How many of you know about the print function? Comma is main difference. No, that does not make sense. Let me tell you. If you go out and try to look at the syntax of print function, it has few parameters. Look at this. The parameter I want to talk about is file, which is set to none. But if you look at the details, it says file. A file like object or stream defaults to the current STD system standard output. So essentially what is happening, when I use the print function, this thing is going to get saved to my standard output device. That's the default value. And I have the leverage, I can change it. I can pass it on to a printer. I can pass it on to my memory device, wherever. If I want to save that, I can pass it on to my memory as well. Do you want me to show that? Okay. On the left of my screen, I'll just show it very quickly. I'll do that. Do you see this is my latest files that I've created. Last file is your file, which I'm working on Pandas about 1 minute ago, that has been saved. Let me, if you just to showcase, I'm resaving that file. That should change in a short while. Let me refresh. So you can see that 6 seconds ago. So it was saved 6 seconds. So do I have any recent file, any notepad file in here? No. Great. I will just put a few messages above it. Let's say open. Let's name that as you, or let's say the question. Let's say I name that as today's date. Okay. So let's name that as date. underscore 07 022026 dot txt. So I have opened up a text file, comma, in write mode. So I'm going to write down on this file. That is going to be W plus. Good. Great. And then I'll put a print Jitendra, or let's put up anything else. You might say that you might have pre-formulated that. So any string of your choice. So any string of choice good, deliberately not making it wrong, right? Any string of your choice, good. And comma, now I am redirecting my output. File is equal to, let me open that with a variable name, f is equal to this, good. So file is equal to f. And just wanted, once this print function is done, I want to close that file so that it gets saved. So f dot close. Keep an eye. I execute it. There is no output. The print function is not showing anything on the screen. Why? Because that thing has now been redirected to a file that should be here. Can you see this? I got the file date 07026, and if I double click and open it just to verify, any string of choice, that's what I written down. Now don't lose the context. Why did I come up to this point, right? Don't lose the context. So context was, I'll just remove that file. I don't need it. I have too many files there, highly cluttered. Hold on. All right, so let's come back to the point. Just give me one. Okay, sorry for that interruption, team. My kid just arrived. She wanted my phone. She's just back from the school, so no problems. Thank you. So that was the objective. Now, getting back to the context, what I wanted to convey here is that if I use a print, right, that gives me a different answer. Let me just put that into a comment so that maybe you guys might want to use it later on. So if I use a print, that redirects my output to the output console, whichever output console that I'm putting up. But if I do not use print, the value that I see is actually the last known input. It's just showing me the last information that it remembers. So only the things that is there, right? So if I put up another string below it, let's say ABC, it is not going to show me Jitendra because that's not the last thing. Last thing in the memory event was ABC. So it is only showing me ABC there. Sensible? Thank you. So that is the difference. Now, when I do a print, now this is a very small data frame that we have, right? It's a very small data frame. So it's kind of, okay, you can do it up here, no problems. But imagine terabytes of data. For example, consider a file, a data set that is of 1,000 rows, only 1,000 data, 1,000 rows containing 3 columns. Let's say I have an employee, 1,000 employee data. Now, if I think of, let's say I'll redirect to a printer, I would redirect that to a printer. What is that going to do? It is going to print out the table, correct? And if that happens, that's a complete wastage of paper. I would say that. Why? Because the purpose of creating the data frame is not to take a paper output, right? It's not to take the paper output or any kind of output. That is not my purpose. My purpose is to analyze that data, to view that data in efficient manner. So essentially, whenever there is a data frame, if you try to view the data frame using print, you would see this kind of structure, right? But if I do not use print, I get this. Now tell me which one is better, the one with print or one without print, right? The second one with print is better for Asif. So if you feel that comfortable, use that, no problems. But essentially, this, according to me and most of the people that I have trained so far, the number would be more than 10,000, maybe 20, approaching 20, maybe. This structure looks much better because it's more tabular, more formatted kind of scenarios that I can see. Great. That looks better. So I will use this formatting. So whenever now onwards, till now you would have noticed, if I have to do any printing or showcase any data, I have always used print, and I will continue doing that. Only with the data frame, I will not do it. Good. And my own reason is that I just wanted to have a look. I do not want to print that out. Great. Thank you very much. So that's how a data frame is created using a list. Or you can create that using a dictionary too. Same information I'm going to take up as dictionary. So you can simply understand that I can convert that to an array form. Let's say using array, I can make that as np.array of this data. Same information, no changes. The rest of the things will remain same. Invalid syntax. Oh, I have this. Good. Let's say make it as df2, and I'll display df2 here as well. So just add that line too. So you can see the same information. Good. That's an array. So list and array wise, there is no difference. Let's go to the dictionary form. There is subtle change. Create data frame using dictionary. Now, and when I'm going to define dictionary, the dictionary formation changes, right? The data dictionary. That will not be like this. It will be like a dictionary. So I'll have a curly brackets at the beginning. I have a curly bracket at the end. Good. And this is not going to look like this. It is going to look something different. Why? Because I would have a key value pairs. The first key that I have is name, right? For name, I have a list of 3 values, right? I have Alice, I have got Bob, and I have got Charlie, right? So first key name that has 3 values, Alice, Bob, and Charlie. Second key, let's put up age, that has 3 values, again colon, 3 values. I'm putting that as a list. So Alice was 25, Bob was 30, and he was 22, comma. Third thing I want to put up is salary. Colon. And let's say I had that 45,000 or whatever the number was, 50,000. So there is just random selection team. You can put up any value. 45,000. Good. Now, I do not need these column names. Why? Because these column names are already captured in my dictionary indices or dictionary keys. So essentially, when you were creating a series, the keys of the dictionary were your index. Good. That were your indices. But when you create a data frame, the keys of the dictionary will become column labels. The keys of the dictionary will become the column labels. So I do not have to put up the columns. And I'm going to avoid index 2. I'll explain you why. Good, I got the definition. Now, I'll tell you why did I not use index here. I have used EMP1, EMP2, EMP3 earlier, but now I did not. There is a reason behind it. The reason is this is again a small chunk of data, right? In small data, it is possible for me to put up those names. Let's imagine I'm telling you, just not take up a very small, medium, not even a, take another small data that contains data of 100 employees. Would you like to write down EMP1, EMP2, EMP3, EMP4, EMP100 as a list and then put that as a index? Would you prefer that way? You would not. So when we create a data frame, right, using methods like dictionaries, arrays, or anything else, right, we generally do not put up the keys or put up the indices. Generally do not. If at all there is a requirement to put up the index at all, right, usually what happens is, what we do here is that, because at real time scenarios, what you will get is a data, right? You will have, let's say, a CSV file, right, that contains comma separated values like this, or you have an Excel file, right, that contains row 1, row 2, row 3, row 4, like this data. Good. Let's say this kind of it. You will take this data and one particular column, any particular column, you might want to put up as an index. Correct? I'm still not saying that you will take that as an index, but you might want to. Suppose I have a column already present in my data. I have a particular series which is already present in my data, given data, which is talking about, let's say, employee number. I am not going to create that manually again. Rather, I would like to use that known number as an index if I want to. Sensible? So we have facility, while reading data from an external source, I can choose out which column of my data is going to be the index if I want to make something as index. If not, then I have the choice to remain stick to the default index. Usually we remain stick to the default index unless there is a requirement. Get? Let's keep up for the last topic for the day. Right. So in order to read the data from an external file, right? So Python offers, let me just put up, Python has, not Python, but Pandas has a standard syntax to read any type of, to read rather many types of external files. I'll tell you the list, external files. And that generic syntax is, now understand it, it's generic one. So pandas dot the word read followed by an underscore. Then there is a file type based word followed by pair of round brackets, path to the file. So that is how you can read it up. That's the generic idea. Now, there is a very common question that people ask me. What is that path-based file, so and so forth. So I'll talk about that. Just give me 1 second. Let me complete this piece of code. Mhm. No, it's not taking up. No problems. I'll put that as a raw text. Okay, that's the way. Great. So now when it comes to what kind of files it could read up, let's have a look. I'm going to show up. First of all, let's say I want to create first data frame, any data frame from an external file. So I am not telling you what type of file I'm reading, just showing you what types of files are available. So pandas dot read underscore, and I press the tab key on the keyboard. I press the tab key and you can see that it can read from a clipboard. Let me just redo this. Tab space. Okay. I can read it from a clipboard, CSV, Excel, a feather file, an FWF file, GBQ file, STF file, HTML, JSON, then ORC, Parkey, Pickle, SAS, SPSS, SQL, SQL query, SQL table, Stata table, and XML. These are the all possible files that can be read out in pandas. Are we good? But what we want to read out is a CSV file. So I'm going to use CSV file, and I would have to put a path to the file. Good, here. So let's start up with first file. I'm going to send across a file to you guys into the chat. Okay, I had a one personalized message, so I was responding to that. So here, I was just, okay, I want to put up a file to you guys. So which one would you like to start with? I have 3 major files that I would like to work with you guys as a part of code. One is Titanic. There is a house pricing file, rather 2 different house pricing file, and then there are some more that is relevant to tips, and then there is a lot more files. But let's bring into the content from Titanic perspective. This file may not be available in your standard documentation, so please make sure you have it from here. I am sending a file by the name titanic.csv. Is that into the chat? So click on that folder icon onto the left side. You will have that on Colab environment somewhere bottom, right at the bottom you might have it. Click on that. You will find there is an up arrow, correct? You need to click on that up arrow. It opens up the file browser. From that file browser, find out where did you download that file. So I've got this file over there, Titanic, good, in my downloads. You might have it somewhere. Click on that file, click on open. Now, if your current working pandas file, or the Python file that you have, and your data file that I have just asked you to upload, they are into the same folder, you will, they are already present into the same folder, you will see that overwrite message come up, because I'm working in the same folder, I'm working in the downloads folder itself. So I will overwrite it. Not a problem. Otherwise, what you will see here into the list here, you will notice that Titanic.csv has appeared up. Correct? If you're not able to find it, just arrange your data on the modified date. So you will be able to see that. It will come up on the top. Or we'll go reach out of order. Confirm, done. Great. Now, close that folder box so that you have some space. Click on that again. Okay. Now, in this place, I am going to mention full file name since I am reading CSV, so Titanic.csv file. Good. And I'm going to save this as a data frame by the name Titanic. Now, this should work perfectly if your current working file, my current working file is pandas adsp b1jan.ipynb, and my Titanic file, they are in the same folder, same place. You can take a look by clicking on this icon. I can just show you that both of them are in my same drive. This is the pandas adsp b1 file which I'm working on, and this is Titanic. They both are in the same place. So I can directly read that file. Good. Execute it. That should work.
And with that, we have come to the end of our full course. If you have any doubts, let us know in the comment section below. Thank you and keep learning with Simplilearn.